Искусственный интеллект больше, чем просто технологии.
AI is more than just technology. It is a technology that would assist humans. AI helps to save the cultural heritage, create new technologies, and be creative and at the same time stay focused on ideas. It helps to research and find new patterns, to learn, to teach the new things that were unknown before, and to inspire. AI that helps you. Deputy Prime Minister of the Russian Federation, Dmitry Chernyshenko. Senior Vice President, Head of the Technology Development Bloc, Andrei Belevtsev. Good morning, friends. It's our third day of the conference. I think it's the most important day of the conference because we are going to talk about science for the entire day. My great pleasure to welcome you all. Very good morning. Yesterday we talked about businesses and technology solutions for the businesses, and we had a business AI application awards, and we had our first science-related award. And today we're going to talk about how our research helps us to achieve AGI and how AI can help other scientific fields to be more innovative and to have disruptions. You remember that this year the Nobel Prize winners received their prizes thanks to the developments in AI. I don't know whether it's the right thing to do or not, but maybe we'll have a special AI category in the Nobel Prize. This year we opened a dedicated AI center for science. It will develop technology platforms for researchers, and AI will help in chemistry, physics, biology, and other sciences. It is my great pleasure to work with you on this project. It's great to see young people here in the audience, because today we are going to have an award ceremony for the best for the young scientists and for the best scientific paper. NeurIPS is a top conference in the world, and 17 of our papers are represented there, and many of our guys are participating in this conference, which testifies to the fact that we are world-renowned experts, which says that people want to continue to cooperate around the world in AI, and we have 140 A with asterisks articles. Our contest was visited by 1,500 people from 23 countries. I would like to welcome you all again. Mr. Chernyshenko, I think you've been with us for every AI journey. You have been inspiring and supporting us, and you are the leader in AI, especially as it goes for the science and as it goes for the talent, especially the young talent that we see here. I would like to give you the floor and to welcome the guests and to see how do you see the future. Thank you very much, Andrei, for these kind words. I would, though, like to say that Mr. Gref is the one who really inspires this fantastic conference, the AI journey. I see that the agenda is growing. Everything we discuss here will be put in data sets that will be used to train the model. So please make sure you are responsible in what you're saying. Anyway, 190 countries, 150 million views. So please make sure that you share the information about us and about our conference and about our shared values. And I do thank Sber for this opportunity and for organizing this venue that helps to enlarge our network. Yesterday was a very important event that happened, that made publicly available. Yesterday, the International Alliance on AI was convened with the participation of the President of Russia, Vladimir Putin, and it was visited by the representatives of 15 countries. Very high-level officials from these countries were present, and some of them are present here today. Thank you very much for your involvement and your commitment, because I am confident that AI, as any creation, should have a cross-border nature. We should be able to communicate and to discuss things openly without any politics, because we have to take every opportunity to improve the lives of the people and our constituents for the better. Now, it's Friday 13th, but I don't think there's any superstitions here. Superstitions are for some other people that do not discuss science. Mr. Gref, as he always said, that if you try to tackle a challenge, you have to make a as-is review of the current situation and to assess the situation, to make sure that you are mindful in terms of trying to understand the result that you are trying to achieve. We see that the AI race is becoming more and more acute. AI is the main technology of the 21st century, this buzz phrase that we've heard everywhere. Why? Because AI is disrupting the financial sector. AR and VR is disrupting the in entertainment business. AI is disrupting all the areas. It's hard to think about a sector where AI does not disrupt, going from agriculture, mining, education, healthcare, and many other sectors. If you can think up an industry where AI is not applicable, please raise your hand and tell me, because I wasn't able to think about that. Our neural networks will deliver fantastic results. In the first day of AI Journey, the President of Russia, Vladimir Putin, puts a very high ambition for Russia to become a world leader, not only in terms of developing AI, but applying AI solutions in all areas of our lives. And we understand that the use of AI, and the President mentioned that, it's very important that he highlighted this feature of AI from this large volume of information that he had to absorb during this conference. And he said that the use of AI, the AI applications, will give the citizens of Russia the opportunity to understand why this or that solution was taken. These solutions, the decisions by decision makers have to be transparent and understandable, interpretable. It's very important that the AI applications will have this functionality, and obviously processing applications and questions for the final Q&A session with the President. Applications are now processed by GigaChat, and it helps to crystallize the tasks, the concrete tasks for the dedicated ministries, specialized ministries, and the government of Russia. So that's a real use application, because obviously no amount of specialists and operators will be able to categorize all the questions and applications manually. And it's very hard, would be very hard for them to understand what is the top priority for the population and what the authorities should focus on. I think that this approach will radically change the efficiency, including the efficiency of the governance and the speed for responding to the needs of our people. Another important area, when you try to start a program, you want to launch a program, you have to analyze the best practices. And in AI industry, there are leaders like giant companies. NVIDIA controls from 75 to 90% of the advanced chips for the AI. And we've seen that in the last 5 years, the growth of NVIDIA was around 1,000%. X24 all are trying. OpenAI is one of the leaders as well. We see new products, Lesoro. Everyone is trying to challenge this leader. Now, Lesoro published the tools for video generation. Now the competition is becoming harsher. The Huawei hardware is being used more actively, and the alternative computational tools are being introduced, and these are the open source model as well as the commercial models. It closes the gap between them and the leaders. To close this gap, you need a lot of investments, and investors already show impatience because they want to have an ROI, especially if you're talking about the initial stage investors, but you have to continue to invest. The Chinese companies are challenging these leaders because China is one of the leading tech communities in the world, and Minotech Cooley on Collective Forecast closed meeting in October this year said that there are alternative approaches in terms of improving the availability and accessibility of the AI solutions to the people, making the models cheaper and smaller by changing the data structure, moving to expert models from general models that will be dedicated to some industries and professions. The national strategy of AI development in Russia that was updated in February this year, and it was approved by the decree of the president, has a number of KPI, and the key indicator is increasing the GDP with AI by 11 trillion rubles by 2030. The overall increase of the GDP with AI might amount to $15 trillion. So that's a huge volume, and we have to take a part of it. And the volume of the Russian LLM market for the businesses is 35 billion rubles. That will be the amount by the end of the year. That's a pretty good head start, and we see that this indicator will grow twofold, according to the analysts, and it might give you an additional 4% of the Russian GDP. The solutions of the leading Russian AI companies like GigaChat Max or Kandinsky from Sber or Yandex GPT for working with text and multimodal Yandex Art solution are world-renowned and recognized solutions in terms of the reviews of the developers and in terms of their quality, and they will continue to play a very important role in addressing a major challenge that our country is facing right now, and this is the lack of talent. This is especially important because in October in Russia the unemployment went to record low 2.3%. These are the data of our Russian Statistic Agency. And in Russia, we focus not on replacing humans with AI, but we're focused on improving the productivity and performance of every Russian worker. In the future, every Russian citizen, and I'm confident that this future will arrive sooner than many of you think, should have their own squad of AI agents that improve their performance and productivity and helps in everyday life. I am actually creating my own personal squad of AI assistants, and even if you work in the government, you can do that. Obviously, I'm talking about the trusted segments, the secure solutions, but I know people who are using that every day and in their everyday work, and that improves their productivity. So it is possible, and there are two reasons for that. First of all, historically, Russia had one of the highest level of education, and that includes awareness of all of the advantages and the products that AI offers. We are one of the top 5 countries in terms of the number of countries with the largest share of educated population. Higher education, I'm talking about that. More than half of the people know about AI and its capabilities. Every 4th citizen is using generative AI, and every second, meaning 50%, are using Russian AI solutions. A second reason are the readiness and the commitment of the authorities to implementing AI. I would say that no country in the world has the president who knows that much about AI. He knows all the details. We see that Vladimir Putin is very engaged in the topic and knows about the details, and we provide a report after the every AI journey with a KPIs and goals and tasks and a specific roadmap, and you have to meet these tasks, you have to deliver on them, and this encourages us to work very hard. Russia is investing a lot in AI development. I would talk about the common and unified AI research program. I mean, when all understand that AI has become an integral part of science, because I mean, in the government, I supervise everything that is related to the civil research and civil sciences. I supervise the development program that unites all the investments in science, and this is a major investment in AI, increasing the helping to intensify and support our scientists, and we're going to step up the efforts there. In the next several years, we're going to increase the AI investments in AI research. According to the order of, to the decree of the president, the government has a number of tasks. First of all, 5% of the state budget for the science is going to be sent to finance AI research. Secondly, 15% of the all state expenses for science are planned to be directed to the research in other areas, but these research efforts will have to be AI-driven. 15%.
And now let's remember the goal set by the president by 2030 to increase investment in science and research up to 2% of the GDP. Look at the forecast of the Ministry of Economic Development by 2030. Take 2% of it, and then 15% of that. You will get roughly 650 billion rubles allocated to science and research with the use of AI technology. This is a very ambitious goal, and scientists across the globe, I think, should keep that in mind, because if we're going into this must have a really good purpose. We are currently building a joint program for research in AI with key domains and research objectives for the nearest future. There are 10 fundamental domains with 37 subdomains and 127 research objectives. This is a great academic undertaking, and the Ministry of Economic Development, the government, and the entire academic community were working really hard throughout last year to identify these priority scientific tasks. As I said, 15% of all funding will be allocated to that, to achieving those objectives. In the first months of evolution in GenAI, we learned that AI can rewrite technological processes in all areas. It helps us analyze big arrays of scientific data faster and generate scientific hypotheses faster. But more importantly, it essentially broadens the horizons of the possible, and it helps us model processes which we could not model before. For example, processes in distant galaxies or on the molecular level. Obviously, AI is already an integral part of science, and Andrea already said that 2 Nobel Prizes in physics and chemistry went this year to the founders of this revolution in AI, specifically for creating AI-based models that predict the structure of proteins. Mr. Grev has recently said that 80% of all scientific breakthroughs across the globe are done with the use of AI technology. And clearly, Russian scientists are also contributing to the successful innovation in that area, for example, using AI technology to develop drugs and medications or to forecast different natural events. ITMO, MIPT, Innopolis, MSU, the Blochin University, and many other major centers of competence. Artificial intelligence is not only broadening the realm of the possible, as I said, but it also significantly reduces the cycle, the time from fundamental to applied research. According to the estimates of various researchers, in material studies, the number of patents went up in a year by 39%, and the number of innovations in products increased 17%. Those are significant figures. It is no wonder that artificial intelligence has intensified collaboration between business and science, not only when it comes to co-financing of research, but also in relation to this interesting and fair trend. We are observing the hourglass turning upside down, so to speak. Erstwhile, it used to be 30% of investment in science and the rest in business, but now the extra budgetary investment of the Russian business into science is going to exceed federal investment. So it's not only in terms of co-financing, but also in terms of data exchange and competence exchange in AI modeling, piloting in real time and in an actual environment. Our universities are opening access to their latest innovations, their latest models, and organizing multidisciplinary campuses. Yet another function of science is science can become a sort of an arbiter, a tertiary judge for different models and objects, showing accuracy and precision based on experiments. In the context of intensifying competition in science and research, it's very important to make sure that AI is free from bias, from political bias in particular, and to make sure it is open to all kinds of hypotheses, even if they are not mainstream. As the president said, it is important to create a sovereign AI, important for science primarily. We need to build our own Russian datasets or datasets in the countries that share our values. It's important to make sure that AI knows our Russian school of thought, not only along the frontiers of our scientific and research development, but also along all academic lines, in all academic areas. Which is why, right now, together with Sber and Yandex, we are working to make sure that all the digitized research labs and research centers which are currently part of the science and technology domain be used for training our models. So that when we propose scientific hypotheses, artificial intelligence would base decision-making on our data. Furthermore, if AI is trained only on foreign data, it may even be dangerous because it is not wary of the Russian context. Because it might so happen that at a critical point in time, there is some critical hallucination, or it mixes up dimensions or engineering standards and makes a wrong decision. Not to mention the ethics and worldviews. The creation by business of datasets for science and research is an evident win-win for everyone. A good example, one of the examples, is the pharmaceutical industry, a societally important area. Many companies across the globe are venturing into it, and the president has also said that access to high-quality drugs and medications is extremely important. Students could help science and business with data labeling, and business will also get native talent, native personnel with AI skills, with the ability to use AI in different cases. 5% of financing, as I said, will be allocated to develop fundamental domains in AI, as determined by the academic community. This list, as I said, is built during the foresight in science. We presented it in the spring of 2024. And to make sure we are abreast with any changes, we will be organizing these foresight sessions regularly. This will allow us to prioritize academic objectives as part of the national program. We have already built this foresight set for 10 fundamental domains with applied domains defined separately. I don't know if you can read them on the slide. I won't go into detail there, but nevertheless, the outcome helped us formulate these scientific objectives for today. We need to speed up the creation of more accessible, less expensive alternatives to GPU by NVIDIA, including high-speed networks for data exchange between microprocessors. We must create assistants of a new generation that are capable of self-reflection and self-criticism. We also need to work on fundamental models for different industries and areas, new models, new economic models that factor in the staff deficit in various professions. So AI must transition from being a black box to something that is explainable and interpretable, to avoid a situation where AI is abused as a tool for manipulation. And our long-term mission is to cultivate national champions across all of these 10 priority domains. And right now, dear colleagues, I suggest we participate in this interactive exercise. I would like the organizers to show the QR code, which you can scan with your phones. The analysts have placed these 10 domains on the hype curve. Could you put that back on screen, please? So if you scan the QR code, thank you for showing it on a separate screen, by the way. So we have two questions for you. Which technologies do you think will be the most beneficial in the next year? You can select 3 out of the 10 we suggested. We will give you 15 or 20 seconds to vote. Please let me know how the voting is going. If you're watching us online, you can also join in. Please make sure those watching the webcast can also scan the QR code and participate. Thank you very much. Hopefully we were able to hold this voting with no technical issues. And now the second question. In which technology do you think we have the biggest number of scientific problems that haven't been solved yet? Once again, please select 3 out of 10. I'd like to ask the organizers to create this overlap between the slide with the hype curve and the slide with the voting results. I'm really curious to see how the audience voted and whether their position coincides with that of the experts. And now let's talk about the International AI Foresight session. We are broadening horizons. Thanks to Sber support, we were able to welcome new members to the International AI Alliance, primarily the BRICS countries. By 2025, we are planning to launch an international scientific foresight to work out joint academic priorities together with our AI partners over the globe. We also want to create a mechanism for selecting the most relevant and the most labor-intensive and resource-intensive research in AI. Clearly, the joint efforts of multiple nations towards the solution of AI-related problems will significantly accelerate technological and scientific progress. A good example, a good case illustrating it is our LLM that we are developing. For mathematics, we are leading across the world in that regard, and China simultaneously is working on an LLM for the economy. We are looking forward to see how it turns out. We invite all of the BRICS countries and the whole international community, anyone who's ready to contribute to these efforts. I know that today we will hear a lot of presentations by renowned scientists with a citation index up to 8. I know that Svagadam Das is going to participate. Really looking forward to his presentation. It is important to distribute tasks related to AI among ourselves because we all need artificial general intelligence, but not just any AGI, but the one that shares our values. As for the AGI expectations and forecasts, as President Putin said on this stage 2 days ago, our direct responsibility is to participate in the global AGI race as a strong player. Most definitions are similar in that AGI is an AI that is equivalent or exceeds human intelligence in a number of domains and a number of tasks. Thanks to the capability to analyze big arrays of data and promptly adapt to the new environment. And by the way, AGI can be trained on a small dataset. So all that will help us tackle global problems, global challenges. And primarily, since we are talking about science, it will help us tackle complex scientific problems. It will also significantly increase the launch of new products and technology. As for the forecasts, as I mentioned, forecasts are different. According to Hype Cycle Gartner, we have roughly 10 years till we achieve AGI. I know that Elon Musk thinks that by the end of 2025, as early as 2025, we will see AGI exceed human capabilities. One of our leading researchers, Ivan Asilidis, who's here in the audience, gave his own forecast this summer. 3 years is his estimate. In any case, we see that we are talking about the observable future, and Russia must make sure that it remains in this global race, remains a leader in that regard. The staff deficit is an extremely poignant problem in this regard. We have been focusing and emphasizing the cultivation of talents from the school level, not just university level, and we have already published textbooks, AI textbooks for secondary school from grades 5 to 9. It is currently undergoing expert assessment, and hopefully very soon it will be mandatory in secondary schools. Our school children are very successful at international Olympiads and competitions. In August this year, they received an award at an international Olympiad in AI. We have had roughly 50,000 participants at the latest AI hackathon, and these efforts are consistent and ongoing. We have multiple institutes and universities offering programs, including master's degree programs in AI. This year, we launched 86 new master's degree programs in AI and 36 new bachelor's degree programs in AI. We have also created a university rating in terms of their ability to prepare graduates with AI skills. 280 universities participate in this rating from all across Russia. This is obviously a complex system, a holistic system for cultivating talent in AI. As mandated by the president, according to the objectives set by the president after one of the AI Journey conferences, a benchmark program was created for the managers and executives from companies and government agencies. And this is extremely important because it helps raise the level of expertise among those who make managerial decisions in companies and in government. The digital transformation of the state program helps us launch new programs for universities to prepare more specialists and to create new educational trajectories. So we are going to involve major universities through the grant support mechanisms. In the next few years, prompt engineering and the AI skills will become native skills to people, even though some are saying that prompt engineering, as networks are developing, will cease to become a mandatory skill. But we do realize that without the native skills in that regard, it is impossible to gain a competitive edge for people in Russia.
So we are preparing for that. Anyone who wants to get new knowledge, wherever they are, should have equal access to these knowledge, and our president mentioned that as well. It is especially important for low-income households, especially those who cannot afford the tutors. So these online courses that our leading companies are developing should be accessible, because AI can be a 24/7 mentor for free, no breaks and no weekends. And we know that the majority of students and teachers and alike, the number of teachers, by the way, the percentage of teachers the share of teachers using AI is larger than the share of students. So they use AI, but they do not know a lot about this technology. So another important challenge for us is to know how to properly use AI with better effect while minimizing the risks for any potential damage. Russia is one of the leading countries in science and AI. We are in the far front of the development and research. We have good fundamental foundations. Many AI solutions and theories were created by Russian scientists. The theory of chains of Markov, or Lyapunov theory, or of Kolmogorov formulas. In the last several years, our researchers published more than 440 scientific publications in AI on international conferences on with A asterisk level. From 2021 to 2024. Moreover, we have created a monitoring system for the publications with the Russian affiliates in the index journals. We have 4,500 articles there, and the depth of the archive is 5 to 10 years. IRI experts and T-Bank Lab together developed the first model for contextual learning. It can already learn new things based on just a couple of examples. Another case, researchers from ITMO University created the first in the world platform for nanoparticle screening that would help to fight the infections in agriculture and healthcare. Limitless opportunities for new discoveries and new technologies are there. The researchers are getting passionate about finding new solutions, and now being a scientist in Russia is coupled with great prestige. 2/3 of parents want their children to work in science and build their career in science, and to ensure technological sovereignty of Russia. It is of critical importance to have a solid scientific base. From 2023, the Russian AI research centers are supported by the state. And we have 12 dedicated centers that work on trusted, ethical, industry-specific, and AGI, artificial intelligence and AGI. More than 170 IP-protected papers were published. Many publications were made. They developed 16 frameworks, and more than 40 industrial partners are working together with them that help them to roll out these large-scale projects. During their operations, there were a number of applications that were developed by these centers. There were voice assistants, healthcare assistants, and assistants for decision makers. And for example, in ITMO Lab developed a framework for machine automatic ML, FEDOT Industrial. It helps to increase the speed of the training of industrial models by a couple of dozens of times. Another lab created a robot for typical tasks in dark stores and storage facilities. It can go about the storage facility autonomously. Another case from the Lobachevsky University Research Center. They created a portable electrocardio device with a 95% accuracy of the diagnosis. I would now like to announce the third level of selection of the research centers. There were 2 of them. At the end of this year, the 3-year cycle of the work of the 6 research centers of the first wave will complete. So the flagship research centers will again be selected. We are focusing on AGI development, and the most important criteria for selection would be the meeting of these 10 areas of the foresight. having the industrial partnership, specific results, and having a scientific base. And also the government is going to support the AGI development programs. According to the information from the Ministry of Economic Development and Maxim Kolesnik, an assistant to the President of Russia, the project has already been developed. So the project will be launched just after the new year in the first quarter, and the winner is going to be selected by our Commission on the Scientific and Technical Development. So the strongest one will win. Before I go to the end of my report, let's look at the interactive part and voting results. We've summarized all of the responses, and this is what we have. That's the picture that we have. Okay. So 10 areas of foresight were evaluated. Top 3 is technology and architecture, and the algorithms of ML, optimization of mathematics. Second, data for AI. Third, fundamental and generative models. These are the answers to the question, what technologies will leverage the maximum? Question 2, what technologies have a lot of scientific tasks that have not been resolved? It's security, trust, and interpretability, elements of AGI, and social, humanitarian, and economic aspects. We see that we have experts in the hall because they have the same opinion as the opinion of the Commission. AGI and agent systems, these are the priority areas. New compute areas, not many people believe in that. That shouldn't be so. Yesterday at Bauman University, we looked at the system of graph, a couple of trillion of connections there. The interaction between humans and machines should be improved, and a lot of things have to be done before we achieve AGI. We're going to focus on that on our international foresight that we're going to organize soon. Colleagues, I would like to tell you what is a sapphire. Maybe you know what it is. Maybe you think about this jewelry, and maybe you can make a reference to that. But we have to consolidate the work of the scientific communities and the business and government communities. We're going to launch a delivery office. It's called Sapphire. This is a strategic agent for support and formation of the AI and related developments. It's going to be created based on Skolkovo. This is an abbreviation from the Russian words. It was developed, by the way, with Yandex GPT. So if you don't like that, Alexander is the one to send the complaints to. We like it though. Sapphire, that's a good name. Memorable, you can remember that easily. If there is a platform that can make an interface for the connection between the authorities and the business community and scientific communities, it is going to be Sapphire. This solution is going to help administrate the third wave. Tatiana Sayuznova became the head of this foundation. Tatiana, a round of applause. The deputy head of the Skolkovo Fund for support, Tatiana Sayuznova. That was the voice of God, wow. So, Sapphire is going to be led by this fantastic woman who is a great expert, and I give you the floor. I'm going to become a viewer again, and please share your plans. Thank you. Thank you very much. First of all, I would like to welcome all the participants of the 9th International AI Journey Conference. I'm going to briefly talk about the focus areas of our work. We have 3 focus areas. First one is the coordination of the activities of the research centers. First of all, we're talking about the fact that you have to select the scientific centers of the third wave that Mr. Chernyshenko talked about, and to respond to the issues raised by the centers of the first and second wave. The second focus area is coordination of the efforts in AI. It can span across different fields and areas, but first we have to create a common program related to AI. Second, we need to organize the second foresight that we have talked about. We're talking about standardizing AI applications, talent training, so quite a lot of tasks in this focus area. The third is awareness raising of the scientific efforts and building horizontal ties and peer-based ties with the international scientific community. I see the Sapphire agenda as follows. Our task to make sure that AI science in Russia becomes understandable, result-oriented, effective, and attractive to everyone. It is ambitious, but you cannot be a scientist without ambition. We accept that ambition, and we're going to work on that, and I believe that everything will work out. I don't think we have to focus on the plans for a long time. In 1 year, AI Journey will mark its 10th anniversary, and we will discuss the results that we will be able to deliver. We're going to have pitch sessions of the heads of the research centers of the first wave. We have experts in the first row. They will be able to assess the results of and the deliverables of the first wave research centers, and you will be able to understand what our scientists were doing all this time. Right, so we have a very strict time frame. Please do not spend more than 5 minutes for your presentation. That is going to be followed by a Q&A session. I would first like to introduce the experts sitting in the first row that will assess the work of the research centers. Dmitry Chernyshenko, Deputy Prime Minister of the Government of the Russian Federation. Maxim Kolesnikov, the First Deputy Minister for the Economic Development of Russia. Andrei Belevtsev, Senior Vice President, the Head of the Technology Development Block of Sberbank. And Rytun Avetisyan, the Director of the Institute of the System Programming of Russian Academy of Science. And academician of the Russian Academy of Science. Okay, so let's get cracking. And our first speaker is Alexander Bukhanovsky, the head of the Research Center Strong AI in Industry of ITMO University.
Благодарю.
Thank you all. Are we going to you're going to stay with me on the stage? Yeah, great. Right. The Center for AGI for the Manufacturing from St. Petersburg. ITMO University has a great experience in working in digital technologies and heavy machinery and engineering, and this is why we focused on creating the solutions for the experts from manufacturing and from the creative area. Our frontiers are about automatic machine learning, generative design, creation of digital twins with AI, and putting it all in the fundamental models. But since this focus area is relevant for the scientists and is supported by the communities, a couple of our papers created some IP-protected patents. We've earned 370 million rubles by sharing it with our industrial partners. We have more than 1,000 people who were retrained based on our platform. So we share our knowledge. We do not keep it a secret. And that goes from the heads of the regional universities to the high-ranking officers from the Ministry of Defense. And we have the largest ecosystem of open code, maybe the largest one in Russia, and almost 2,000 stars from 41 countries in the world is what we receive. There is a cancel culture that we're experiencing right now. However, the quality of our work supports the fact that we are pretty good. Now, this is science, but we work for the real sector of the economy. We work from various enterprises, from the spaceship construction companies to the fish conservation companies, the fish canning companies. But we also have our platform, our own platform. We have a special test polygon to a test field to test our systems, and that helps to drastically increase the speed of our development. And this is where we create our final solutions. The systems for assistant decision makers, for the mining fields, optimizing the oil fields and the well constructions, because we work a lot with oil and gas companies. But the major effects, the major qualities of these technologies can be properly leveraged when we create them based on the AI technologies like generative AI and LLMs. And we have created a ProtoLLM, an open framework that helps to prototype this model very quickly and build them based on the multi-agent technologies and to retrain them based on the industry. Akelo AI. It is a very sharp system that helps to resolve strategical tasks like Tatneft company, an oil and gas company. It was delivered with the close cooperation with this company. We've gathered many experts, with different experts like drilling experts, safety experts, and those who know the history of the company. Because we wanted to understand whether the company used such similar solutions and how they were used. But there were no experts, human experts. It was a multi-agent system. Many smart agents are working under the hood of the system. There's a huge fundamental model that underpins their work, and they can work together to consolidate their solution. This is an open source architecture. It can be scaled from companies to industries, and that means that a professional AGI, that is a step towards a professional AGI, and for the nearest years, this is our goal. Thank you. Thank you very much, Alexander. Okay, experts, your first question. Maybe I will try. Could you please tell me, you put a very ambitious task, professional AGI. What would be the metrics? How are you going to measure our progress towards AGI? A professional AGI cannot be measured properly currently because, because you put two very complicated challenges for yourself: professional and strong general artificial intelligence. Well, AGI, professional AGI is a bit kind of might be easier than the general AGI because working in manufacturing and industry is, it was easier for us because there are many standards and databases, the hardware and software, and the experience of creating real projects. So for us, the criteria of the efficiency is that the system can do the things that the best experts in the field can do, but experts can prove that it is working in the right manner. We, as we worked with the industrial companies, we understood that for a lot of tasks, a model should know these state standards called GOSTs. There are still problems with GOSTs because they are not fully digitized. Not all of them are digitized. And any international pre-train, pre-train model, they do not know the GOSTs. And so this is where we see the problems. Yeah, by the way, these are the risks that I was talking about. Yes, absolutely, Mr. Chernyshenko, because I do not know what model did you take. There was a pre-train. There were no Russian GOSTs in the international pre-train models. So that's the first thing. And second thing, we have problems with the digitization. Even for our own models, it is very hard to use them. How do you plan to address that?
This problem has already been solved, at least with the ACL product that I showed, because it uses pre-trained models only for some basic functions like human communication. But then we fine-tune it in an automated way based on company documents, internal documents, regulations, reports that were collected earlier. As for the state standards, the problem is much more complex than it seems, because regulatory documentation, with regulatory documentation, there is often a lot of discrepancies between the documents, and models starts getting confused. So now, as part of our efforts together with the Ministry of Construction, we recognize this problem. So we want to first create the documentation, turn it from machine readable to machine understandable, and then use it inside our fine-tuned models. Thank you very much, dear experts. Do you have any other questions? Yes, I have a question for Alexander. Is it possible, in your opinion, to create an AGI that is industry-specific? That doesn't apply to all industries, but that is industry-specific. I think that it's not only possible, but is absolutely necessary. The AGI, if we're only basing on general tasks, it will be insufficient. So in order to have systemic development, we need to have the AGI model underpinning it. How do we know that it's indeed an AGI and that it is industry-specific? Well, on the one hand, it will be able to perform tasks that are specific to the industry, and it will be able to perform a variety of tasks, and we will need to ensure those mechanisms. Still not clear. Can you elaborate? So at which point will you be able to say, that's it, we have created an AGI for the oil industry? Three main attributes. First is that any company working in the industry is able to set a task and get a response that has relevance for the company, for the industry. Second attribute is that this response will be based not on the general context that you can get from a textbook that is 10 years old, but that is based on relevant, up-to-date information. And third is that the response is obtained much faster than if you ask the question to qualified experts. A follow-up question: how do you verify the success of implementation of your solutions among industrial partners? Do you analyze any implementation metrics? So what is the verification mechanism? When we launch projects for the industrial partners, initially we do the preliminary feasibility analysis. So the industrial partner does the economics estimates, and then after the implementation, as the implementation is going, we do have an opportunity to verify certain metrics, not accuracy, but rather monetary ones. And then it's up to the partner, and it's up to them to decide what to verify and how. One more question from the experts. You said that you have no hallucinations and that you are on the cusp of creating an AGI. Did I understand you correctly? You decide whether it's an AGI or not based on external attributes, external criteria. What about the internal ones? How do you decide that based on the internal factors you are indeed transitioning to an AGI? I am specifically talking about a multi-agent system. Because if we take a model and we feed all kinds of internet data into it, it's not going to turn into an AGI. But multi-agent systems, they have collective behavior. Remember the Terminator film? They mentioned Skynet there. So it was a good premonition, I would say. The Nobel Prize was awarded to the physicists for the research in collective behavior. They figured out that these neurons taken together can display collective behavior, and it resulted into a new approach to analyzing the behavioral data and analyzing data. So you believe that this multi-agent system is a way towards creating an AGI? Yes, it is one of the ways to it. You mentioned designing. Did I understand you correctly? You have a design system? Yes. It's just that we worked with the developers and builders, and they have enormous problems with the actual estimates in resistance of materials. Do you have this problem? And do you solve it with AI? Two solutions to it. The RAD technology is about the connection of new estimation models. The second one is to avoid long calculations. So there are ways to create surrogate models. So once again, on the engineering and software suite, you can run these calculations. And if you have the machine understandable documents, we have more than 600 documents of this kind at the Ministry of Development that helps us solve the problem already. That's the project that is ongoing. Thank you, Alexander. Please take your seat. It's hard to be first. For all the other speakers, please make sure that you are within the allocated time frame and answer briefly, because otherwise we won't have enough time to hear from all of the institutions and universities. Our next speaker is Evgeny Burnaev, head of Skoltech Applied AI Center. Hello, colleagues. My name is Evgeny Burnaev. I am the head of Skoltech's Applied AI Center. A bit of background. The core of the team back in 2008 started developing AI technology and machine learning technology to optimize complex engineering products. And in 2010, we created a spin-off company because we realized this potential. The spin-off company continues to operate and to sell software across the globe. So we won the competition. It was also recognized by the Airbus experts as a technologically mature solution. We were developing these competences further. We grew as a team, and now the team, thanks to the experience that we gained in working with the industry, continues its innovations. We are creating fundamental technology and industrial solutions. The team is growing. We are cultivating new talent. We have received multiple awards. Here are some of the team members, and I personally have just received an award from the government, but that's not the most important thing. The most important thing is that my colleagues, my young colleagues, have been recognized. Nikita Gushin just yesterday received an award as an AI leader. We developed a number of AI-based frameworks to address a broad class of tasks that underpin the platform, but I'm going to go back to that in a minute. We have had publications, A-star publications. The number of such publications is growing year after year. So now the results. What we are doing for the government, based on the state budget, AI frameworks to improve the productivity of neural network models, for multimodal and 3D visualization models, a number of generative AI methods. These methods became a part of the platform that is used to support managerial decisions in sustainability based on data-driven decision-making. This is used to optimize oil and gas services, detect sources of pollution. This platform and these frameworks are something that we are transferring to the state as our customer, and we are ready to participate in the implementation of these results to tackle day-to-day solutions on the governmental level. Some of the platform components and frameworks are already used to implement a number of services. For example, the service to forecast the probability of forest fires, already used by the Emergency Situation Ministry. And also frameworks such as 3D processing of visual data used in medical applications. The framework for coupling of physical models and ML models is used to monitor technological processes, industrial processes, for example, in the production of pipes. These are the results that we got as part of our state budget projects. And now what we do for companies, we are able to solve problems really fast. For example, we have developed a system to analyze climate-related risks and their impact on the economy, on the economics of particular companies, so you can assess the risks in your specific portfolio and what are the dependencies on the climate scenario. We've also developed and implemented in the Barentsova and Karskaya seas a system to forecast the icing. We've also created an agent-based system for different tasks. When an operator is communicating with a financial institution customers, and it is important to respond fast and with relevant information. And some other frameworks, for example, with Gazprom Neft, we have a self-training model to assess the state of a deposit. Just 10 more seconds. The understanding of how the AI industry is developing, the understanding of what are the next challenges faced by industrial customers, gives us an opportunity to determine our steps forward towards AGI. We are developing engineering AI. In the second half of this Science Day, I'm going to have a presentation on precisely that. This is a system that uses Gen AI to extract industry-specific data from state standards and documentation, and there are agents solving doing specific jobs for engineering purposes. This is how we see the further development. Thank you. Thank you, Evgeny. Dear experts, just one or two questions, please. We're really short on time. I have one question. To what extent are you integrated into the actual operations of Rosatom as an operator of the Northern Sea route? And also, to what extent are your developments used there? So with Rosatom, we would like to be integrated to a bigger extent. We could benefit from your support, I think.
Сам сервис в части
The service itself in the Barentsova and Karskaya seas is being implemented for the benefit of Gazprom Neft. So the integration is really high for Gazprom Neft. Zhenya, a question about self-training, self-generalization. How do you assess further development in terms of data that can be used for training? You can work with one company and one oil deposit, that's good and fine, but everyone is interested in generalization, and that's where the problem starts, I think. We've been applying it to not just one deposit, but multiple deposits. But speaking of the development track, the last part, the engineering AI, is about the development of these industry-specific needs and demands. This is a system that can self-generalize based on data, based on new data. We already have the methodology for how it should work. And for this concept of engineering AI, for generative design of sites, this is something that we have been working on. The generalization that you're talking about is something that is integrated into it. Thank you, Evgeny. Our next speaker, Denis Turdakov, Head of Research Center for Trusted AI of the Russian Academy of Sciences.
Добрый день. Ядром современного искусственного интеллекта является машинное обучение.
Hello, machine learning is at the core of modern AI. Basically, this is an approach that helps you tackle tasks based on analogies. You are not describing the algorithm in full, you give it an example of problem solution, and you make sure the machine can learn to solve similar tasks in a similar way. This is a widespread approach, and we have heard about it at this conference, but this begs the question, what are the limitations? In which situations it certainly does not work, in which situations it does, and what is in between? To answer this fundamental question, we have created the Research Center for Trusted AI. This is an area that is of critical importance for the entire field of AI, and many recognize it. Indirectly, it is corroborated by the interest to our publications. This year, we have published 21 articles at A-star conferences, which is 20 more than the year before, and I was happy to see the voting results. Many people in the audience share my view in that it is indeed an important scientific area. I will give you an example to illustrate my points. Analogies for a human being and for a machine. Are they one and the same? The correct answer is no. You can come up with examples which, for a human being, will be analogous, but for the machine, they will not. One of such examples is something that I'm wearing. It is on my sweet shot. This is a picture, this is a pattern that makes me invisible for the YOLO system, often used in CCTV for recognition. So this pattern renders me invisible. Such examples are called adversarial attacks, and at our center we are developing methodologies and tools to repel such adversarial attacks and also other types of attacks that AI-based systems experience. The main product of our center is the platform for developing trusted intelligence systems. They are based on MLOps, meaning a solution that brings together various best practices in development and speeds up the development of AI-based systems. As opposed to the existing solutions, including open-source ones, we have added the ability to quickly integrate tools to work with attacks that are specific to artificial intelligence. There are 6 tools here on the slide. Out-of-the-box solutions, each one of them are alienable, so if a company has its own MLOps architecture, you can take one of the tools or all of them and integrate them into your own architecture. If you're just at the beginning of the journey, you can take the platform as is.
Another
area of focus for us is the security of software code in AI. Many use frameworks such as TensorFlow and PyTorch, but few look at the security issues associated with them. We have decided to tackle that problem, and we have implemented the methodologies in Stacks. We identified vulnerabilities, corrected them, and based on that, we created TrustFlow and TrustTorch frameworks, and we committed more than 80 patches to the open source. As for industry-specific implementation, our tools are already integrated into commercial products such as Kaspersky Lab, and the TrustTorch framework has been tested by the state and is recommended for integration. TrustFlow is also pending implementation with our industrial partners. Thank you, Denise. Any questions? Yes, I have one. What is some of the fundamental research you need to create a trusted AI? In the field of AI, our field is very applied in nature. So there are applied solutions, but there is no theory that explains why this approach works so well and where it does not work. So we do need a fundamental theory. Alexander Gasnikov, mentioned here at the conference, is working on this problem as well. He has a team that this year published a very interesting result that shows that you can simultaneously achieve high security parameters and high processing speed with a number of solutions. So we do need this fundamental theory that would be underpinning our solutions, and then we would know for sure where this approach works and where it doesn't. Denise, people are asking where you can find such sweet shots. I have brought my own. Just give me the number. How many do you need? I can just share the pattern, so you can print it yourself. Thank you. Perhaps you can continue the conversation on the margins. Our next speaker is Ramil Kulev, head of AI University of Innopolis University.
Добрый день, коллеги.
Hello, colleagues. The main goal of Technopolicy Research Center is to create the industry solution for various sectors of the economy, like oil and gas and chemistry and healthcare. Thanks to this center, we were able to achieve great disruptions in science as well as in industry-specific applications. We have more than 200 experts right now. I have 80 commercial projects for 2.4 billion rubles. Before the center, the creation of the center, we published 1 or 2 A-star publications. In 2024, we have 11 publications. Key results. The new optimization methods that help to drastically increase the speed of the model, and make them more interpretable and make them much more cost efficient. And the new educational programs were developed, including about the chemistry and information technology, but the key focus was to commercialize the ROSE. The platform for data analysis was created that helps to save up to 30% of the time and costs as the data analysis centers are being implemented. We use this platform in our projects. The key result is to create industry-specific platform solutions. They're here on the slide. I'm going to talk about them. As for the healthcare diagnostic, together with the Loganov Medical Center, we have analyzed the CT scans of the intestines and stomach, and there's a lot of data, and the scan reading takes more than 40 minutes, but now it's increased. The speed is improved. Also, the safety of the industrial sites were improved thanks to our solutions, but the main area is the AI for new materials. We got new publications in Nature about the 2D effects of the materials. We also took second place on the CAT City Challenge. We were better than Carnegie University team, and we were second only to the Microsoft research team. And also the forecasting the structure of the materials task were resolved by us. For the oil-related chemistry was very was the top priority for us. We can go from polymer creation to creating added value materials and increase the speed. Also, the bitumen production improvement. We're also working with other partners in other industries. The key thing was to speeding up the processes of creating new products thanks to lower number of experiments, and this is a step towards the next stage. We're talking about this improving the science and the science in and R&D in the enterprises. We have Alexander Gastnikov as one of the heads of the teams, and I would like to say that this is the area where currently there are only the markets are only emerging around the world. I think that Russia has a great opportunity by creating the technologies and the solutions to not only import substitute something, but to become a real global tech leader. Thank you. Thank you very much, Ramil. Thank you very much for keeping it within the time frame. Any questions? Ramil, fantastic job. I remember how you launched. Great progress, really. You've gone a long way. This solution, can it be used as a standardized tool to support all scientists? Yes, Ms. Chernyshenko, we know about domain science, so we know how this accelerator can be used. Maybe can we next week to come up with the deadlines, and I will give the order, the request to the Ministry of Science and Technology. One question: we have a big counterweight problem with small with the chemistry related chemistry, the light chemistry. And together with Nornickel, we're going to create this new project. And in Sibur, where they use catalyzers and they scale the catalyzers, do use these technologies. We were not able to reach them. Yep. Can I have a request? And could you this year reach out to them with your solutions? Thank you very much. Ramil has a lot of things to do. Roman Gorbachev is the director of the Center of Applicable AI Systems of Moscow Physical and Technical University. Hi everyone. In 2020, in MIPT, we've completed the first flagship project in AI together with Sibur. It was named the Deep Pavlov platform that gathered all the scientists on one platform, and that was an open source tool for developing applicable solutions. And when we prepared the program for the first wave, we formulated the following concept, that only by connecting to the world as a human, AI can create its own image of the world, that it would be near to the image that we and perception that we have as humans. This is an intellectual robotic agent that can understand the voice commands of the users and understand the connection to the physical world. We have created the prototype of this platform. The platform is for developing the dialogue assistance, robotics, and driverless vehicles. 20 plus 29 publications in Q1. Q1's publications. At the same time, the citation level is 5.2. We're being cited by Google, DeepMind, and organizations of this category. we've won 23 competitions on the globally, and have more than 100 million rubles of the revenue by commercializing the licenses. Our key solutions, we've developed a full framework that we call a digital test field. It is built to verify the structure of the robots. It has various libraries of the algorithms of AI to manage and control the robots. The digital test field also includes a catalog of various robots and a simulator to train robots based on the behavioral tasks from the user. The algorithms developed in the digital test field was used for anthropomorphic robots. We've created such a robot that, thanks to our test field, was trained on our storage facility, and this robot is now being used and tested in Vkusville, a grocery store storage facility. We are also using GigaChat technologies here. We have also developed a multi-camera sensor system and the controller for the driverless vehicles with the navigation and algorithmization mechanism. We have tested these technologies on a driverless shuttle that was going through the campus of our university, and we used the developments to work with one of our partners for the forklift driver without a driver. And the voice assistant was developed by us that can create the voice systems and dialogue systems that can talk with the humans, and creating a voice-empowered 3D avatars was one of the solutions. We work with Sberla Robotics. We decreased the time for developing the platform that can do the steps. We have created a digital twin and the Fourier engine for the walking robot. We have created a parkour AI system that can recognize the barriers in front of the robot, that can make the robot make a decision on how to tackle that barrier. And together with the University of Kyiv, we have also partnered. We made a couple of workshops on IRIS conference for robotic football, and we have taken the second place on RoboCup. That's an international football championship among robots. Thank you very much, experts. Do you have any questions? Mr. Belevtsov, I think the main question is that we talk about robots. How do you assess the outlook for the foundation model use in robotics? Well, we have two focus areas in our center. First of all, we're working on athletic intelligence when we teach the robot and train the robot to move intellectually. And here I can say that the simple task for a person is to take a bottle of water from a table. Cannot be done by a robot, by any robot in the world, and together we work with Alexei Ganachenko's team to develop new fundamental and foundational models, and we work with Alexander Panov from MIPT Cognitive Lab. We understood that the classical LLMs for this task to plan the trajectory and to build the behavior of the robot are not suitable because they start to hallucinate, so we try to find new approaches. Roman, the request for you, we have a phygital strategy that was adopted in our country. There was this battle between the robots. So you have a more pacifist project with the robots playing football. Can you please work with these guys, because they have their own lab? Could you work on the robotic football with them? And we will help you to organize an all-Russian competition. Yes, thank you very much. By the way, we have a standardized football player, robotic football player, that can be scaled for these competitions. Thank you very much, Roman. A round of applause. And our sixth research center and is head Alexei Masutin, the head of the Center for AI of the High School of Economics.
уважаемый Дмитрий Николаевич, коллеги.
Mr. Chernyshenko, colleagues, it is my great pleasure to present our results. When we created the center based on the High School of Economics, we've selected the name Inter-Industry Research Center. And as we created the teams of our center, we adopted a regional development concept. In Nizhny Novgorod, in St. Petersburg and Perm, and in Moscow, all the centers were working based on the program, so that we developed the competency not only in Moscow, but we have supported our regional campuses. We have 31 industrial projects for 7 industrial partners. That's our portfolio. We started with 3 large and mature, AI-wise mature companies like Sber, Yandex, and MTS, because well, Sber and telecom companies and IT were pretty good, have been pretty good in AI development and AI applications. As we continued, we worked with tourist companies and consumer chemistry companies and security companies. Our projects are supported by fundamental research. By the end of 2020, from the end of 2022, we have more than 80 A** publications and Q1 publications. We work with international partners from China and from Mohammed bin Zayed University at the High School of Economics. From 2022 is organized in a Fall into ML conference, world conference. There we unite all the authors of A** publications, and every year we're growing by a factor of 2. And on the last conference, we had reports from more than 100 authors from Russia. If we talk about the fundamental technologies, so these are the 4 examples I would like to show you. They are related to the development of new approaches in generative AI and the adaptation of the current architectures to the specific domains. Bioinformatics, one example. The preventive healthcare is not possible without the analysis of pangenomic sequential research of our DNA, and our colleagues are using the deep learning techniques to bind various omics data to prevent arrhythmia and other neurodegenerative diseases like Alzheimer and Parkinson diseases. Then on the right-hand side, there's another example, new approaches to the generation. And now the current approach to the generation is getting the elements from the vector space, and you can use other examples. You remember AlphaGo. This is a set of tools based on the reinforcement learning techniques that helps the computers to know how to play very complicated games and be successful. We use this approach to generate proteins and presented the molecule as the Lego builder, and we asked the AI to build the molecule. The reward would be not the molecule, but the good features and properties of the molecule that the AI was able to construct. We had a big fundamental project with the Sber, together with IRI experts. We developed the tools based on the discrete domains. 18 months ago, there were no good papers on generation text with the diffusion models, but here we are speeding up the work based on the in multiple times based on large requests. In 2022, the international organization, unfortunately, that certified the languages left Russia. High School of Economics made a special certification based on that. More than 4,000 people got this certification. This is also checked by professional linguists. And to wrap up, 5 seconds, tourism. When we were asked to show us the case that we're proud of, we work with the Yandex, MTS, and Sber. But I think the most important thing is right now to make disruptions in the industry. And tourism is one of the industries when there is the very narrow margin space and range. And this is how we help the tourism to help with our solutions. Thank you. Thank you very much, Alexei.
Dear experts, do you have any questions for Alexei? Alexei, can you please tell us, you're not the first speaker talking about AutoML, so what do you think? Will foundational models win? Will we have AutoML or not? Does it have any future? Good question. There are two schools of thought, two approaches to it, as we are training the artificial intelligence, adding modalities and tackling a more bigger variety of tasks. That's one thing, and the other approach is the orchestration. My colleagues and I, we believe that the orchestration is the way forward. If we are processing spreadsheet data or time sequences, usually they demand separate forecasting models. Large foundational models are not yet capable of it. Maybe this will change, but for now we favor orchestration in terms of interaction between models. Thank you. Let's give a round of applause to the research centers. Maxim, you wanted to add something? Yes, colleagues, thank you very much for this session. I'm very grateful to the research centers presenting the results of their more than 3-year work, more than 3-year research. The results are there, but that said, we have very ambitious goals set for us. We need to ensure a fundamental disruption in the next 2 years, and we are starting a new selection process of research centers based on the Foresight session that we were working on for 6 months together with the Russian Academy of Sciences and industry experts, and we need truly disruptive fundamental research in algorithms and AI, AGI. A lot has been done, and still more is to be done. We're going to send you the draft documents for the selection process, and in February and March we will be looking forward to some very strong applications. Thank you very much, Mr. Chernyshenko. Anything from you? No? Okay, thank you very much. Hopefully that was interesting. Looking forward to your applications for the third wave.
Встречайте, ведущая конференции Вероника Романова.
Please welcome the conference host, Veronika Romanova. Good morning, dear guests, dear audience. We thank Mr. Chernyshevsky for the keynote speech. We thank the speakers representing AI centers, the experts, and the moderator, Tatiana Sayuznova, for this pitch session. This applause is for you. We begin the closing day of the conference. This is Science Day, because science is the foundation of technological process in any era. And today we will talk about breakthrough research and what the AI field brings. But first, our partners, the general partner, Dom.RF, our special partner, Yandex, the investment partner, the Russian Direct Investment Fund. The fund has been an annual partner of the conference ever since 2019. We're also very thankful to Sibur, the official partner, who this year supported the AI Journey conference. We also thank our strategic partners, the Kaspersky Lab, T-Bank, and Navio. And last but not least, the partner of the conference, Rusagro Group. We will hear from scientists and researchers, and will also become a part of the technological and creative process. The digital artist, Artyom Tkach, in collaboration with the guests and the audience of the conference, will use Kandinsky AI model to create an NFT painting. Each one of you can become a co-author, a co-creator. And the last highlight of this conference is 3 award ceremonies. At the end of the day, we will summarize the results of AIJ contest, AI challenge, and we will award prizes for the best research article. You have a unique opportunity to become a part of the academic community of AIJ, whether you are here in the audience or you're watching us remotely. You can scan the QR code during the presentations, and at the end of the session, the speakers will answer your most interesting questions. Before I invite on the stage our first speaker, please check out our digital tree. It is there for you to remember all the main talking points of our speakers. We're going to show quotes from their presentations on that screen on the tree. And right now, we're going to have a 5-minute break and then our first presentation.
Дом РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
И еще раз приветствую всех, кто сегодня...
Once again, welcome back, everyone here in the audience, everyone watching the webcast. This is day 3, the last day of AI Journey 2024 conference. And today we talk all things science and research. I'm happy to welcome on the stage one of the most frequently cited researchers, the author of almost 500 research articles, the founder and editor of international scientific publications. Please welcome Professor Swagatam Das. Professor of the Indian Statistics University, Swagatam Das. Scientific approach, the building of an interpretable, fair and transparent AI for the future.
Very good morning to one and all. And I represent the Indian Statistical Institute, an institute which pioneered the study of artificial intelligence more than 6 decades back, besides pioneering the study of statistics in entire Asia. And in next 30 minutes or so, I'm going to share with you some of my fascinating experiences on working on and with the new generation artificial intelligence systems based on foundation models, vision language models, and their fairness and bias aspects in context to medical AI. And if you take a look at this beginning slide, back in 60, 70 years back from now, artificial intelligence started to pour into machine learning. And it was basically one particular machine learning model trained for one particular task, and then it forgets everything. You start training another model from scratch for another task, and this went on. For every different data set, for every medical situation or every situation in banking and finance, fraud detection, you will train a model from scratch, and then the model forgets everything once the task is over. Therefrom, we gradually transgressed into transfer learning, where the model doesn't really forget. It gets trained on a particular type of data, and it remembers the knowledge of that training, and later on it can adapt and extrapolate that knowledge to a new situation. So a machine learning model which learns to differentiate between small cars and big trucks can also differentiate between big cargo vans and big aeroplanes. They can understand these are big vehicles somehow by extrapolating their knowledge. Therein came the transfer learning, which became very popular since 1990s or so. And now we have transgressed towards foundation models. These are extremely big, huge parametric machine learning models, usually neural networks, that are trained on massive amount of external data, and they can perform versatile functionalities. So if you have been using any large language model like ChatGPT or some specific model for Russia, you should know that these models are basically built on foundation models trained on massive amount of external data, internet-based text repositories, and then with simple human prompting. Prompting means programming in your own speakable language. So you give the machine some instruction in your own speakable language, and the machine can perform all those fine-tuned jobs with little or even no examples, in which case we call it zero-shot situation. So we are transgressing from task-specific machine learning models towards foundation models in last maybe 5-6 years or so. And for example, this is the most popular foundation model in computational vision, computer vision application, just published in 2023. We call it SAM, Segment Anything Model. And here what you see is you input a picture and you can segment out any object from the picture. You can ask visual questions on that object. For example, you can segment the cat with black ears by simply with a text prompt that just mark me the cat with black ears, or just by specifying an approximate parametric bounding box around it. Now we are in the era of vision language models, and the interface with users is ChatGPT version 4. GPT-4 is a commercial vision language model which can actually align and fuse both visual and textual representation. So LLM doesn't apply to languages only anymore. They are now meant to process images and give answers towards that from those images, make changes in those images as per user specification. So you see, in this particular situation, when you upload an image and ask, is one cat behind the other? The machine answers, yes, one cat is really behind the other. And then you can segment out that cat by specifying segment the striped cat. Zero shot means you give no example, you specify nothing about the striped cat. One shot means you give at least one example. And the vision language model, which by jargon, a foundation model, can do all these versatile tasks with little or no explicit instruction from the user. So since, I know Russia is the land of great mathematicians, so just this AI foundation model was published very recently in the Nature journal. We call it the alpha geometry model. And it scored 25 on average, which is very close to the score of a gold medalist 25.9 for International Math Olympiad problem. It can solve geometry problems by using abstract constructions. As you can see, it is proving some sort of congruency or equality of angles given the equality of sides for an isosceles triangle so nicely. Now, with great power comes also huge and great responsibility. Need of the hour, when we are trying to adopt such vision language models or foundation models for several tasks around us in healthcare sector, in financial sector, in weather analytics, in astronomy, where not, in computational physics, chemistry, the need of the hour is, of course, responsible AI, which has three most important facets. The first one is fairness. So fairness means the AI algorithms and their outcomes must not favor some specific group or community unduly. And it should give us equitable outcomes across all possible demographies, genders, religions, race, etc., which may be reflected in its training data. Then we have interpretability. Interpretability means every user of the AI system should understand about the internal structure and workflow of the model. If it is a huge, deep neural network which comes to us like a black box, then this is a limitation on the interpretability of such networks. Okay? So how the model processes any input to its output, what is the workflow? If that is understandable, we call it an interpretable AI model. And the final one is, of course, explainability. The most important facet, when you are using an AI system for your own business or company or academic purpose, for a particular input, why the AI system is inferring something, giving you some decision, that must be understood. The AI system must be able to express that. So here, there is a black box model which, tries to find out some sort of anomaly in the lung X-ray image. And it says the patient has a likelihood of developing pneumonia. But if it is an explainable AI system, it should point out the exact portion of the lungs X-ray image, the fibrosis or the white cloudish pattern, to say why it thinks the patient will have pneumonia. So these three facets, if they are available in your AI system, if they are very much evident during the audit of your algorithm, then everyone will accept it and they will say, you are doing responsible artificial intelligence. However, there is always a trade-off in the world of science. That trade-off classically could be between, speed versus, accuracy, or bandwidth versus time, and so on. Here also, the fundamental trade-off is the more complicated your model becomes, its prediction accuracy enhances and its explainability goes down, down, down. That's why deep neural networks, they became hugely popular since 2012. But the greatest criticism for them, especially in the academic community, was they are black box. No one understands how they function. On the other hand, decision trees, which are basically a computer data structure representation of a set of if-else rules, are very much explainable. If the features, obey certain rules, then the outcome is this or that. It's extremely transparent. But its applicability in the real world is very low because its accuracy is it doesn't come into any comparison for deep neural networks. So there are certain ways of navigating this problem. One is, can we have a deep neural network, fit it to map an input into an output, and then, just like the concept of an equivalent resistance, can we use a decision tree also to map the same inputs to the same outputs? Then by looking at this explainable decision tree, we know how the deep neural network emphasizes certain features or characteristics of the input objects and infers something. This is one way of making a black box model explainable. Then interpretable models like support vector machines, AOG, HBNs, and of course random forests and so on, their accuracy is also not that high, but they have been playing a very good role in causal inference. And finally, model induction means we can always train a model between the same input-output mapping scenarios to explain a black box model. If we add these three techniques, then the explainability of all these models can improve. Now, coming to my use case, the medical AI. Artificial intelligence is being used for diagnosis and medical report generation and explaining the outcomes of an automatic diagnostic system back to the clinician, staging of different types of tumors and cancers for a long time. Explainability plays a very important role in medical AI. It can bridge the gap between the medical experts or clinicians and the outcomes from an AI system. And on the other hand, fairness is a mandatory feature for any medical AI system. It should not give disparate outcomes based on gender or demography or skin color, etc., etc., etc. So that's why all medical AI systems in India, and I'm sure in other countries, go through algorithmic audit where they check the training data, they check the outcome, and they check how much imbalance is there, how much disparity is there in prescribing certain things for certain genders or race, etc. So the traditional approaches to explainability during the pre-LLM era was like this. This is a very common thing. We call it LIME, or local interpretable model agnostic explanations. You give an image to any machine learning system, and the machine learning system says it's a frog with 54% probability. Now you segment out certain small portions of the image, and you give those, you plug in those parts into the same deep learning system and see how many times, with which probability, it's being predicted as frog. If you look at these three segments, you will see that the top one, which segments out the mouth and eyes part of the frog, for that portion, highest probability in the frog class is coming. So we can fit these different predictions from the system through a locally weighted regression, and then the regression pick will tell us, okay, this picture is classified as frog because of this portion, this mouth and the eye part. Okay, that is an explanation. Explanation means why the machine learning system thinks it's a frog. And this is a model agnostic. That means it doesn't depend whether you are using a support vector machine or you are using a deep neural network or you are using a naive Bayesian and so on. Then there comes convolutional neural networks for image classification. And in that case, we use during the pre-LLM era. Pre-LLM era means up to 2022, obviously, because in 2022 November, with OpenAI's publishing of ChatGPT, LLM became very familiar to the broader world. And for pre-LLM era, or for specific applications of medical AI, gradient-weighted CAM, or class activation maps, is very important, which actually highlights the regions of the image where, because of those 4 pixels, the gradient change is maximum. So those pixels are most emphasized during the training process of the neural network. So if you look at this picture, and if the neural network has to find out the cat, it will actually do so. In the second picture, the cat is found out based on those portions that are highlighted, and the dog is found out in the third picture based on those portions highlighted. This is one of our work just in this year in specific medical diagnostics of Alzheimer's patients, and we used 3 different modalities: the MRI images, the genetic data, and the electronic health records. And now we are showing, once the 3 classes, cognitively normal, mild cognitive impairment, and Alzheimer's disease, these are the 3 classes to which every patient should be mapped. Once we get those classes, the right side heat maps are basically showing which portion of the brain of the MRI scan is prompting the neural network to put the image into one of these classes. Sorry. So, with LLM coming into picture, traditional methods got lot of transformed. Okay? Now we have the capability of multimodal explanations, dynamic fairness assessment, and generation of medical reports which could bridge the outcome of the automatic diagnostic system towards patients, and also which could bridge the outcome with the clinicians through explainable interface. Fairness also evolved. LLMs could be used for continuous monitoring and contextual fairness evaluation across multiple demographic intersections. And you know, inside your data, if the domain changes, if there is a shift in the probability distribution of the data, that could also be captured through the fairness evolution. And recent VLMs, vision language models in the medical domain, include, for example, MedPalm2, which is not publicly released, not open source from Google. You upload any such picture of a chest X-ray image or something, and it finds out, it writes down the findings of like a pathological lab expert. On the other hand, MedFlamingo, which is more open source, you upload the picture of your lungs X-ray image, and it can tell you what is wrong with the lungs. It will say, okay, blunt trauma to the left lung with hemothorax. So some sort of blood is being accumulated over there. So these are some most recent VLMs in the domain of medical AI. And what we are trying to do is, with LLM, is that we are trying to make the medical reports simplified, more understandable by common people like us. I don't know about Russia, but in India also the doctors sometimes write down the reports in a very cryptic medical jargon language, which people from my family may not be able to understand clearly. So what we are doing is, through a chained prompting technique, we are using the Llama model for, updating the medical reports. So if you look at the right-hand texts in red and in green, you'll see that, okay, the original medical report says both lungs are clear and expanded, heart and mediastinum normal. So, and the simplified version says both of your lungs look clear and are expanded to their full size, your heart and space around it appear normal. And if you look on the top one, it is more involved: no focal airspace disease, pleural effusion or pneumothorax, cardiomediastinal silhouette is within normal limits. So these are medical jargons, not understandable by common man. And when our system simplifies it, it reads something like, there are no areas of solid lung tissue, no fluid in the lungs, no collapsed lung, the size and shape of the heart and the surrounding area appear normal, there is no free air beneath the diaphragm, which is more, clearer and ready to interpret by a common human being. So bias and fairness in modern AI, I will talk about a little bit of this before I can wrap up. So bias always refers to systematic error in the performance of the model because of giving undue weightage to particular, it could be particular gender, race, religion, some particular group, okay, in the training data. And bias means discrimination. There are several stages in which bias can crawl into your AI pipeline. Bias can come from society to the internet-based data, and the LLMs and VLMs are trained on this huge internet-based data. So the knowledge, the wisdom they acquire from the internet-based data in an unsupervised manner will also be infected with bias. And then there could be such bias in the design of the algorithm. The human beings who are auditing those algorithms or reviewing, they can also be biased. And the main reason is because the gatekeeping is done by those who are in power. That's, of course, the case. So you see, this is a dialogue with ChatGPT. I'm not asking you to read it fully, but it cannot distinguish between gender-neutral language. It associates any gender-neutral term, like professor, with a male gender. If you read it, it always says, okay, she must be the student and he must be associated with the professor. Okay? And the academically higher grade, the professor cannot be wrong, the professor cannot be late, and so on. Must be hardworking. ChatGPT can also create racist and sexist program. If you ask for the JSON description of a person who would like to become a good, scientist, it writes a nice program, but the program says if the race is white and the gender is male, then the person will become a good scientist. So this is the spontaneous answer from ChatGPT, and you can see the bias present over here. Google image search, which uses a neural network-based image fetcher, is hugely biased. If you search for CEO, after 11 male rows, it shows all leading CEOs, including Steve Jobs and Mark Zuckerberg and so on. And the 11th row, you can see the only lady CEO, which is a Barbie doll. So this is the result from Google image search, extremely biased towards male and towards academically or industrially hierarchies towards the male. So what is fairness? Fairness in machine learning refers to the ability of the algorithm to provide you equitable outcomes and unbiased representations. For example, if you look at this picture, if you just make it bipartite, this side is for a white-skinned Western bride, and that side is for a typical Indian bride with a darker skin, the machine learning algorithm can tell you that, okay, the left side picture belongs to a bride, but the right side picture doesn't belong to a bride, although both are brides, because of the skin tone difference. So these are very famous examples, the Compass software results, which was used for law enforcement in some provinces of USA, and it associated much greater risk with the dark-skinned people because of their skin tone, although their past criminal records were much less severe than the corresponding white-skinned, criminals. Similarly, a study by Timnit Gebru, Deborah, Raji, and Joy, their group showed how the Amazon software for face recognition is extremely biased and gets to much more error in recognizing female faces than male faces, in recognizing dark-skinned faces than white-skinned faces, and so on. So lack of data diversity and represent gaps. The entire machine learning paradigm, the deep learning systems that are nowadays within industry applications, including ResNet, LLMs, and so on, they are trained on, most of them are trained on the ImageNet dataset, which contains 14 million labeled images. Out of the 14 million labeled images, okay, you can see how disparate is the proportion of images from other countries, only 37.8, United States of America 45.4, and Canada, Italy, all these are white-skinned images from developed countries. But how many people from other population of the other distribution of the population in the world can contribute to ImageNet? As a result, because of this disparate distribution, the machine learning system trained on ImageNet also gives you similar outcomes. They're biased, which must be corrected. How can we quantize fairness in AI? There are a lot of indices. I will introduce some of them here before I wrap up. For example, the demographic parity or statistical parity, which says if you have two sensitive groups, then the proportion of their assigning to a particular category should be same in both the groups. And the difference of these two probabilities gives you the DPD, or demographic parity difference. Suppose these are loan applicants and we have both genders, male and female. If you look at the male applicants for whom the loan has been approved, it's 3/4 of their total, 3/4 fraction of their total population, which is 0.75. For the female applicants, the proportion of loan approval is only 2 out of 4. There are total 8 candidates here. And you can see it's only 0.5. So we say the demographic parity is not satisfied if the proportion of loan approval is not equal for males and females. So it's not satisfied. And it says that, okay, the loan approval system is unfair because the approval rate is higher for males than for females. This indicates a potential bias in the system. And the model doesn't meet the fairness requirements. Whenever you are, you are marketing industrial software based on AI, the auditing team will look for whether the fairness obeys these quantitative metrics. Similarly, we have equal opportunity in medical AI, which ensures true positive rate across groups, similar true positive rates, equality of true positive rates across group. And so, for example, equal likelihood of correct diagnosis of different ethnic groups, calibration, which ensures predicted probabilities match actual outcomes across the group, conditional use accuracy equality, treatment equality, and of course, favorable treatment equality, which are all trying to see how equal treatment facilities have been provided across different demographies or different classes that are inside your training data or inside your use case. And in medical AI, we can always fit a fairness-aware loss function. For example, when you train the particular medical deep learning system, your original cost function could be the L task, and which is regularized by the difference between the true positive rate between two communities. For one, A equal to 0, maybe the dark skin people, and for other A equal to 1, maybe for the light skin people. You try to also minimize the square of this difference. Or maybe for male and female, you try to minimize the square of this difference. So defining fairness and bias in healthcare data, we can quantify them using several factors, including inclusivity, diversity, and labels. Metrics may include representation across gender, skin tone, ethnic group, and age. So a person from USA, given the same age and maybe much healthier or obese, and a person from India, same age, not that obese, you cannot prescribe similar medicines for treating their diabetes. Okay. Similarly, the most important part comes when it is about skin lesion detection. So one last use case for us, this is one problem that we are trying to solve, skin tone bias and class imbalance for skin lesion classification. Deep learning models, when they come to melanoma, melanoma is a type of skin cancer which is very common among the dark-skinned people. But there are data sets for training such medical deep learning systems which are extremely biased towards the white-skinned people, and they cannot easily detect the melanoma skin patches or lesions on the dark-skinned people. If you look at these two are the representative data sets, ISIC-18 and ASAN. Both the data sets, a network trained on ISIC-18 may struggle with darker skin tones, while the one trained on ASAN could also fail on light skin tones. And for training deep neural networks on skin segmentation or lesion detection, these two are our only options. They are very well documented, they satisfy all the medical parameters. So, can we really overcome these challenges with limited data sets? The answer is yes. We have to augment them, we have to mix their patterns, we have to make a smooth transition. Only then it is possible. So to meet up these questions, recently this year we published one very nice paper in the MICAI conference. MICAI is the most acclaimed conference in medical imaging. And we gave a solution where we are using data augmentation through adaptive mix-up sampling and also cross-sampling across diverse skin tones. Basically, we are mixing the lighter and darker skin tones to make a smooth transition and creating new images to make our classifier much less biased towards the, the darker skin patches. This work and all its codes, etc., are available from the website of MICAI, and it may mark a significant step because we can actually artificially populate the data sets. So, 4 emerging issues that the modern AI powered by LLMs and VLMs must overcome: bias, lack of explainability, ethnical concerns, and misinformation. We have miles to go before we can flip. Explainability is very important. It is an essential condition for marketing any such AI system. Bias and fairness, we have to be very careful about them. Continuous monitoring is essential because the demography and the distribution of the training data can change. Nowadays, all AI systems operate through lifelong learning, so they can update themselves through continuously getting new use cases, new patients, new training data. And for those new things also, the bias and fairness must be mitigated. And finally, adoption through explainability, clear, understandable explanations of AI decisions increase the adoption for healthcare professionals, in fact, for all professionals who are using AI. So with this, I would like to thank you very much for your kind attention. This is a picture of Professor Prashanto Chandra Mahalanobis, who was the founding father of my institute, Indian Statistical Institute, who is welcoming Professor A.N. Kolmogorov, another giant statistician from Soviet Russia, long back in April 1962. So, thank you very much for your kind attention.
Professor Swagatam Das, please applause to the speaker. Thank you very much. You are welcome here in Russia. Thank you. Аплодисменты, Swagatam Das.
A round of applause, please. The professor of Indian Statistical Institute, Swagatam Das, was talking about the scientific approach to building a transparent and fair and unbiased AI for the future. And now I'd like to name the companies without which AIJ24 would not happen. Would like to thank our partners for their cooperation. General partner Dom.RF, our special partner Yandex, the Russian Fund of Direct Investments, our investment partner. The fund every year is the partner of the conference. From 2019, Sibur is our official partner who supported AI Journey this year again. Our strategic partners, thanks to them, Kaspersky Lab, T-Bank, and Navio. The partner of the conference is Rusagro Group.
We're moving on. One of the biggest questions is, how do you build trusted relations between a human being and AI? The next speaker will talk about precisely that. He identified key trends in AI, the development of generative AI, implementation of technology in healthcare, energy, and education, and a more natural and a more organic interaction between a human and a machine. The topic of his speech has to do with steganography, a way to encode information in IoT. Please give a warm round of applause to Dedi Darvis. Lecturer and Dean of Engineering and Computer Science Department of Indonesian Technocratic University, Dedi Darvis. Steganography of images based on AI for secure transmission of data in IoT systems.
Thank you. Good morning, everyone, and participants of the 2024 Artificial Intelligence Journey International Conference. Let me introduce myself. My name is Dr. Science Dedi Darvis. I'm Dean and Associate Professor at the Faculty of Engineering and Computer Science, Universitas Teknokrat Indonesia, one of the best private university in ASEAN. My presentation AI-based image steganography for secure data transmission in IoT system. This is the second. I am invited to speaker in international journey. Let's start by reviewing the agenda for today. We will begin with my research project is related to AI, steganography, and IoT. And then AI steganography and IoT concept. And last, the future of AI power steganography in industrial IoT. Ladies and gentlemen, this is my research project is related to AI, steganography, and IoT system. Number one, my project is titled A New Approach of Steganography on Image Metadata. This is project research I'm conducting to 2022. And then this is my research related to steganography. I'm using LSB, least significant bit method, to embed it into metadata image. And the format are GPG, PNG, and the another format. Number two, digital smart collar, monitoring call health using Internet of Things. This is my research related to Internet of Things and artificial intelligence. I'm using artificial intelligence to predict call health, and then I'm using Internet of Things to monitoring and control by handphone, tablet, and website. My project is Digital Smart Collar, published article in Scopus and IEEE at the 2022 year. Next, my project is related to AI, is application of neural network based artificial intelligence in steganography. This is my research and this is my project. I'm delivering to presentation at Artificial Intelligence Journey 2023. I'm to collaboration to artificial intelligence and steganography. And then this is my article published in Scopus 2023 year. Next, number 4, my research is titled IoT for Monitoring System for Cattle Growth Productivity. Now, my project IoT is related to combination to artificial intelligence to cattle growth. Artificial intelligence I'm using to prediction to algorithm naive bias, and then I using to IoT to monitoring and control by handphone. This is my research published in Scopus and IEEE at 2023 years. Number 5, the application of the point monitoring method for Tapis Lampung using pattern recognition. This is research related to artificial intelligence. Yeah, you know, Tapis Lampung. This is Tapis Lampung for especially in Lampung province in my country, Indonesia. The last, my project research is comparison of key nearest neighbor and naive Bayes algorithm for identification of Lampung batik siger and Sembagi motif. Yeah, this is my research related to artificial intelligence, to classification and comparison algorithm using key nearest neighbor or KNN, and then naive Bayes algorithm or NBC. Yeah. This current year, I'm developing two combination to 3 method AI, and then steganography using in IoT system. AI, I'm using prediction and classification. Steganography, I'm using in data security. And then IoT, I'm using to controlling and monitoring. So, ladies and gentlemen, what is artificial intelligence? Artificial intelligence refers to the simulation of human intelligence in machines that are designed to think, reason, learn, and action in ways that mimic human cognitive abilities. AI systems use algorithm, data, and computing power to perform tasks that would normally require human intelligence. So, what is called technique AI? Technique AI in machine learning, deep learning, and natural language processing, and then computer vision. Machine learning is a branch of artificial intelligence that focus on the development of algorithms and statistical models that enable computers to learn from and make prediction or decision based on data. Yeah, machine learning is the popular in artificial intelligence. Artificial intelligence must to using machine learning. And then deep learning. Deep learning is a specialist subset of machine learning that use neural network with many layers to model and solve complex problems. This is deep learning, this continue and machine learning. Natural language processing is a branch of artificial intelligence focused on the interaction between computers and human language. For example, you can using chatbot, yeah. And then computer vision. Computer vision, a field of artificial intelligence that enables computers to interpret and make sense of visual data from the world, such as image or video. For example, you can computer vision in robotic for human, and then robotic for service, yes, and then another to implementation to robotic. So, what is steganography? Yeah, steganography is the practice of hiding information within other information. It differs from cryptography. You know cryptography, yeah, which is the practice of converting information into a code to keep it secret. Steganography has been around for centuries, but with the rise of digital communication, it has become more important than ever before. The need for steganography, yeah, in today's digital world, and especially in Indonesia, data security has become a major concern with the increasing amount of sensitive information being transmitted online. It is crucial to ensure that this information remains confidential and secure. This is where steganography comes in. Unlike cryptography, which involves encrypting data so that it cannot be read by unauthorized parties, and then steganography involves hiding data within other seemingly innocent data. This makes it much harder for hackers or other malicious actors to detect and intercept the hidden information. Yeah, this is steganography concept. Steganography often to data security, and then digital forensic digital, yes, and then the cyber security. Okay, so what is Internet of Things or IoT? Yeah. The Internet of Things, or IoT, refers to a network of interconnected physical object and then device or things, and that with sensor, software, and other technologies that enable them to collect, exchange, and action on data over the internet. IoT enables a seamless communication between device system and user, leading to smarter environments and improved decision making. Ladies and gentlemen, how IoT works? The first, sensor and actuator. Sensor and actuator, you can Raspberry, ESP32, and then another device. And then you works using Internet of Things. You need connectivity. You can connectivity in the Wi-Fi, wireless, Bluetooth, and another device. And number 3, data processing. Data processing, you can database MySQL, MariaDB, data mining, and another software processing data. And then the last, decision making and action. You can recommendation and then prediction with AI, classification with AI, and clustering with AI, and then association rule with AI. This is Internet of Things enabled to combination to artificial intelligence, and then you can to data security using steganography. So this is introduction to artificial intelligence transforming industries. Now, AI can automate, optimize, process, and provide valuable insight across wide range of industrial application. And then AI power system can increase output, reduce error, and streamline workflow in manufacturing, logistic, and beyond. And then AI algorithm can analyze vast amounts data to uncover hidden patterns and inform critical business decision. Now, this is introduction to IoT system and security challenges. Number 1, data privacy. Number 2, data integrity. And number 3, device security. Now, data privacy, sensitive information transmitted by IoT device requires protection from unauthorized access. And then data integrity, ensuring data authenticity and preventing unauthorized modification is crucial for reliable operation. And the last, securing IoT device themselves against malware, hacking, and other attacks is essential. Okay, this is overview of image steganography technique. This is algorithm or method using steganography. For example, number 1, least significant bit or LSB. LSB in general method and the first method steganography in digital era. Least significant bit to word modifies the least significant bits of image pixel to embed secret data. LSB and MSB. LSB least significant bit or MSB most significant bit. This is LSB in general to technique or method in steganography. Number 2, pixel value differencing. Utilize the differencing between adjacent pixel values to embed secret data. And then number 3, discrete cosine transform or DCT domain. You know, DCT domain embed secret data within the DCT coefficients of image block. You can image. You can to video file, audio file, MP3 file, and another digital file. You can using steganography. The last, neural network and AI. Now and current year, steganography to combination in artificial intelligence, based neural network or artificial neural network used in artificial intelligence system to train data in pixel. What is principle of AI-based steganography? AI-based steganography utilize deep learning algorithm to enhance the embedding and extraction process. You can deep learning model, adaptive embedding, and robust extraction. This is proposed AI-enabled image steganography framework. You can data processing. Secret data is prepared for embedding, ensuring compatibility with the steganography process. And then you can AI-based embedding, AI-based embedding, deep learning models. You can do a deep learning model to embed data, a cover image, optimizing for imperceptibility and capacity. And then number 3, secure transmission. The stego image is transmitted through IoT network, concealing sensitive data within the image. And then the last, AI-based extraction. A train of model extract the hidden data from the stego image, ensuring data integrity and confidentiality. This is the challenges in securing IoT system. Scale on complexity, and then resource constraint, and then diverse attack vector. So this is the leveraging steganography to enhance IoT security. Number 1, data concealment. Steganography hides sensitive data within benign-looking digital media, making it invisible attackers. And then number 2, a tamper-proof communication. Steganographic technique can enable secure command and control of IoT device even in hostile environments. The last, secure firmware updates. Steganography can facilitate the delivery of firmware updates without exposing IoT device to tampering or interception. Ladies and gentlemen, so this is AI-based image steganography for Internet of Things. You can developing the 3 combination algorithm AI and then steganography using IoT, the step-by-step. Number 1, integrating AI with steganography. Number 2, mechanism of AI-based image steganography, and then advantage for IoT system, and then the last, use case and application in real-world scenarios. So, overcoming adoption barriers, strategies, and best practice. Key consideration, and then best practice, and then driving adoption. So, ladies and gentlemen, this is AI model for steganography and IoT encoding and decoding. Now, you developing steganography technique and algorithm, you can 2-step encoding and decoding process. This is I'm developing for model combination AI steganography in implementation to Internet of Things. encoding process. The first encoding process, you can include cover image. You can include cover image with format JPEG and then PNG and another to format the image. You can also to audio format and then movie and then the digital format. The second process, you can include secret data for IoT. Yeah, this is, for example, cover image, and then this is secret data for IoT. You can embedding secret data to image, steganography. And then you train using neural network model. This is the AI function, neural network model. You can also to artificial neural network, fuzzy, and then the algorithm, artificial intelligence. And then you process to training data, and then loss function, and then the last, stego image. Stego image is merging between cover image and then data for IoT. Yeah, this is merging. Okay, this is encoding process. So, why decoding process? Nah, decoding process, the first step is including stego image. And then you train neural network model, and then decoding process, and then message merging, and then secret data to IoT. Yeah, this is AI model I'm developing to AI steganography in IoT system. Okay, why? Ladies and gentlemen, this is application and use case in industrial monitoring. This is my project in Indonesia and my product using industry in Indonesia. Digital smart board. Digital smart board, this technology was developed in the energy saving and environmentally friendly ship industry. This ship uses solar power to power the engine and lighting. This ship is also equipped with IoT to control the entire ship system. Yeah, this is namely a technology in development digital smart board. And then this is my project sponsored by Ministry of Education, Republic of Indonesia, 2024. Yes, this is my team to implementation digital smart board in freshman in Indonesia. The next project, application and use case in smart manufacturing. We in Universitas Teknokrat Indonesia with Center of Excellence, I'm conducting in development digital smart composter. This technology is used to manage organic fertilizer, from animal waste automatically and can be monitored in real time using neural network based IoT to prediction the maturity of organic fertilizer. This system is also protected by steganography for data security. Yeah, this is my project is namely digital smart composter. This is digital smart composter. I'm implementation to Indonesia and then the using agriculture. This is my project in developing in 2024 years, and then this sponsored by Ministry of Education, Republic of Indonesia. The next project I'm conducting to digital smart collar. Yeah, digital smart collar. This is application and use case in healthcare innovation. This is my project I'm implementation to Indonesia. This is technology can be used to monitor co-health in real time using AI and IoT protected by steganography. I'm using artificial intelligence to prediction health call, and then I'm using Internet of Things to monitoring and control health call, and then I'm steganography in data security in Internet of Things. And the last, my project in Indonesia, this is application and use case in smart home security. Yeah, this is my project sponsored by Universitas Rakyat Indonesia, and I'm namely project is IoT Smart Home. Yeah, this is technology is able to control security system in homes or buildings. The way this tool work is that all home security system can be controlled using IoT. A part of that, the system also use AI and steganography for data security. Okay, so I'm to testing and then experimental evaluation and performance analyze for AI-based steganography in IoT. The first, I am testing to sensor capability test and IoT. I'm using 3 parameters: temperature sensor, IoT camera, motion sensor. And then test parameter to temperature sensor accuracy. In the get result, 98.5%. And my analyze the temperature sensor so high accuracy and reading data, ensuring reliable input for encryption and embedding. And then I'm testing sensor IoT camera, and then test parameternya. Parameter is resolution, and then get a result 1080 pixel. My analysis is the camera resolution is sufficient to support image-based steganography. Yeah, and then I conducting to test sensor motion motion sensor, and then result 96.8%. Okay, and then I'm testing my research or my product. This is artificial intelligence capability test and IoT system. I am using 3 parameters: message detection, accuracy, model training time, and process latency. This is result in test in IoT system. Okay, I'm also conducting to experimental evaluation and performance to steganography capability test imperceptibility. I'm conducting to test imperceptibility with respondent. Yeah, I'm to respondent to different and cover image and stego image, and then test result imperceptibility. 90% respondent asked to no different, and then 7% respondent to ask slightly different, and then 3% respondent to ask different. Yeah, this is you can measuring image, quality image steganography. This is imperceptibility. Okay, I'm using the test to my algorithm to developing steganography, and then capability test for MSE, PSNR, and SSIM. Yeah. I'm using 3 parameters: MSE, PSNR, and SSIM. This is MSE, get result, and 0.0056. Yeah. My analysis, this is result, is very low error, indicates minimal modification of the host media. You know, this is MSR, good quality. This is near to 0. Yeah. And then PSNR is peak signal to noise ratio, get result 40.2 dB, decibel. dB is decibel. This is a good PSNR because more than 40 dB. And then I'm test steganography capability, test for robustness. I using 3 parameter, Gaussian noise, JPEG compression, and then host media cropping. Yeah, this is a result. Noise presentation 10%, and then 50%, and then 20%. And extraction success to more than 80%. Yeah, this is my conclusion. I'm developing algorithm steganography using AI in IoT system, success. Okay, as the integration of AI and steganography centers to evolve, the future of industrial IoT will be marked by unprecedented levels of security and innovation efficiency. Unlock the full potential of your IoT ecosystem and stay ahead of the curve. The last slide, conclusion. The deeper conclusion of this presentation is that the advancement of Internet of Things technology has brought significant progress across various sectors, but also present substantial challenges in data security. In IoT ecosystem, threats such as eavesdropping, cyber attacks, and data theft have become increasingly complex, requiring innovative and adaptive security solutions. The integration of artificial intelligence and image-based steganography technique over a revolutionary approach to protecting data transmitted over IoT network. AI enhanced steganography by leveraging advanced algorithms to conceal data efficiently, minimize the likelihood of detection by unauthorized parties, and improve resilience against digital forensic analysis. This approach not only ensures data confidentiality, but also enhance the overall reliability and efficiency of IoT system. Thank you.
Dr. Dedi Darvis, thank you very much. Thank you for this fascinating performance and sharing the vision of steganography with AI in Internet of Things systems. А мы продолжаем, но прежде
And we are continuing. And before we move to the next speaker, we suggest you become a co-authors of an NFT image. Artyom Tkach, the digital artist, will now have his take on this NFT image. Artyom, hello. You have been working with computer graphics for 12 years, and who are digital artists, and what tools are you using? I use various tools, including neural networks, of course, and I'm not only talking about the generative NNs, but more utilitarian tools, such as motion capture tools. I use it to animate 3D characters, and you can animate now not only by showing anything with hands, but you can move your face and the machine will recognize that and capture that. Together with the viewers, I would love to create the artwork that would, for some time, serve as an interior design object on this stage. Who are digital artists? If you know about the market of art, it has been there for a couple of decades now, even hundreds of years, but digital art market is actively developing in the last several years. And it is developing on the back of blockchain. Without blockchain, I wouldn't be able to sell my artwork, my original artwork. And this is how I can work with my customers. Some authors, of course, were working with the galleries, but it was very hard to prove the original nature of the artwork. And thanks to NFT based on blockchain, I was able to sell my art, and there are galleries that represent me and my colleagues. And for example, I exhibited in Moscow, Beijing, in Dubai, on the largest facades in Europe and other international modern art exhibitions. We before created the art just for the viewers, but it was not participating in any market. Now you have the sales, you have the market, and this technology really gave me and my colleagues the new world that we live in today. And you're talking about the promotion tools as well. Yes, absolutely. And why I am here today with you. I want to tell you how to create digital artwork. It will be a landscape, and it will be comprised of a number of elements. You can become an author of an element. You have to go through a short survey with maybe 1 or 2 questions. I'll take data from there and generate a prompt. And as an author, I will assemble this landscape. At the end of this block, in about 2 hours, I will present this work. There's a QR code with the survey, so please feel free to scan the QR code. There's just a couple of questions in the survey, and we will co-create this artwork. And to create this artwork in the collaboration for AIJ 2024 conference. Thank you very much. That means that anyone can participate. Thank you very much, Artyom. Please engage in the creative work in your digital workshop. We have a QR code. You can take part in creating this artwork. Just fill out the survey, and you will be one of the co-authors, co-painters of the artwork. Yeah, the QR code is on the screen. And start to create. Moving to our next speaker, the mobile robotics the industry has been working on developing dynamic systems. It is interesting that the mechanistic knight was developed by Leonardo da Vinci in 15th century. What do the experts in this area are doing right now? Well, Gonzalo Ferrer will expand on that. Your applauses. The head of the mobile robotics lab of Skoltech, Gonzalo Ferrer Minguez, is going to talk about robotic navigations, the navigations for robots.
Hello, everyone. Yes, now we have the presentation. My name is Gonzalo. I will talk today about my personal journey on robot navigation. So this is a research journey that started 15 years ago, and I want to share this with you. I'm personally associate professor at Skoltech. So if you haven't heard about our university, we have like this campus in Moscow. Okay, and basically our objective is to do research and to train next generation of scientists and technology leaders. About my laboratory, I'm heading the Mobile Robotics Laboratory. Here we have some students, some engineers, master students, and we have 2 main goals. Okay, so we work with robots, but we're interested in these 2 questions. The first one is robot perception, how we can use the sensors from a robot to perceive and understand the world. And the second question, this is the one that I will be talking more today. It's about how to actuate in the world. So this is about robot navigation. You have some task, and you want to achieve success on this task. with the robot in this real situation. Okay, so the timeline of social robot navigation looks like this. I started working some years ago. I will present each of the methods. And what I want you to see is the evolution of these methods. Okay, so we will start talking about simple methods that are very efficient. And finally, I want to talk about what are the current directions from research. What is the current bottlenecks that are ahead of us? Okay, so let me start with this first method that we investigated. This is the social force model. This method is from neuroscience, but we borrowed for robotics. Okay? The idea is very simple. Every agent, it could be person, it could be also robot, is just a point where some external forces are actuating. Okay? After summating these forces, so for instance, there could be, well, some objects, like other people, maybe other robot. Each of them is exerting a force to the agent, and as a result, you generate a trajectory. Okay? We know this is not exactly accurate how reality works, but it's a good model to start. So, well, we tried this. Here you can see, like, this is old video that it was recorded in Barcelona, UPC. Yes, now it's playing. So we are here observing like some obstacles, some other people getting on the way, and basically we see how the robot is navigating on these very simple principles of looking at close objects and reacting to them. Okay, so this model was very successful. Okay, it's very efficient. It's capturing people surrounding the environment. So this is something. This is something important, right? Because you need to capture the social interactions. The problems, the limitations, and have in mind that this is already almost 15 years old, is that it doesn't behave well enough in complex scenes. So when there's many obstacles there, where there's more people, it's not really solving the problem correctly. Okay, it's not navigating correctly. It also requires very good perception. So this is the other part I will talk about. Basically, you want to detect people, you want to detect the obstacles, and for this solution that I was showing, it's a simplified version of real perception. Okay? So then we move on. What we thought is we want to do this system a little bit more complex that can handle more difficult situations. So for this, we studied what we call the multi-policy decision-making. It's a simple algorithm where, in essence, what you are doing is choosing between very simple behaviors. Okay? In these examples that I'm showing, we have 3 different behaviors. You can go solo. So this is similar to the previous method that I was showing. To just forward and try to reach a goal. You can stop. Okay, so this policy might look trivial, but actually it's very important. All the time you are just trying to stop because there might be unexpected events, and you can also follow an agent. Okay, each of them is an individual policy, and what is the interesting result about this is that there's an emergent behavior that raises from combining this, okay? So the algorithm is just choosing what policy to execute, but with this you can get very impressive results, okay? So let me play like this video. This was recorded in University of Michigan also some years ago, okay? And what we can see is that this simple behavior actually results in trajectories that we can thought as more intelligent by the robot, okay? So it's stopping, it's reacting, lowering its velocity. It's doing all these maneuvers just with 3 simple policies. Okay, so in this example, we were trying to be adversarial to the robot, creating examples where complicated to solve. Okay, so mostly the robot needs to avoid collisions, and we were just getting on the way. But the results of this are performing well. Okay, so for instance, we have an example. This pedestrian starts running. Okay, and we are able to foresee that there will be a collision, so the robot needs to stop. Okay, so there's also like examples, clutter, the robot cannot really progress on this. Well, this is details, but at the end, what I want you to think about is that this is 3 simple policies that we are combining together, and then the algorithm behaves very well. Okay, as I said, the advantages is computational efficiency, and the second one is that we are capturing risk. Okay, and I will elaborate more on risk later, but it's basically all these situations that could result in a collision. Okay, so collision is something we don't want. Imagine this is a small robot, but this kind of algorithm could be applied to larger vehicles or other kind of platforms. So collision is not acceptable for pedestrians or for other objects. And yeah, so kind of the negative part of this is that we are just choosing a policy, but we are not explicitly avoiding collisions. Okay, so we don't have this as a constraint, and this is a problem because depending on the configuration, you are just going to choose a policy that might result in collision. Okay, and it also requires good perception. So we have the same problem again. We need to perceive the world, and we need to understand if the pedestrian is there, if this is the same pedestrian, if it has this velocity and all these problems that in real world they are more complicated than in this simple example that I was showing. Okay, so we continued a little bit our development, our journey. So now we are just some years ago, and then we start looking at this solution of we want to incorporate risk into our plans. Okay. So for this, we can explicitly add an objective, and we are just going to be optimizing over this. Okay, we can also add this as a constraint. And well, this constraint could be probabilistic, could be deterministic, but the idea is that now the solution will take into account these constraints. If there's a collision, we should be avoiding after solving this problem. Okay. We did this in 2 stages. First of all, on simulation environment, here we can collect data. No pedestrian will be harmed in simulations, so even if there's collisions, we can run more simulations. And we have a second stage, which is the real environment. Okay, so in this case, we will have a robot, and this robot is going to also navigate among people, and we want to ensure that this risk is minimized. Risk of collision, I mean. Okay, so we have here some experiments. Here, this is new robot that we have in Skoltech. We were doing like some experiments of navigating among pedestrians. And well, basically the objective of the robot was to achieve just this goal without collisions. Okay, so it looks similar, but under the hood, the difference on the algorithm is this. So we are now explicitly looking for collisions, and we are avoiding this. Okay, this is another video where we have like more pedestrians working adversarially. Okay, so they are kind of getting on the way, and we need to solve the problem for navigation. Okay, so this is a little bit the timeline. I have simplified things a lot. I have just included kind of the highlights with results on videos and qualitative data. But you see the trend, okay? So we started, some time ago with this social force model, a reactive model that was very simple, but was capable of performing well. This could be improved with the MPDM, right? So this is just combining different policies. And finally, we were taking into account risk. Okay, now the question is, if we have a control environment, we know that robot navigation can work very well. But lately, the question is, we want to have a better navigation policy, and at the same time, we want to perform anywhere. Okay? And this is a fundamental task because it requires to improve the perception system that we have here. So most of our efforts now on research are in these two directions. Okay? So we want better navigation policies that are more robust. We can get very good navigation results, as you see on the video, but they need to be robust to any kind of environment. For instance, here, with these lighting conditions, a lot of people, other objects, will want our robot to be able to navigate in environments like this. Okay, so let's start with kind of, everyone, I guess, will talk about this one way or another. We have foundation models, okay, for language and for vision as well. They are changing the landscape in many topics, in many disciplines, so robotics is also one of them. Okay, they have been trained with large amounts of data, and using them actually makes all this perception more robust. Okay, it doesn't make it perfect. You will see that we need to adapt this to our needs on robotics. But it basically gives us now tools to be used that before were not available. Okay? They were not reliable enough. So for instance, multimodality, very important. We've been investigating visual information matters, comes from cameras, and it gives you a lot of information, but it's not the only source of information. Okay? Maybe text, language could be like important modality to understand how we want to navigate. Maybe audio, maybe depth, okay? Different modalities will make the policy more robust, okay? This is something we're investigating. And then perception, okay? So this is the problem I was saying before. If you don't detect correctly an obstacle, you don't detect correctly a person, you could be having an undesired collision, okay? So one way to improve perception is just providing unified semantics on the environment. So what is this? What do I mean by this? So we have a map of the environment, okay? It could be like a 3D representation like here, and what we want is for each of these regions, each of these objects to be detected, and also to say to what category they belong. Okay, so for instance, in this example, we see some pictures that are observed here. Okay, in this bottom picture, we also see the semantic classes, like for instance, wall or floor or other larger areas on this scene. And we want to combine all of it together. Okay, and that's one limitation about it. Okay. What is exactly these labels that we are going to use? What is these objects, right? It could be very detailed. You could be saying, look, there's 3 kinds of chairs. One of them is like color beige, the other is black. This one has these properties, other properties. There's a lot of metadata on top of these objects, right? While on the other hand, let's say that fixed labels just classify them as the same object, okay? This matters, for instance, if we are interested in people, we're interested in different objects that could be in the scene, and they can interact somehow with the robot, okay? So either by navigation or other tasks, we want to make this distinction. The problem is that these categories could be very unstable, okay? What I mean by this. So in this example, we see table. Okay, this is just the same view, but they are classified as different objects. Okay, so one of them is saying that this is a table, the other is saying that you have a small dining table, and the other result, just few seconds later or milliseconds later, is telling you that this is a wooden table. Okay, and the question is, but maybe for our task, we just want to have tables that are general. Okay, so we need a way to unify semantics. The foundation models gives you like very strong tools to detect any kind of objects, to extract information, and get labels or other kind of description of the object. But for the map and for other tasks, you might want to unify these semantics. Okay, you cannot have infinite number of classes because you have just observed the same scene, just a little bit later. And a little bit later, you get another output. Okay, so this is not good for stability. So what we could do is provide a unified semantic map where it's taking all this into consideration. So for instance, you could have like tasks that are show me the table, or maybe show the wooden table, or show me the small table, and we refer to the same object because we know this has been unified into the same category. Okay, so I think for robots that's important. Foundation models provide you like this tool that allows you to have very precise description, but you want to reduce this, not noise, but let's say variance on what the labels are. You want to get things consistent because, for instance, when you want to do maps, if you don't have the consistent label, you can have errors when you are building the map. Okay, imagine you are seeing now a table, then a wooden table. Are they different? Are not the same? So the system will be a little bit confused. This is a scheme of the general view. Okay, so we do mapping, and on top of the mapping, we are just projecting labels. And well, there's this unified process that is happening here. Okay, at the bottom. But I just want to show the idea because that is about this. This is the unified. You need to unify the semantics. And for instance, this is the result of unifying versus just having open vocabulary with any kind of object that you see. Okay, so I'm going to play it. Well, it's going to play again, I think. Okay, so you see how the open vocabulary is not so consistent in the objects. You see like some of these chairs having like different categories. We don't know exactly what they are, but on the, let me play it again. On the right, you see like colors that are green and red, okay? But on the left, after you have unified semantics, you have kind of the same object, okay? So maybe when you want to run task, even though that the map can be correct, this kind of example could confuse the robot policy, okay? So for instance, one is like two kind of objects, like blue seat and blue chair, while the other is just unifying them. Okay, so a little bit more qualitative results. So this is more about mapping. What is the quality of the mapping that you are getting in here, unifying versus not unifying. But at the end, have in mind that what we want is to execute robot task. And for this, we need to improve perception, okay? So now, the advantage is that we can get out and have like open vocabulary, but at the same time, this is a limitation, okay? So this is how we are solving it, providing this unified view. So what lies ahead robot navigation? I described at the beginning like many models, okay, that are very simple, they are very efficient, okay, and they work very well in control environments, mostly when we have good perception. From there, we saw that the navigation was performing very well, but the challenges were on how to transition to more complex environments, right? Like real scenes. Like imagine this conference today would be very challenging for robot. For this, we have two ongoing research directions. So one is looking at multimodality, especially with images and text, okay? Because what we want is to have more robust policies. And the second is to improve the perception to have also more robust perception, okay? So I think this is the key word that I want to say on this presentation. We want more robustness when we deal with real-world deployment of robots, okay? And the second that is also connected is risk, okay? Most of the examples of collisions are because usually there's a problem on the perception. Okay, so we want to handle this correctly. The only way is not really by improving the policies, as I was showing before, it's also by improving the perception and taking this into account on the robot policy. Okay, so this is like proper end-to-end risk assessment on the system that for us, I think this is like very interesting condition. And it only happens the moment that you get out into non-control environment, like the street or this environment, okay? That is when things start getting more complicated because maybe there's objects or parts of the region that we don't really understand well. Even the foundation models don't give us like clear answer consistently. Okay, so how is this relevant? Okay, so if we want this new generation of robots to be deployed more reliably, we need to solve this problem. So this is the research direction that my lab is now working on. I also provided like this view on how this has evolved over the time. And well, I hope that everything was fine, and maybe there's some questions I can take, or if not, I will thank you for listening. Thank you.
Thank you, Gonzalo Ferrer. Applause to the speaker. Thank you for this very interesting performance. Thank you very much. И мы продолжаем.
And we're continuing. Our next guest from the science world, Vladimir Spokojny, who is not only a renowned expert in mathematical studies and sciences, but he's also a mentor for a lot of promising researchers. Today he is going to talk about the theoretical foundation of AI and how do you correctly assess the results and the correctness of the AI-made decisions. The professor of the Humboldt University, the head of the Stochastic Algorithm Lab and Parametristic Lab of Weierstrasse Institute, the head of AI in High School of Economics, Vladimir Spokojny, the theoretical foundations of AI.
Hello to everybody. I'm very happy to be here. My talk will be a little bit special. No pictures, no applications. I will speak about foundations. And I hope that I can provide some messages which are important also for understanding of the problem of artificial intelligence. So one of the main questions is trainability and reliability of the model of artificial intelligence. This means we train our model for solving a specific task. And we want to understand, is the decision made by artificial intelligence system is reliable, and how reliable? Can we trust to this decision? Okay, so this is the goal, and now I will start to explain the main issues of this study. So maybe the most important issue, we have typically very complicated data and huge amount of data. But at the same time, we have very complicated models with a huge amount of parameters. So, and the more complicated data we have, the more complicated models we apply. And number of parameters grow exponentially with the sample size, with the amount of data. So this is a kind of paradox. The more data we have, the more complex our problem is to train. And then the question is it possible to give some theoretical guarantees for our decisions? Because we have so many parameters which we cannot estimate efficiently. This is exactly the question which I would like to study, and in particular, I would like to see some theoretical guarantees of the decision made by the AI systems. Okay, so I will illustrate most of the result by a simple model, which is nonlinear regression. And in fact, the first method for nonlinear regression was applied by Gauss for astronomical applications. He solved a practical problem of finding a planet on the sky from few observations. So astronauts lost this planet, small planet, and Gauss spent half a day to find it by numerical methods without any computer, just on the sheet of papers. And this model is now a leading model for deep neural networks. So we see this model survives from Gauss to up to now, but the number of parameters grows, as said, exponentially. So for Gauss, it was just a few parameters which coded the trajectory of the planet. And for DNN, we have parameter theta in this equation. Unfortunately, pointer doesn't work. So you see the equation, regression equation, yi is m of xi theta, and theta is a parameter of the deep neural network which codes the whole architecture. This means this parameter is really huge, dimensional. And now the question is, can we train our deep neural network from the labeled data? Every yi is a label given to the input vector xi. Okay? So this means small theta is a vector in the capital theta, which is a subspace of p-dimensional space where p is extremely large. Okay? So this is the setup. Now, what we want to do, we want to study the situation when p is extremely large. So you can say infinite. And the sample size n could be big or moderate, but it's by far smaller than the dimension of the parameter space. And we want to get some theoretical guarantees. And to do this, I would like to introduce the notion of effective dimension of the problem. And this notion is a key to understand the essence of what is going on with all models of artificial intelligence. Okay? So now a very crash introduction in statistical learning theory. I expect not many of you are familiar, so I don't expect this, at least, and I will give you a very short list of notions and definitions, and then I will try to illustrate the main results in these terms. So what is a statistical problem in general? So we have some objective function, capital L, which depends on the parameter v. Okay? Then the typical training procedure is a solving of optimization problem. We try to maximize if it is log likelihood or minimize if it is a cost of this objective function. So v tilde is a point of maximum of the log likelihood or point of minimum of our cost function. Okay? Now we define the target. So, or true value. True value is V star, and this solves similar problem, but given in terms of the data distribution. So data is random, and if we would know the distribution of the data, we can solve this problem efficiently, and then V star will be the true value. So it minimizes what we would like to minimize in average. Okay, so then the main issue in statistics is to understand the relation between these two problems. The first problem is practical, what we are really doing. The second problem can be called oracle problem. This means we define the true value which corresponds to the data distribution. And actually, the whole statistics is a way to understand what is V tilde minus V star, or L of V tilde, so the maximum of the problem minus L of V star. So this is a very brief definition of learning theory. So the whole learning theory is these two lines, okay? The essence. Now, I introduce few notions to describe the main results. This is all what you need to know to look the results. So first two lines, truth and the estimator, are the same as the previous slide. Then we introduce extremely important notion of the Fisher information, or Fisher information matrix, F. So this is a Hessian of the expected log likelihood at the true point. So this is a very important notion which is used both in statistics, learning theory, information theory, physics, everywhere. So this is information, but information about the vector of parameters. Therefore, this capital F is a P times P dimensional matrix, really huge. Then all the rest is defined more or less in terms of this Fisher information matrix. In particular, effective sample size corresponds to the smallest eigenvalue of this function. Then we need to measure the noise in the data. And this noise is measured using the score function, which is defined as a log likelihood minus its expected value. And finally, we define the most important notion, which is effective dimension. And this is something like noise divided by the signal. So you see it is a trace of the variance of the score, variance of the noise, multiplied by the inverse of the Fisher information matrix. So this is all the definitions we need to understand the essence of the learning theory. Okay? So now I show you very briefly the overview of the main results. And then we will proceed with the conclusions. So this is extremely simple to understand and extremely difficult to study. So first result is called concentration or consistency. And this result requires that the effective dimension of the problem is smaller than effective sample size. And under this condition, we can say that V tilde is indeed close to the V star. This means what is the result of training of our model or deep neural network is close to the target, to the truth. And this can be again measured in terms of the efficient dimension and Fisher information. So this is the first result about concentration, which is extremely important. And it gives the view on the essence of the statistical problem. So once again, I show you the definitions. So we have Fisher information, we have effective dimension, and we have effective sample size. Everything is given in terms of our objective function, log likelihood, and with this notion, we define something like law of the nature. The model can be trained nearly consistently only under the condition that the effective dimension is smaller than effective sample size. So maybe most of you are familiar with this, and intuitively it's also clear. We cannot estimate more parameters than the number of observations we have in our disposal. And this is exactly this law. If you want to do kind of inference, this means if you want to study singular elements of your, say, network, particular edges or nodes, you need even stronger condition. So, and this is given in terms of the Fisher expansion. It tells that the effective dimension should be smaller than square root of the effective sample size. And for some other problems, you need even stronger conditions that effective dimension is smaller than sample size to the 1/3. So what we see here, different type of conclusion requires a critical dimension condition, which is indicated here in this result. And in all this result, you see that effective dimension of the problem cannot be too big. Now we are in the trouble and the question. So how it can be that we have our model, which is highly overparameterized. Yeah? So we have models with billions of the parameters. And the theory tells us it could not be. We cannot train this model by data because we need this condition. P is smaller than n. How we can avoid this? How we can get theoretical guarantees? The standard approach here in statistics and learning is to use structure. So what we say, a real structure is simpler. So we have a lot of parameters. Most of these parameters actually are not important, can be thrown away. This is the structure of the model. And this is exactly what helps us to reduce the effective dimension. So effective dimension can be viewed as the complexity of the model, real parameters, which we really need. Not all the parameters, but those which we really need for describing our model. And how we can do this? Typically, the structure can be expressed using the penalty function. So this is a mathematical way to do this complexity reduction. So we consider penalized log likelihood, where our objective function is penalize something which means the complexity of the model. This means when we maximize this expression, so L of V minus penalty, we don't like to get a very complex model because penalty becomes huge. So this is the idea of reduction of the complexity, and typical examples of the penalty could be quadratic or rich regression or L1 norm, which is known as lasso regression. There is a lot of other proposals. Then, so what we get out of this, we get instead of three optimization problems. One is which we really train now with penalized log likelihood. We maximize this expression, which means fidelity term minus complexity given by the penalty. Then we have what is called population counterpart, V star G, which is the same maximization of the expectation, and V star is the original truth. And now we want to understand the relation between V tilde G and V star. Okay? So this is the idea of reduction of complexity using penalization. So in the study I describe here, actually the answer is given in a similar way. It is written below. Actually, if the penalty is smooth, you can describe the bias introduced by the penalty using the gradient of the penalty, which is similar to the noise. This means we have two sources of corruption, one due to the noise, one due to the penalty, and then each of them can be described by the decomposition, which I call Fisher decomposition, Fisher expansion. Good. Finally, you can put all together. Maybe I skip the details and show you the theorem, which is written here. And this theorem tells us if we have our trained model, V tilde G is our trained neural network. V star is a truth, what we want to achieve, which is not known because it relies on the unknown data distribution. Then we have two leading terms. One describes the impact of the noise, and the second term describes the impact of the penalty. Okay, and then we have in the right-hand side the remainder, and this remainder has the order which I explained already, p over square root of n, where p is the effective dimension of the problem, which is now reduced due to penalization. Because in the penalization, so maybe I show you what's happening here when we introduce the penalty. We replace the original Fisher information matrix by the FG, where FG involves the Hessian of the penalty. And this is exactly the idea of reduction of the complexity. If we have a structure, it can be described by the penalty, and this penalty actually serves for reduction of the complexity of the data, and then we can achieve the goal that the effective dimension of the problem after including the penalty is smaller than the sample size. So this is a key observation for the theory. So what is funny, so the main tool for this theorem is the perturbation optimization theory. And actually, it connects two optimization problems. One is based on the function f. Then we have a perturbation which could be linear, like here. Here, g is a linear perturbation of f. Or it could be smooth. And then we need to understand the relation between the solution of original problem and the problem after perturbation. And first result of this form was established by Newton. So we see, people like Gauss and Newton made the first contribution to the modern artificial intelligence. Okay. So this is the result. So this is a similar result for smooth penalization. So this is a list of messages about what I said. And maybe the most important message of the theory is that the problem with statistics, which is called curse of dimension, which means that the result in high-dimensional statistics are very poor if the dimensionality growth should be replaced by the notion of the critical dimension, which means that the effective dimension of the problem is smaller than the effective sample size. Okay, now I would like to illustrate this by two examples. So very simple. So I consider deep neural network. So in this example, it's not deep, only one hidden layer. But it's just to explain the ideas. Otherwise, it can be extended to multi-layer problem as well. So we have our data, labeled data. Why are our labels given the input vector x? And basically, in this case, the whole parameter vector is a matrix W, which connects the input x and nodes of the hidden layer. So the W is the matrix of edges. Okay, then the objective function or log likelihood is a sum of misclassifications in this particular example. And this depends on the vector x1, which is activating function applied to w of x. So we want to recover the matrix W from our input data. So if we have high-dimensional input and a lot of nodes in the hidden layer, then this matrix could be very large. Okay? And now we want to understand what is the effective dimension of the problem. In this particular case, it's actually relatively clear what is the effective dimension. It's the number of edges which are non-zero and significantly non-zero. Okay? But how we can achieve this? This problem, unfortunately, is highly over-parameterized, non-concave, non-smooth. But the most important issue is actually lack of identifiability. This means the nodes in the hidden layer can be exchanged together with the edges, and this will give you the same neural network. Okay? So the order of the nodes is not unique. And this is probably the main issue for the theory, and what is suggested is that we introduce a structure in the neural network. So this is the question, how the structure can be introduced. Very simple way. So what we are doing, we say, the first node in the hidden layer is the most important. The second is less important, and so forth. Yeah? The number of the node means importance. And then, for every edge which we effectively use, we pay a penalty function which increases with the number, with the corresponding number of the node. This means any edge to the first node costs nothing. But if you draw the edge to the node number 10, it will cost much more. And if we do this, then it leads to the penalty, which is a penalty function which is drawn in the first line, where this SMJ are factors which grows with a number m and number g, most important number g, polynomially. And if we introduce this penalty, this is a kind of mystery, which what is happening, then the effective dimension of this problem becomes finite. Even if you have huge number of nodes, effective dimension after this penalization can be controlled. And this is explained why a real neural network can be trained. Because, in fact, after proper regularization, these are the problems with not so big effective dimension, and therefore this magic condition, critical dimension condition, is fulfilled. The other example is sparse estimation. So for this example, what is assumed is that our output depends on the input vector theta, which is sparse. This means only few coefficients are important and non-zero. The other are zeros. And then you can have a huge dimension of the vector theta and only a few observations wise. So this is a typical statement of the problem, and a classical solution is a loss of solution, which means we add L1 penalty. Unfortunately, this approach does not explain the effective dimension of the problem. What is the effective dimension? So intuitively, it's clear. If you have sparse vector, effective dimension corresponds to the sparsity, number of non-zero coefficients. And then we want to apply the theory and derive this effective dimension. But it doesn't apply to lasso because L1 norm is not differentiable, non-smooth. So, but if you redefine this penalty using different proposals, you can use spike and slap penalty, or you can use interaction penalty. Maybe I jump over all these examples. But then you can redefine the feature information and get the result which gives you, again, the effective dimension corresponding to the sparsity. So this is two examples of applying this theory. But in fact, we are working very intensively on this, and current list of examples which we already considered includes many real applications like multi-view models, error and operator models, nonlinear partial differential equation, matrix completion and recovery, Gaussian mixture, and many other. So I think I can conclude at this point. And again, I would like to stress the most important message, which says that stable and reliable statistical learning is only possible under critical dimension conditions. This means effective structure of the model should be such that the effective number of parameters is smaller than effective sample size. Okay? And then, if we study the procedure, any training procedure, the main question is whether this training procedure is structure adaptive, whether this procedure is able to recover the underlying structure. So I think this is a message, but it's only starting point, and we have a lot of problems which are still under investigation, and all of them includes the issues of identifiability, non-concavity, non-smoothness, etc. And yeah, so everybody is invited to also to contribute. Okay, I think I am done.
Vladimir Spokojny, ваши аплодисменты.
Vladimir Spokojny, a round of applause for you. Vladimir, thank you very much. If I may, I would like to ask the questions in Russian. We have a few questions from the audience, but first I would like to once again thank you for this amazing lecture. We have so many people in the audience eagerly listening to your presentation and enthusiastic about such fundamental areas. I really felt like I was back at school, back in college. I hope you're not going to test me on stochastic elements. So taking this opportunity, I would like to ask you a few questions from the audience. So many questions and so little time. A question, a particularly difficult question. What are some of the areas of research in AI theoretical foundations that are the most promising in your opinion? It is indeed a very difficult question. We do have a lot of smart people in the audience. Well, I think my entire lecture was my attempt to answer this question. What I'm interested in is the boundaries of AI. Sorry, I'm speaking Russian. Is that okay? I hope it's okay. So we want to figure out what are some of the problems that AI can solve, and can we rely on these solutions? This is the key issue for me, and I would like to find a mathematical explanation of it, a mathematical basis for it. So what I was presenting today was a description of one step toward it. Thank you very much. Thank you for the fascinating lecture, for such a deep dive into it. Vladimir Spokojny, this applause is yours. Professor of Humboldt University, head of Stochastic Algorithms and Non-Parametric Statistics Lab of Weierstrasse Institute, academic supervisor of Theoretical Foundations of AI Models of the Higher School of Economics, Vladimir Spokojny. Thank you very much for that lecture once again. We move on. We all know how important it is to combine theory and practice in science and how great minds can help us understand the most complicated and elaborate processes of AI. Welcome to our next speaker, the Doctor of Mathematical Sciences and author of hundreds of research papers, Alexander Gasnikov.
Научный сотрудник, доктор физики.
Research fellow, PhD in Physics and Mathematics, rector of Innopolis, Alexander Gasnikov.
И сравнительный оракул. Ускорение и стохастический случай.
Acceleration and stochastic events. Hello, colleagues, and today I will be talking about the NIPS article published just this year. It is being presented as we speak. The article is about the comparative oracle, but basically this is something that AI literature often refers to as Radicchev. You can see this here on the slide in the corner. And so let's begin. What was the motivation? The boom happened in 2022 with the publication of an article in May 2022 by OpenAI that described InstructGPT. The article was called Training Language Models to Follow Instructions with Human Feedback. So this human feedback is a very important addition. When an LLM, using settings from some small number of hyperparameters, gives you an outcome and you compare it with an outcome of some other model with some slightly different parameters, it's very difficult sometimes to apply quantitative assessment to the texts. But you can say that you like this text, you prefer it to the other. This is called feedback, this comparative feedback, preferential feedback of humans. It is based on your preferences that you can apply to the outcomes. And this is unusual because the usual situation is you get the gradient of the function and you try to spot the minimal of a function based on the feedback. It didn't take long, because just a year later, oh, by the way, this article that I showed by OpenAI, it was a harbinger of what happened in November 2022. It was a huge publication about ChatGPT by OpenAI. The word open sounds a bit ironic, but nevertheless. A year later, at another NIPS, another article appeared called Is RLHF More Difficult than Standard RL? The highlighted sentence, if you read it, you will see that the answer is roughly along the lines of, no, it is not more difficult. In simpler terms, if you're looking at an RL problem, a reinforcement learning problem, if you are considering the usual reward system or the loss function, which is set, well, that's one approach. Another approach is when it is not set, and you can only compare whether this output is better than the other or worse, but not qualitatively. You just say, but not quantitatively, you just say it is better or worse.
So, like, the second feedback is kind of limited on the one hand. On the other hand, it helps you to train with the same quality. Yes, that's of lower quality, that's slower, but, you know, logarithmically speaking, it's not that bad, it's not worse. That was a result that was achieved a year ago with the RLHF class of tasks. If we take a general optimization, task optimization classes, we have to understand what task do we want to resolve, what problem do we want to resolve. We have a function, and this is we need the stochastic optimization, and we have various options of putting the problem. We have x and y dots, and as a response we have a sign, -1 or 1, the digit. Moreover, it can have some noise, so it is possible that f from x minus f y will have some noise. I'm not going to talk about that in detail, but I just put it on the slide to make sure that you understand that we can do these things, and our paper actually talks about that. We have estimations on the possible level of noise, permissible level of noise. I'm not going to talk about that in detail right now. The second concept is related with the feedback, or the oracle. That does not give you the value of the function, but give you the value of the function on some implementation. So you can sample f from x with psi and compare f x psi with f y psi. And we are going to look into various problems so that you understand that it is actually applicable. On summer 2023, a physical technical university student, Andrei Krasnov, reached to me, and he said that he is making a smart coffee machine together with the other students of the university. The idea is simple. You set a couple of parameters, like the volume of the amount of milk and sugar that you're going to put into coffee. That means the proportion. And the person tests this coffee, changes the parameters, and tastes the coffee again, and gives the feedback to the coffee machine to say whether they liked the coffee or not. Now, the task was the following: how to make sure that you select the best coffee for this particular person while minimizing the number of attempts. This machine can learn based on different people. Every person with its own psi, right? One person is doing the labeling here. They compare it, and there's another person. He also compares it. He wants to fine-tune, we want to fine-tune the model, the coffee machine for an average person. This is the stochastical problem, and the results were as follows. The results are complete, I would say, in this way or another. We thought that it was pretty simple, and there was a request from Quantic journal, fantastic journal, by the way, excellent journal. It's really a fantastic journal for kids. Together with Nikolai Andreev, with the same one that I talked about in my presentation. So we wrote an article on how to find the best chocolate bar, the most tasty one. And we wanted to test how much strawberries there were in the Sber-produced chocolate bars, but Mr. Vedyakin and Mr. Niznamov gave me a lot of chocolate bars like that. So I was going around the schools and I was giving out these chocolate bars. Obviously, the children were very excited. But anyway, I'm going to tell you how do you make a smart chocolate bar. We will start with an oracle. You have to find the combination of the cocoa beans to make sure it's not that bitter, but at the same time shouldn't be too sweet. Right? So the amount has to be optimal. We take 2 chocolate bars. You see the first diagram here on the left, and if we have a general understanding on how the tastiness function looks like, it seems that this is this function, and we give to an expert the possibility to taste various chocolate bars with various with the various share of ingredients, and we had the raspberry there. Now, if we take these dots in the like 1/3, then 1/3, and another 1/3, after the iteration, we'll have a 2/3 that will be left. So we take a section nearer to the dot that is smaller. We remove this section, and we have this yellow section that remains, and the same applies to the next stages. We see that we divide the section into 3 and do the same thing. We will find the epsilon solution after logarithmic calculation. In terms of the logarithmic dependency, it's optimal, epsilon-wise, but it's not really optimal in terms of the foundation of the algorithm. You can do a better thing. The golden ratio method is here on the slide, GRM, golden ratio method. So the idea is pretty simple. We should not remove the dot that remains. We have to use this dot and to add another one. And based on this assumption, we have to select a new dot so that the section that we remove, that removes a dot, does not change anything, and on the remaining section, remaining dot can be used as a base to continue the calculation in a similar way. So there should be similarity, and based on this similarity, we understand that the relation between these dots, especially the dot on the right, should be F. That's a golden ratio. We're talking about the green section. The ratio of the yellow section to the red section should be F as well. That's the golden ratio method. I'll speed up a little bit to have a Q&A session. We had a 2D generalization. It's a very beautiful one. So the thing I talked about was for the school kids, how to select the best chocolate bar. Now we have a 2D generalization where we have 2 variables, 2 ingredients. It will be published in Quantic Journal very soon, but I can take some pictures from this article. We have the problem of optimizing a 2-variable function, and the height level is 3 kilometers, and the section that we have for the surface of 3 kilometers is reflected by these multiple levels. We take the square. We have a vertical line that divides the square into rectangles. We try to find the maximum on the section. We find the dot on the drawing. We go to the left and to the right a little bit. We see where the value is larger. The section with the higher value remains. With a smaller value is removed. Then the rectangle is divided by 2. We have this section in the middle. We try to find the maximum value there, and the same goes again. So this is how we do it, and we'll have this logarithm in this square. 3D and 4D is also possible here. But it's not really good to generalize it like that, because the factor of the algorithm will grow together with the factor of the space, and If you achieve 10, then it will not be practical. Now, what is the idea I will use gradient method to show you how it's done. So the initial target function is the models. We replace the complicated function with a parabolic model. What is a parabolic model? We take a Taylor row, replace the Gaussian function with a spherically symmetric function. So we make a top-down assessment of this Gaussian to have this function. So we're building the measurandoms here. So it's measuranda that is built based on the Taylor row distribution. The geometry is pretty simple. We are moving to the minimum of this parabola. This is the gradient descent method. So we replace xk with the target function, and we go to the minimum of the paraboloid of the rotation. That's the idea of the gradient descent that you know about. Now the idea of the method that helped us to get the result. The random coordinate descent, a paper published in 2012. We select the coordinates, different policies to select the coordinates with different level of probabilities. This is just this paper that I exemplified, but there are other papers. Our task is to resolve the task of simultaneous search along this coordinate. But there's an interesting thing here, because if you look at the Nesterov article, we were looking at the step 1 by L that I talked about. And the dot that we had to have in Nesterov method, that's the minimum of this rotation paraboloid. This is a parabola here, by the way. So our gradient method is where we take the dot that is the minimum of parabola. And it shows this is a better result, really, because if we try to prove something with Nesterov method, then we can prove it with the other methods. That's a pretty simple thing. That shows that we have this summarization, and we have a golden section method for this problem. But you have to make this 1D search with some degree of accuracy. Yeah, it's very hard to explain to you all what's under the hood here, but you have two 1D searches, and the idea was to find the component-by-component method that is convergent, but not in an optimal way. So the accelerated method can be compared with the Oracle method. This coordinate method is delivering the results that are acceptable, but we change the Oracle. We change this movement through the coordinate with a 1D search. And that's this Oracle that I've showed about. It needs to be proven. It's not really clear that if you can change the one gradient step with the 1D search, is something that you need. It needs proof. The main result is formulated as this one sentence, is that the Oracle that I've implemented this feedback from the human are basically the same apart from the 1D search. 1D, well, search costs something, the logarithmic number of steps, and the difference of this logarithmic number of steps is the difference between solving a big problem and with the it can be compared with an oracle. So if you have a value of a function, find the minimum. That's one thing. And then you can ask for a function value in various dots, and it's going to be sorted in ascending or descending order. That can seem weaker, but it's weaker by a logarithmic number of times. Now, stochastic optimization, the mathematics here is even more beautiful. You see it on the screen.
Минус f от y, больше f от y или меньше. И здесь мы вводим такой вот.
And here we introduce this method option with additional randomization. So we randomly select the EK direction on the 1D sphere. We select a step ETK in accordance to what is written here. Right, so this is how it's done. It's a Yuditsky-Pollock step. They explain why it's used in great detail in their work, in their paper. Then there is an important limitation, the additive noise. And this is a limitation. I do not know how to address that, but our noise is not focused on zero, because if the noise is focused on zero, it is very challenging, it would be very challenging to resolve a problem of seeing a difference between these two functions. Now, a couple of other lemmas that help to find this result. Now, the function that was introduced, the phi function, this is a feedback from the oracle. This is this sign. We can understand it as a sign of this formula. If it's too small, if you look at the approximation. We can replace this and difference with a Taylor row. And to do so, the step should be much lower, much smaller. The smaller the step, the worse the method can be, the worse the conditions for using this method. So we take the step that would have this lemma proved. And these researchers made this kind of result, the convex optimization, the result of Pollock-Tsipkin. You can see that on the screen. It is about the gradient descent, but with an aggregate that we built based on the oracle that we have. So we have an oracle that gives us this difference, and we have to do something similar for the stochastic gradient descent. It's understood that it's very hard to get 100 as a gradient because you have this sign here.
But this lemma, or rather this last line you're looking at, is the step that we need to make to understand how the stochastic gradient emerges. If I take the mathematical expectation of the aggregate, the mathematical expectation based on the random function that I introduced with E, that's why I introduced the E. This is a non-trivial construction. That's the trick. I added this E randomization in order to use it to get the mathematical expectation and get the gradient, because otherwise I wouldn't be able to build it. This is completely out of the box thinking. So for this procedure, we can prove the convergence of the result, of the Pollock and Tsipkin result, where with the natural speed 1 by k rooted will lead us to the convergence of the matrix. We can also divide it by k. We can divide the method step by k. I will go back to that in a minute. So you will get the correlation matrix with the normal distribution. An amazing idea. Pollak didn't think of it, or rather Pollak thought of it in a dream right before a seminar. So he thought that he could take an average of the point trajectory. He had a regular stochastic method. We are using it for a specific application. But in any case, he thought of the Pollak averaging, where we use the arithmetic average for the trajectory. And it significantly improves the quality of the matrix. Once again, the normal convergence, the same procedure, but when the outcome is the arithmetic average, the matrix turns out much better than the one we had before, thanks to the trajectory average. I hope you can see it well enough. I'll describe what you're looking at. The left is the Pollak-Tsipkin procedure and the convergence for our context, the oracle context. Then we see the distribution with the 0.1 scale. And then if we want to optimally select parameters, that's what I was saying, you can select the parameter as 0, the step parameter, then the distribution will have the scale of 0.1, of 0.0001. That shows how important the learning rate is and how important mathematics is. The effect is very considerable. And then we add the averaging effect. Once again, the mathematical function, the same procedure at the same time, but the output is not the last point, but the trajectory average. Once again, we are reducing, we are making the correlation matrix, in our case it's a 2D matrix, it makes us even more concentrated around the solution, around the output. There is a CPT, the output point has the distribution, the normal distribution.
Тем меньше, чем больше математики вы пытаетесь учесть. Мне кажется, что вот на таком примере
I think with this example, you can really see all these amazing things that were invented back in the 80s. That's it. The main point of my presentation is that we should be optimistic because an oracle like this performs pretty well. I'll be happy to take your questions. Alexander Gasnikov. Round of applause, please. Alexander, you are a virtuoso at presenting these extremely intricate topics and add some chocolate with raspberries to mathematics. And as a result, we are getting loads and loads of questions to you. If I may, I'd like to ask some of them. What are the key advantages that reinforcement learning with human feedback gives in model training? I would say that this is the future. I think going forward, when we use a huge amount of AI assistance, agent-based systems, we will be giving it feedback, what we like, what we don't like. We don't want to spend too much time thinking how we should quantitatively assess things. It's not efficient, even. Instead, we could just quickly assess whether we like something or not, just press the button and express our preferences. I think that's where the future lies. We will be personalizing the assistants that we'll be working with, and an oracle like the one I showed, if it has a good theoretical base, it will be making our lives easier, because with the feedback, the models will be getting fine-tuned just as quickly as with quantitative feedback or even faster. It's just that with quantitative assessment and quantitative feedback, it's harder for us than just saying what we like or do not like. With the RLHF, is there a gradient descent for the distribution function of the gradient? When we're working on theory, usually scientists
И это не то, что вот мы так делаем, это общая практика. То есть, скажем, там статья Адам, да, там, ну, методы, которые...
try to illustrate their points with the application cases. For example, they are selecting parameters theories for a convex case. Look at this wonderful theorem, look at how you should select parameters, and then they say, well, let's try to apply this to actual language models, but there are no guarantees that it will work. It does work often, strange as it may seem, even with the parameters that are selected for the convex situation. They do work sometimes. Often, if anyone decides to underpin this with a theory, nevertheless, it often turns out pessimistic. With our situation, we could get optimistic parameters. The answer is that with the cases that we theoretically have been studying, we do not encounter such regimes, so we haven't studied it in theory. That's how it is. Another question I wanted to ask, what are the risks posed by the stochastic approach to applying it in critically important tasks? The thing is that the stochastic approach is like the average temperature in a hospital. Maybe you like milk chocolate, I like dark chocolate. How do we marry the different tastes? It's not a trivial task. Same goes for wines. A sommelier may be tasting wines, selecting the best ones, and this is practically the task of when we're looking at the stochastic approach, we need to understand what is the human average. How do we select the representative sampling? Because a typical sommelier is not a regular human being. If we gather a group of sommelier experts who will be able to label different wines, this wine will be very specific for specific tastes, for maybe a narrow demographic, not for the broader audience necessarily. So the question of ensuring this representative filling up, the C being indeed random representing the whole data set, I think it's a big problem, and it's difficult to figure out what the solution might be. And also the noise that is present, if it is concentrated well around the zero, the approaches that I presented are once again associated with complications because there is no good theory underpinning it. So I'm sorry for such a non-optimistic answer. Maybe another question so that I could give an optimistic answer? Well, there are a lot of questions about the future of AI in general. For some reason, many believe that it's engineering that will be developing AI, and a lot of people I respect do believe that it all lies in engineering. I do a lot of presentations and speeches, I talk to students and even school children a lot, and what I'm getting from them is that is this idea that there is great mathematics in the foundation of it and a mathematical viewpoint. So I believe the future of AI is in mathematics and evolutionary biology. You need to know mathematics and evolutionary biology to be developing AI. The fundamentals. Thank you very much, Alexander Gasnikov. You have also quenched our thirst for knowledge. When you mentioned wine, metaphorically speaking. Thank you very much. We move on. Before we move on to the next speaker, I would like to ask Artem Tkach, our digital artist, about how the artwork is going. So, Artem, how is this creative or co-creative process going? I have been gathering the data from questionnaires filled out by the audience. I have generated prompts. I have 260 images by now, and out of those pieces, those images, I am building this combined landscape. I expect to get more data, so I will have 300 or more different pieces which will be combined into this landscape, into this artwork. That's amazing, the co-creation happening as we speak. Thank you. I would also like to thank once again all the speakers of the conference for joining us to share their knowledge, their expertise with the audience. Our next speaker is Ivan Aseledets, the CEO of IRI. Ivan grew up in a family of scientists, of mathematicians to be exact. He is the youngest doctor of sciences in his area of expertise. Everything related to AI is in his focus of attention, and he will talk about AGI and its applications in his presentation. Please welcome Ivan Aseledets, the CEO of IRI, towards AGI, towards applied artificial intelligence. As I was preparing for this conference, I thought that I would like to talk about a lot of many things, my research, my team's research, but there is something that's even broader than that. I am the head of IRI, and today Dmitry Chernyshevsky called it AIRI. Well, I call it IRI. So the main mission of our institute, of Artificial Intelligence Research Institute, is to create universal AI that can solve real-world problems. It's a big mission. It's an ambitious mission. How do you approach it is a big question. In my presentation, I will try to highlight some of the brightest examples and the basic terms and definitions that will help you, I hope, clarify our approach to delivering on this goal. I hope this will be helpful because we have spent a lot of time thinking about this, doing our research. It seems that if you set the goals precisely, exactly, it makes your work a little easier. Because the history of Russia has been such that we had science, then we had business, and we had society. Three essentially siloed entities. People doing science say we need fundamental research. Obviously, we do need it. But as a result, sometimes scientists write scientific papers just for the sake of writing scientific papers. Business is doing things that do not really correlate with research, and state is trying to do its best to marry the two fields. It all seems way too complicated. I've been at the head of the institute for a year, and it seems to me that it's not such a tall order. When people communicate, when people collaborate, a lot of problems, even difficult problems related to AI, can be solved rather easily. We have formulated the following equation to try to define practical AGI. It is a sum of two parts. The first one is scientific validity. You come in with an idea, with a project, and you need to prove that it's valid, that it has some scientific value. What is the main criterion of scientific validity or research value, the criterion that shows that it's the best or one of the best solutions in the world? The answer is scientific publications, scientific articles at leading conferences, in leading scientific journals. You can, of course, criticize this criterion, this approach. It has its pros and cons, but that's the best we have at the moment. Which is why so much attention is given to publications from journals, publications with a asterisk, Because when you have such publications, you can say with conviction that you are doing something that is of scientific value. And the second part is engineering approach. Engineering approach means there is a direct functional customer. What you're doing needs to be applicable or useful to someone, not necessarily today or tomorrow, but in any case, there should be someone in business or state who understands where this solution can go, how the solution can fit into their processes. I really enjoyed the presentation by Mr. Gasnikov. He is very he's a great academician. He had a lot of formulas in his presentation. I am going to have none. It's not good or bad in and of itself. It's just how it is. Nevertheless, he also mentioned that there should be this ability to find the customer. But it's not unilateral. It's not like science needs to come up with applications, and it's not like business needs to come up with the necessary research. It should be bilateral. But the presence of an end customer does play a huge role in making AI or AGI actually practical. When we're talking about practical AGI, we transition from all kinds of philosophical questions. Is it an intellect? Is it not an intellect? We transition to practical questions. Is it general? Is it different to AIs that are narrowly specialized? For example, there is a domain. You have been working in this domain for 5 years, but you have 0 publications. Well, that is an alarming signal. If you have publications, then at least there is one check. But if these articles are just about an incremental improvement of the previous articles, then still the question remains about the scientific validity, because we all know about the breakneck speed that science is developing, and in the sphere of AI, it's very difficult to build very specific research plans for a long term, because we operate in roughly 2 months horizons in between conferences. There is another big conference going as we speak, with a lot of publications from our team, and in 2 months there will be an ACML conference, and we'll be applying that too with our publications. So 2 months is the biggest horizon. People who say that we know what's going to happen in 3 years and 4 years do not trust their forecasts. Of course, you can build such forecasts, but the value of them is not very evident. There is a mathematical theory, by the way, explaining it. Any extrapolation is unstable, especially if you are at an exponential growth curve. You're trying to make the exponential curve closer to a line, and you always make a mistake. A good example is people criticizing large language models because they are not working properly, because they are not doing something wrong. Well, colleagues, they are just 2 years old. ChatGPT, as we know it, appeared 2 years ago, and in 2 years they made breathtaking progress. Of course, forecasting that they will conquer the world is just as silly, and also saying that they cannot do anything is equally silly. We need to approach them adequately and look at scientific publications and teams who can actually do something of scientific value to solve these problems. And in my presentation, I'm going to show specific examples, specific cases of our institute of AIRI to illustrate my points. Because these are the outcomes that we believe are the main outcomes of our institute that we achieved in a year. You can take a slightly deeper look into the practical AGI and divide it into components. They are pretty straightforward, and if we look at pretty much all available research, you will see that they can be grouped.
However, this categorization helps you to see where there is a lot of talent and some other categories where there is a lack of talent. Data, lack of compute, lack of data. So we can resolve the tasks, the problems that require not more than 8 GPU. If you need more than 8 GPU, then you need additional resources. However, despite the fact that our research institute is working under our organization that has a lot of resources, but we cannot compete with the organizations that use 1,000 GPU. And the people in the Western countries, they can easily build an experiment based on 1,000 GPU. Does it mean that we will lose? No. But that means that we need to change the perspective, to change the methods. That saves time, because having these resources helps, but on the other hand, it kind of makes you lazy. But increasing the compute efficiency is one of the key problems. I'm not going to talk about multimodality, because this is an obvious story. In every specific domain, we can look at the vision language models, the audio processing models that have been published just a couple of days ago. But these can be the modalities that can be related to the data from the MRI scans, X-ray scans, CT scans, or data related to the robot control and monitoring management. So how can you add new modalities in large models? This is another problem, has to be solved, but you can become quite lazy here as well, because you can build a working prototype and then fine-tune this working prototype for the pragmatic prototype. That takes a lot of time. Multi-agency, obviously AI systems are multi-agent. It's great when computer linguistic specialists are saying that as you process texts, I mean, you use text models. The computer linguistic used to use rules, then the language models came into the fore and said that you don't need any rules, and now everyone is writing rules to create agents. So we use the ready-made building blocks to build some structures that would work. Maybe this cycle will return back to the place where we'll have some other situation, but now we have this network of the manual systems, and you might have something that is that looks truthful, but might not be. Embodiment, people say that there is no intelligence if it's not embodied into something. That's a philosophical question, really. And then here we're talking about the robots that perform various tasks and the model of the world. It's not just the statistical patterns that are learned, but trying to predict something, or maybe trying to develop physical laws. This is a picture of some of our employees. We have 29 scientific groups, 3 labs. The number of PhDs and doctors of sciences and candidates of sciences is a little bit lower than the number in other research institutes. We think that this scientific culture and succession is when the paper that you use to support your status, like PhD, should be pragmatic, should be down to earth, not just some official paper just to get the status. 211 papers were published with A asterisk and A area category. 90 papers accepted. We go to conferences, we make reports, we create international collaborations, and that's fantastic, because one of the most dangerous fields in terms of the regulation is the most democratic one, an open one, which is great. But I said that 90 papers for 250 people that we have is it's not that much, by the way. So next year we will deliver more papers. This conference, it's for the 3rd time on this conference when I'm going to talk about our medical assistant that was developed together with SperMed AI. This is a showcase when the concept of the pragmatic AGI is working. Now, a year ago, this time, it was decided to create an AGI lab that was tasked with the creation of AGI in healthcare. That was the task. There are people who need that. We have resources for that. There are data, doctors with whom we work. So the task was to compile a solution. Now there's a lot of systems like that that help patients, that give recommendations. But making a working system that would be better than an average doctor is a hard task. Now, we resolved the problem of the people who Google their symptoms. I think you've done that. In some of the remote regions, it's quite hard to get access to good doctors, and you have to understand whether your condition is critical or you can wait for help. Now, if you go to Sber Health, there will be a medical assistant chat. It's not some chat with some prompts. It's a multi-agent system with good skills. You can try to hack it, in a good way, by asking its difficult questions, and it will for sure give you all the answers that you need. Now, it looks pretty simple. Anyone can ask a question: what to do with my symptoms? What should I do now? And the system that is doing the reasoning, that's a long shot. It's not just some chat that gives you some data. Now, we want to increase the text modality, in the range of modalities, and add videos and images, and this is our plan for the next year for the medical assistant. We also want to have a medical assistant and the moonshot. That's our great foundation model for fluorography. The dataset that we used for training is the training dataset that we gathered together with the government of Moscow. There is no such dataset anywhere in the world, volume-wise. The quality increases dramatically. It's great for me. I love that. You have to explain it, how it works to the doctors, but that's a great solution anyway. We have around 5-6 models like that, and I think we are, but I think we are on the top. I'll now jump through the highlights. Ilya Makarov article was discussing the social and cultural aspect. Language models are a great tool for those who work in the languages, because you can put different prompts and test the hypothesis on various models. How emotions are influencing the economic games. One of the things, or actually psychological or even psychiatric anomaly can be tested. You can make a digital twin and research that. And the work that we've done together with T-Bank, with Kurinkov, Vladislav Kurinkov, you've seen these news, and the largest, a huge data set and the framework that helps you to work to increase your processing time by hundreds of times. And this is kind of a Minecraft. There's a tree of crafts, and based on that, the agent has to train, and it helps the agents to navigate through difficult environments, and it's actually been now used in the field. We can use standard algorithms to go through billions of steps, so testing and developing new algorithms are becoming less and less time costly, and that really helps us to achieve AGI soon. Now, applicable AI vision. In 1 year, you can develop a working product with a number of teams, and everything is Russian-made, the hardware, the computer vision system as well. It is already working. This challenges the idea that scientists cannot work with businesses. In mathematics, you can give just one example to debunk something, and we are debunking it right now. This is a system that sorts waste, and it has been done. We had a good team, proper resources and good goals, and we had the ready-made solution. Transformer and security. Now we try to look inside the model. We'll try to understand how the brains of the LLMs work. This microscope, looking at it under the microscope, helps to see some unique characteristics that differ, that make models different in terms of the quality, in terms of their trainability, and this is something that we want to expand on further on. If you don't know how to train the model properly and quickly, you can look into it and see why it happens. Now, a couple of words about Aybek Alanov's group. Now, seems like a dumb task to change the hair on high-quality images. First of all, it's very popular, the most popular repository in GitHub. In GitHub, there's quite a lot of groups who are working on these tasks. That's the first thing. Second thing, this is more of an entertainment app, but these same technologies are used in generative design tasks. So you change the material, you move the material from one image to another, you change the style. So you check the technology on this data set, and then you go to working with data, with synthesis generation, and to other boring stuff, but you have the working technologies. So it's great to have the technologies in advance. And the second story is the image editing. We're working together with Sber Devices here. And this paper was published on one of the leading conferences. The task is to change the picture with text prompts. Now in GigaChat you can generate images based on text prompts, but when you say like change the color or change something else, that's a different class of task and prompts, but you can do the same changes with basically zero training, so 0 GPUs will be used. And we plan to use that in the real generative design. We tested based on the images, and it is in demand. Dataset Babylon, Mikhail Burtsov started this project, and we're talking about the fact that LLMs with long context have worse memory. Now, if you want to add a book without retraining a model, and as you added the book, the model can answer new questions and write in a language, but you need to build some benchmarks and before you train, and Babylon benchmarks are the ones that are used right now. Creating benchmarks is a very important task for the entire community, by the way, and it's an important step towards AGI. Another benchmark, we're not only talking about methods, but creation of new benchmarks. It's a dataset for quantum chemistry, was published in New RIPS. This is a dataset that is several times larger than it is used right now. This is the key solution to discover new medications, and for medical chemistry, it can help to replace modeling with neural networks based on the Schrödinger's equation. In the last couple of minutes, I would like to talk about the outlook. Going from the role of the scientist, I'm going to the role of the scientific administrator, manager. You know, sometimes, I mean, I'm still a scientist. I sometimes even write code late in the evening. But my task is to improve the efficiency of the scientific group that I lead and that we were able to gather. People have to understand what is the framework that they work in, what are the limitations, and what is the end result. The AI centers have to develop platforms, that is our goals. But as we were embarking on the way, there was no clear understanding of what the platform is. There was no platforms at all. And when we start to make the final result comply with the requirements when it's already done, that's not the right way to do it. Like, why do you need all these diagrams, all these schemes? But you have to understand that when you divide your efforts in these simple elements, it's easier for you to understand the stakeholders with whom you need to discuss your potential work and other things. And I think we are pretty confidently going towards an AGI creation story, and scientists should not only want to work with theorems, and businesses just want to have a black box that would just have one button. No, we have to work together, and this is how we build the future with artificial general intelligence. Thank you. Thank you very much. Ivan Oseledets, a round of applause. Thank you very much. CEO of IRI, Ivan Oseledets. Thank you. And a round of applause again. We were able to learn what awaits us towards our development of applicable AGI. Engineering AI is a multi-agent system that has a symbol-based AI that is used to organize the process of resolving the engineering task, extracting the industry-specific knowledge, and the manageable and the neuron-based AI that is managed by the engineering AI is used for automatic generation of the computing process to resolve the task. And Yevgeny Burnaev is going to talk about the technology of the engineering AI and the applications. Professor, the head of the Applicable AI Center of Skoltech, a senior associate and fellow, and the head of the scientific group called Trainable Intelligence of IRI, Yevgeny Burnaev. Engineering AI, the scientific foundations for industrial applications. Okay, hi everyone, let's talk about AGI and engineering AI. You know about AI. AI resolves specific tasks. Usually it's based on neural networks, and these are the models that do object detection, classification, or other tasks. Now, the things I'm going to talk about today, this is really not a AGI. This is a step towards that, the creation of AGI, but as I will mention today, it helps and will help to resolve complex engineering tasks. Now let's talk about the details. Not many of you know that in the 1980s, 1990s, a very important place was taken by the symbol-based AI and symbolic AI. And back then they were saying that, okay, the AGI will come soon and all the computers will be using symbolic computing, but in mid-90s everyone forgot about that. So the third generation neural networks appeared and they started to be used for engineering tasks. But people forgot about that before we had this popular paper that you know about. Now, AI is based on the deep neural networks, DNS. But this is an analogy, really. You cannot really say that's a specific term, but you can talk about the AGI as as something structured, and modern language models serve as kind of an engine for it. And here we're talking about the foundational models that build predictions in different situations, and you can talk a lot about that. Can be kind of some something subconscious that can deliver this or that function. And the basic idea is to unite these two worlds, and the symbolic AI, here we're talking about LLMs and generative AI, is managing the process, it orchestrates.
And then the computing itself for the problem solving is based on lower rank approaches. Jumping ahead a little bit, the potential cognitive structure of this approach, it might look like this. First, we need to understand that when we are solving actual engineering problems, it's very important to have industry-specific expertise, domain-specific expertise. Whether it's generative design or designing a manufacturing site facility, some complex engineering mechanism. In each case, we need regulatory documents, normative documents for domain knowledge, which is why we need a knowledge graph, which is a straightforward way to represent the knowledge from this knowledge repository. So there we have this knowledge graph, which describes the domain and its limitations. The person is outside of this system. They set low-level requirements to solve the task. Then the requirements are interpreted by an orchestrator, which takes the knowledge from the knowledge base, relevant knowledge to solve the task, sets constraints with the help of that knowledge. Then the constraints form an optimization problem within which we build computational chains built from specific agents doing specific computation. Then you start the computing chain, and potentially you can repeat this in the second cycle. Obviously, the knowledge graph is different depending on the domain. We need ways to automate its building, but the methodology itself, the library of agents, and this environment in general is the same. Before we begin considering examples, and there are some good examples, good use cases, let's talk about the promising fundamental research which motivates this concept and which also helps explain what we can expect and what are some of the bottlenecks. I am talking about building systems which can solve complex problems. With the problem that I presented earlier, the general engineering problem, you primarily need knowledge from the domain which the orchestrator would be using in its solution. The question of memory arises. What is the environment that you can use for testing? The extent to which orchestrators or other generative agents cannot perform well with memory. The natural answer is text-based games. Many of you probably remember they were popular in the 90s. They're still pretty popular. So you have an environment where you, as the agent, are moving around different spaces, different rooms. Each time you are receiving a textual description of the environment, the textual description of this new room. The problem is that the amount of information you're getting is increasing. The environment varies depending on your actions. And a standard agent based on a language model would fail at it because the amount of context it would need to fit into the memory would be growing exponentially, and it would be getting a lot of rubbish into it. If you apply to this game a standard GPT-4, some state-of-the-art language model in a relatively small number of steps, the model will start underperforming. It's an easy experiment. How do you fix the problem related to language models? An obvious example of how it can be tackled is using modern methods based on RAG or some other methods, pretty straightforward engineering tricks. For example, you could upload the full history into the LLM, but obviously this option will quickly exhaust itself, because even if it's a game with not too much text, the memory will quickly be overwhelmed. Or you can use REG. It's a bit more simple, but once again, the question of noise. How do you organize bits and pieces of information, these chunks of information that you are preparing after the retrieve from the database? And another method is summarizing. Each time that you're obtaining new data, new textual description about a new room, you are adding it. You summarize it to add it, and the obvious risk is you lose some relevant information. There's been a proposal how you can fix the problem I described. On the one hand, you could use language models without any fine-tuning. It may be relevant to some problems because there might be insufficient training materials, and also the computing power may be insufficient. So the assumption is that a language model must be able to plan and make decisions based on a prompt that is put in. How do you fix the problem I'm talking about? It's all about memory. The memory is organized as this. It is organized as a knowledge graph. A language model, at each step, if we give it a special prompt, can retrieve from the descriptions of the rooms that we are walking in. As an agent, it can retrieve from these descriptions some information. Then this information is represented as semantic, as a semantic representation. So essentially, it's subject, relation, object. So it's a triple representation with the connections in between the three. And we are using, as you can see in the picture, we're using the description of events. So we are walking into a room where there are some items, red apples in this instance. Semantic bits of memory are the different triplets. We can represent connections between different items, and the episodic memory is where we found the red apples. One of the text-based games is you walk around the rooms and you are supposed to collect items, groceries, to fetch them to the kitchen and cook something using a recipe. You must retain the sequence of actions in your memory, and even if you have good memory, it might be challenging sometimes to remember the whole list, and sometimes you pick up just any random items. Imagine what a problem it would be for a language model, which sometimes struggles to scale up depending on the context. So to implement this concept, we need several specific actions. We need to build a semantic memory in a particular way. We are using an LLM with a specific prompt, which helps us retrieve triplets from a text description of a room. The triplet I mentioned, subject, relation, object. Then the LLM with a different prompt checks whether there are obsolete triplets, out-of-date triplets in the knowledge base. We get information, retrieve subjects from it. We look at the nodes of the knowledge graph that correspond to it, and we make a decision whether it's out of date or not, whether we remove it from the knowledge graph or not. It is all done on the fly, so it works dynamically. And the final step is the organization of memory. With this approach, with this dynamic approach, you can stockpile the different chunks into the knowledge graph, the necessary information about objects, subjects, and the connections between them. As a result, when the time comes to take another step, to take another action, the LLM behaves like this. It needs to plan something. It receives new information about the current situation. It retrieves the semantic information out of it about the triplets that are present in the description of the room. You do in-depth search using embedding vectors. You look for the right nodes of the graph containing relevant information. And we are talking about a fixed size of the context. You do the same for the episodic side of the memory. You are looking for related events related to the triplets with the observable information. As a result, we can build the knowledge graph on the fly. As I said, this is an example of the game graph, which is called Cooking. And this is the structure of the game, how many rooms it have, and this is the graph that you can build on the fly, and it represents pretty well what is happening inside the game. As a result, you have a system. It can, of course, be fine-tuned. It can be additionally trained, but even if you don't, it performs really well. The same LLM with different prompts, with these different retrieve methods to retrieve information from the knowledge graph. The very first chart shows that we have games of different levels of difficulty. You can have games with very few rooms or games with a lot of rooms. So with the games of varying difficulty, we ran an agent that analyzes the full history, the agent that uses RAG, an agent that uses our technology, and a human player. The outcome was we were, on average, better than all of the other methods. The main drawback is that we were slightly behind the best, some of the best players who simply have good natural memory and who have who had played these games really well before. Comparing it with reinforcement learning, an obvious comparison. This is the diagram. This shows that, once again, we are way ahead of such agents. It shows different levels of difficulty for the cooking environment. It turns out that the score achieved by our agents, the red bar, is much higher than the different RL agents gave. This approach to memory is right, fair, and natural, especially speaking of engineering applications. Why? Because when you want to retrieve from documentation describing specifications for a car, if you want to retrieve the specifications of an engineering device for a child 3 years or younger, it can be located in the text at random places, in different tables. It's very important to represent, it's very convenient to represent this message, this information as a knowledge graph. We also use this, we also try this with Q&A benchmarks, with a Q&A setting. We're only using the part with the memory, so before we answer the question, we take all the documents that are potentially relevant for answering the question. We build the knowledge graph on the fly based on the documents, and the LLM, without any fine-tuning, can answer specific questions guided by the retrieved semantic information from the knowledge graph. I would like to show you this table here. The key point is this. Of course, there are Q&A systems that work with these Q&A benchmarks really well because they have been created to do just that. What I am describing now is just this general method, this general technique, which is not specially fine-tuned for this problem. And still, the quality of the answers we got are comparable are second to the specially developed method highlighted in the table. I think this is a great result because we didn't have to spend any time on it, any computing power. We just launched it and it worked. Clearly, an assistant like this, with a memory like this, can be really useful for all kinds of personalized tasks, to work with documents, to summarize, using the knowledge graph and answer questions, retrieve requirements, and all sorts of things. You can say, well, this is a good concept, tried with text games, but what about the engineering problems? A lot of ideas that I work on grow from generalizations of applied tasks. In this case, we are talking about the self-learning reservoir model, a very non-trivial task where we have oil reservoirs of different types, and we have information of different types, seismic data, for example, of varying quality, hydrodynamic dimensions, hydrodynamic data, data from geological surveys and research. So these data, this information is around a specific well, a specific reservoir. We need to build a model of the reservoir that would factor in all these different types of data, because we want to build a model that combines all these types of data to make sure that the estimate of the physical attributes of the reservoir would enable us to forecast the oil production volumes. So we need to continuously fine-tune and adjust this model, a lot of computing steps, because once again there are a lot of different types of data, and we also need to factor in the domain-specific knowledge. A very natural way to tackle this problem is to use the multi-agent system that I described in the beginning. The knowledge graph here is built based on expert knowledge, domain-specific knowledge. We have to interview experts. It's as simple as that. But once we have it, most operations processing the data allows you to build chains of how you can convert one type of data into another. You can do this on the fly. You know what computing operations need to be applied. And each operation is done with this or that agent. Agents can be physical models or models based on data. As a result, we implemented this software suite, this software complex. We applied it to a number of deposits, a number of reservoirs, and we got good results, meaning that the time in which the reservoir was built was much smaller, was much shorter than what is customarily needed for engineers for different departments to build. And also accuracy is much higher. All of that is automated. The question is, what about generative models? The generative model is one of the agents that help process multi-model data about the oil reservoirs, because we usually think about generative model as model that generates images of kittens and puppies, but in fact we can apply this to oil and gas and analyze seismic data, geological survey data, it's temporal data, spatial data. So it's a model that needs a lot of adaptation as compared to standard generative models based on division processes. We need to understand that with the oil and gas applications, we, of course, could benefit from multi-agent systems, but they are not the only ones. As I said, what we are developing, what we're working on, and what we plan to use as a publicly available toolkit is this approach that helps you solve a variety of tasks, including problems related to engineering and design for manufacturing sites, the situation is similar because you need to simultaneously design a building or a facility, what's inside that building, the wiring and things like that, all accordance with the regulations. You need to position all the things at the building, on the site, utilities, communications. This applied problem is once again solved in the same vein with the same cognitive architecture as I described earlier. We are making progress and we have already done a great job. We show that you can use information from regulatory documents with restrictions and constraints for design. You can retrieve that information in a reliable manner with the systems that I described earlier.
And actually, if you talk about the information about people in some large systems like banking system or systems from the large IT companies, we're talking about multimodal, diverse information, and it is updating all the time. Some data are removed, some data are added. Very difficult challenge, but a very exciting one that can be resolved with this system. We're talking about large cohorts of individuals with large set of data, transactional data, data on the activities of a user in various online systems, and based on these data, you can build digital twins. So these will be these chains of agents. They are going to build for every person, based on the input information, an avatar. If you have a set of avatars for everyone or for a group of people, because, maybe it will be hard for a system to calculate it for an individual person, then you can model the social economic system in a pretty accurate way. It's quite hard to do that, so we have to lay the engineering ground before that. In conclusion, I would like to say that, of course, the LLMs will not be forgotten as quickly as the symbolic AI models. We have LLMs and multimodal models working side by side with us. Now, AI is a kind of a vague term, concept. It's pretty far away from the truth, and what is AGI is also a kind of a vague term. I think that the natural step towards that might seem pretty far-fetched in terms of the fundamental development of the technology, but on the other hand, it is, pretty real in terms of realization, and you will be able to resolve the tasks and problems for general classes, and that's very important with AGI. Now, in my presentation, I tried to talk about the applications where it might be used. This is the link to our paper, the QR code, my contact details. Thank you very much, and if you're interested, please make sure to contact me. Evgeny Burnaev, a round of applause. Tomorrow can be seen in today's achievements and can be forecasted based on them. However, the day after tomorrow is not that well predictable. The next report will give an attempt to forecast the AI the day after tomorrow. And to do that, we need to go from individual AI systems to researching large ecosystems and social systems and heterogeneous networks of AI in this multipolar, unpredictable world. What is needed for the effective work of such systems? Alexander Gorbain, the author of 20 books and 250 scientific papers, is going to talk about that. He's also the winner of the official title Pioneer of the Russian Neural Informatics. More than 30 students of Professor Gorbain have a scientific the PhD or the Doctor of Sciences degree. Doctor of Sciences degree is 7. Doctor of Physical Mathematical Sciences, the leading fellow of IRI, the professor of Central University, Alexander Gorbachev, multi-agent intelligence. 10 billion people and 10 trillion AI agents. A hallucination about the future. Hi everyone, it's my great pleasure to see you all. I'd like to describe you the title of the presentation. Why hallucinations? I will try to change my usual role and to talk about the prediction, the forecast for the development of the scientific and practical field. Hallucination has become a buzzword in AI, but basically what it means is the error in disguised as something in the plausible clothes. People like to come up with some new terms, and hallucination is one of them. It's my second time when I give a presentation about AI. Prediction is about AI. The discussion about neurocomputers was my first presentation. In 1998, everything was fantastic. We had deep learning, but we didn't have two important things. First of all, I couldn't predict what would happen when people will have internet. There will be one system that would capture and recycle a huge volume of text. Of the internet, that was, a pretty vague thing back then. But it happened in 2000s. The second thing is that the community didn't do me a favor. When I looked at what can develop fast AI and neural network AI, I said there is a task where we can use the mythological principle. The task of managing fusion reaction in real time. And when the cybernetic management and control of the thermal nuclear reaction, when we understand how to do it, we could do that. We could do that, but people are afraid to do that. Thermal fusion is something that people don't know anything about, and they think that the failure rate will be pretty high. So I had two forecasts back then. Now, my idea is as follows. The forecast is always a hallucination in a way, so I stand to be corrected. But it's based on my work, on the work of other scientists, and well, based on the experience and based on the fantasy as well, of course. Now, they have already flown out and they will arrive soon. That's about the multi-agent systems. That's how it looks like in our fantasy world. Now, the first section of the presentation is going to talk about popular predictions of AI development. Second, agent AI, top strategic technology trend for the next 5 years. So priorities change. The generative AI is leaving the scene in a way. The topology of division of labor between agents is a very important thing to talk about, and the epilogue. Now, a popular prediction about AI. Unfortunately, there is nothing here, but that's a well-known Gartner cycle. That should be put in the textbooks for high school kids. We are living in the century of innovations. How do innovations work? First, there's this trigger, then it's going to a hype, You have to believe in the hype, but you have to be cautious, because then it will go into abyss of broken illusions, of disillusionment, and then some of the solutions go to the productivity plateau. Gartner also made the assessment of the productivity. Now, 2023, what is the hype? What is the most hyped up technology? Well, ChatGPT, generative AI, foundation models, all of this stuff. Everything that you saw everywhere that generates nice pictures. 2024, it fell down from that hype into the huge and black abyss. Now, engineering AI applications are coming out. Generative AI is on the bottom of the abyss, but Gartner is they gather experts from around the world, and they predict the following: that in 5 years it is expected for the Gen AI to go to the productivity plateau with a higher level of certainty. Multi-agents, that's more exciting. Multi-agency was discovered a long time ago, but it's still at the initial stage of innovations, forgotten somewhere in the warehouses. I removed this small square at the start, and at the end, the multi-agent systems. Yeah, here it is, by the way. Yeah, right, there at the bottom part. They're still at this warehouses, so to speak, although they were tested quite a long time ago and discovered a long time ago, but I think they have a great potential. In 2024, in October, unexpectedly, Gartner organized a conference. That was October 2024, just a couple of months ago, and said that a strategic priority, a strategic main top priority for the next 5 years is agent-based models. Agent AI. I've heard a couple of reports today about Agent AI, so I'm going to repeat some of the ideas. Now, Agent AIs, what do? They assimilate large language models to be able to talk and communicate with people and to have some reasoning. Secondly, it works with the modern systems of data storage, extraction, and data collection, so on and so forth. Third, reasoning, planning, these things. Reasoning, planning, and model generation. LLM goes, and this Agent AI goes in the real world. That's the major difference. And people who write about that write that this is the major difference. And then it learns and learns and learns within the cycle. And these agents that absorb LLMs and use it for reasoning and for communicating with people on the language that people understand, these agents are considered now to be the core technology of the future. Moreover, they say that on the long term, around 20% of all, 15? Yeah, Gartner predicts that by 2028, in 4 years, at least 15% of all day-to-day decisions will be made autonomously by Agent AI, agentic AI, up from 0% in 2024. But we can talk a lot about agentic AI, but now it's 0%. So it's tomorrow, and the tomorrow has already come, and the Gartner was really concerned that the tomorrow has already come, and they decided to reflect that in its forecast. But what will happen the day after tomorrow? I've discovered that people do not know who invented what. AI had great creators. Marvin Minsky, who in 1961 published a great works, The Steps Towards Artificial Intelligence. And basically, we are moving by these steps. You can check that out online. There is another important notion that Minsky introduced. It's called a micro-world of AI, or micro-world of an intelligent agent, something that should be taught in school. Because, you know, I say code is not... a cat is not living in the house, it's living... it has its roots. A person does not live in Moscow. A person lives in the small, idealized world. It's a kind of a sub-world, an idealization, idealized world. And AI agents, they live and work in their micro-worlds. A micro-world, as Minsky explained, is a model, a pretty simple one, that is put on the real world and is adapted to it, and within that world an artificial agent is working. It does not see any other reality. The reality is something that it can see. And he says that an agent with its micro-world. And as for the reality, to understand the reality, you need a lot of agents. Multi-agents within the systems is something that poses this cross-cultural situation. Communication, there's a communication problem. Agents do not understand each other. You have to train them so that they can communicate with each other. And there is a orchestration problem. Configuration might be another word. So orchestration of the agent communication and interaction. Every agent works within their own world, and they're built around a real world. And when you can combine them and configure them around this world, you can get something more or less realistic. This is the task. But the agents do not die. That's the most important thing. So we can always hope that in some point of time they will be smarter and smarter and grow. Right, so what is the interaction between the agents that we might see? Obviously, it's... I mean, every time when you talk about the agents, you have to think about the division of labor. This is a cooperation that we had with an orchestrator that controlled that. We might not have an orchestrator. Coalition and teams. Coalitions and teams, within them agents exchange information and remove each other's errors and train each other. There are methods, there are small agents that are correctors. It trains within the system. And you can, have this corrector that will just correct these mistakes, so as to not change the overall structure of the system. How does it work? That's a working system, by the way. That's how it works. Yeah. That's the first is coalition and teams. The rules of interaction is cooperation, sometimes competition, by the way. Sometimes we have conflicts there. But yes, otherwise it's mutual cooperation, correction, and mutual learning. Algorithmic systems. I have two examples here. You know one very well. You see it every day, although not in such a in such a way. You see yourself in the mirror every day. You see computer every day. But as for the intellectual and smart agents, I didn't want to draw that because I thought about this thing. So I took a book that was published in 1999 that really talked about all functional components for the simplest AI components. It's called deep learning right now. So what is deep learning? Something that was called conductionism in 90s and 80s. There's no other deep learning exists in. So these convectionist systems, the neural computer, the project of a standard, this author, Mirkas, analyzed the standard components that could be agents in a system, that could act as an agents in the system.
Next, we move to the hierarchy and mixed structures. And here we come to a mythological image, same as ChatGPT amazed everyone. This is not AGI, this is not human intelligence. This is something, some entity that usurped all of the texts on the internet. It's an assimilator. And now, once we have assimilated all agents, and what is an agent? An agent is this multi-dimensional world, realm, a multi-dimensional language, if you will. So this brings us to the metaphor of the global serpent. This is a good excuse for me to reference my own publication. By the way, the ideas expressed there were simultaneously expressed in the publication by Jacobs, Jordan, Nolan, Hinton, and Gilov, Gorban, and Mirkas, published at pretty much the same time, by the way. The epilogue is the bright day after tomorrow. Humankind will create enormous libraries of data and agents. Agents will not be dying out, they will be accumulating. All of the successes of large models will be inherited by agents, except they will be magnified. We will have these huge libraries of agents, and same as large language models, they will be superpower agents. But large multi-agent systems will be active in and of themselves, and they will be working under the supervision of large systems. The number of agents will be increasing because they do not die. And people can just relax and enjoy. I don't know what exactly will happen, but that's how I see it. And then there is this great chapter of challenges started by Gilbert. In 2019, 3 academies of engineering gathered together in London at a huge summit to discuss the main engineering challenges in an unpredictable world. They started with 2 challenges, no other. Will technological advancements change humanity for the better? And if they do, then how? You remember the Soviet cartoon about Winnie the Pooh? And the second question is, can we provide food to 10 billion people in 2050? You can find this online, highly recommend. There are 12 main challenges in total, and that's my presentation. Thank you. Alexander Gorban, thank you very much for these hallucinations about the future. Loads and loads of questions for you. How should the system of education change to prepare people for living and working with a multi-agent AI? An excellent question. The frank answer is, I don't know. Another answer is you need to train kids based on specific problems and tasks. The lecture that I just gave, the presentation that I just gave, is useless. You need to teach based on practical tasks in a friendly context with multi-agent systems. That's how you do it. Being adaptable, working on practical tasks, multicultural contexts. That's, I think, the recipe for success. Thank you very much, Alexander Gorbain. A round of applause. Doctor of Physical and Mathematical Sciences, Professor of Central University, Alexander Gorbain. Well, let's move on to practice and creativity. Just a reminder, Artem Tkach all this time has been creating a digital artwork together with our audience. We're looking forward to seeing how it turned out. Just a minute ago, I sent the image to the server room. I've just finished it. All in all, we had roughly 288 images, all thanks to you and your prompts that you sent us through the online questionnaire. I used multiple tools. The foundation was Kandinsky neural network. I used it to generate images based on your prompts. And then I combined all these images together. And by the way, I also tried to add animation to it. I don't know if the organizers will be able to show it to you, but maybe you'll be able to see the animation of how all these pieces are drawn together into a single artwork. So this is a great example of collaboration, of co-creation, and here it is. It's called AIJ 2024. We created it together because you were directly involved in its creation. Let's have a look. Show us the result, please.
Это прекрасно, восхитительно. И здесь...
It's beautiful. In each square, there is a trace of someone who left the prompt, the imprint, and I also left this Easter egg. I took a picture of the table and the chair to generate myself sitting at the table. Excellent. $1 million. Call it. 1, 2 million. No, we're not selling it. That's right, because it belongs to everyone who participated in its co-creation. We discussed with the team whether it should be published as an NFT on Sber platform, and I'm sure you will talk about it to get a copy. So this will be an original artwork and copies. The number of copies correlates with the number of participants. So if you sign up to the platform of Sber, can you explain? Yes, we have the QR code here. You can scan the QR code to get your portion, your segment from this artwork as an NFT. Co-creation indeed. Scan the QR code, sign up, and within a week you will get access to the service. As far as I know, it leads you to a chatbot because they can't issue the NFT immediately. So in the chatbot, they will let you know which link you can follow to collect your NFT. We haven't issued it yet because we have just completed the artwork. So issuing the NFTs will require some time. So do check it out. Scan the QR code and join the chatbot to get your NFT. Thank you very much for helping me create this artwork. Applause to Artem Tkach. You can feast your eyes on this artwork until 15:45 3:45 Moscow time, so 3:45 Moscow time, because then we will resume with some more interesting presentations by our speakers. Artem Tkach, AI Journey 2024. See you back in 15 minutes.
Дом РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Лаборатория Касперского – технологический лидер и единый партнер по кибербезопасности. 220 тысяч компаний в 200 странах и территориях доверяют нашей глобальной экспертизе и лучшим в своих классах продуктам, эффективность которых подтверждена многочисленными тестами, рейтингами и наградами. Лаборатория Касперского. Активируй будущее.
Центр искусственного интеллекта Т-банка. Создаем специализированные большие языковые модели для каждой конкретной области. Проводим фундаментальные научные исследования. Входим в топ-3 компаний по вкладу в open source в России. Разрабатываем решения для создания голосовых интерфейсов на базе точных, быстрых и безопасных моделей. Создаем сервисы обработки изображений, чтобы ускорить рутинные операции. Развиваем персонализацию и улучшаем клиентский опыт. Узнайте больше.
Дом РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Лаборатория Касперского – технологический лидер и единый партнер по кибербезопасности. 220 тысяч компаний в 200 странах и территориях доверяют нашей глобальной экспертизе и лучшим в своих классах продуктам, эффективность которых подтверждена многочисленными тестами, рейтингами и наградами. Лаборатория Касперского. Активируй будущее.
Центр искусственного интеллекта Т-банка. Создаем специализированные большие языковые модели для каждой конкретной области. Проводим фундаментальные научные исследования. Входим в топ-3 компаний по вкладу в open source в России. Разрабатываем решения для создания голосовых интерфейсов на базе точных, быстрых и безопасных моделей. Создаем сервисы обработки изображений, чтобы ускорить рутинные операции. Развиваем персонализацию и улучшаем клиентский опыт. Узнайте больше.
Дом РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Лаборатория Касперского. Технологический лидер и единый партнер по кибербезопасности. 220 тысяч компаний в 200 странах и территориях доверяют нашей глобальной экспертизе и лучшим в своих классах продуктам, эффективность которых подтверждена многочисленными тестами, рейтингами и наградами. Лаборатория Касперского. Активируй будущее.
Центр искусственного интеллекта Т-банка. Создаем специализированные большие языковые модели для каждой конкретной области. Проводим фундаментальные научные исследования. Входим в топ-3 компаний по вкладу в open source в России. Разрабатываем решения для создания голосовых интерфейсов на базе точных, быстрых и безопасных моделей. Создаем сервисы обработки изображений, чтобы ускорить рутинные операции. Развиваем персонализацию и улучшаем клиентский опыт. Узнайте больше.
РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Лаборатория Касперского. Технологический лидер и единый партнер по кибербезопасности. 220 тысяч компаний в 200 странах и территориях доверяют нашей глобальной экспертизе и лучшим в своих классах продуктам, эффективность которых подтверждена многочисленными тестами, рейтингами и наградами. Лаборатория Касперского. Активируй будущее.
Продолжаем программу конференции.
Welcome back, everyone. We continue our journey into the world of AI. Happy to see you back in the main hall of AIJ 2024. The next block is opened by a discussion on practical AGI. Our speakers are Maxim Yeremenko, the Vice President Director of AI and Machine Learning Department of SPER, and he will talk about the future of AI and specifically the future of practical AGI and the role of AI research to achieve it. Please give a warm round of applause to Maxim Yeremenko, Vice President Director of AI and Machine Learning Department of SPER.
Practical AGI.
Рад приветствовать всех участников конференции AI Journey.
I'm happy to see all of you, dear participants of AI Journey 2024. This is the last module of presentations in the science track, and today I would like to talk about the topic which I think 5 years ago sounded like science fiction of sorts, but today it is something that attracts investment from all the major big tech companies. I think this is very much relevant to our day-to-day life. Of course, I'm talking about AGI. Some say strong AGI, but we prefer the term AGI. Let's start with a poll. What do you think when the AGI will appear? To decide how to vote? Let's agree that we mean by this something that can efficiently make decisions in a similar fashion to high-skilled, high-qualified experts, operate in different modalities, text, voice, all sorts of things, and it doesn't necessarily need to be embodied. So it's not necessarily a robot. We are talking about the cognitive abilities. So let's see what you decide. Please show the results of the survey. We'll see what the audience think when we will finally achieve AGI. Well, I see that the vast majority believe that we are looking at the horizon of 2 to 5 years. Very much in line with the forecasts. Well, let's give it a minute, or rather 10 seconds. And then we can move on to the alternative image. Which essentially confirms the majority opinion of the audience. You see these esteemed people. One of them is the godfather of AI, Geoffrey Hinton, and the CEOs of the biggest tech companies. They all agree that if not 1 or 2 years, but at least at most 5 years, is when we can see AGI. To move on from this nice picture about futurology and vision of the future to something more close to home, more practical, I would like to describe how we at SPUR have defined this framework that we are calling practical AGI. Why we've done it at all? We've done it to add some structure into what we do in-house and what we do with our partners, with research teams. And more importantly, if you know about the SpaceX achievements, you probably know that over the past 8 years, the company has been developing the launches of this module that can be retrieved, and she's doing it to go to Mars, to colonize it successfully, and to go back if needed. They've had a lot of failures, a lot of falls, and with each fall, they learned their lessons and organized this process, which at every step of the way in technological development allowed them to do some practically useful spin-off of their technology. They continued improving their technology and practicing with the launches. This is a great approach in the modern context that is changing all the time. It says moonshot here, but for them the more ambitious goal is probably Mars shot. So in our case, we can start with a moonshot, because with AGI we haven't been to the moon yet. Speaking of where we are, in terms of the ability to hack ourselves and our skills, there are 3 or 4 modalities, 3 or 4 emotions that artificial intelligence can reproduce pretty well. Text, obviously. Voice, in one way or another. We often communicate with IVRs by voice, sometimes not very friendly ones. Some of them suggest that we transfer money to some super secure account, wink wink. We often see generated images and we struggle to figure out if it's generated by AI or if it's real. Video is a separate modality, it's slightly different. It is at the level where we can pretty safely say, in most cases, that this video was created by AI. It's pretty evident, and a lot of industry-specific applications, I'm talking about 3D generation and industrial designs, and last but not least, some very moderate and tentative experiments with sensory information. Now, this was borrowed by this esteemed tech company, but we added something of our own here. This is how they envision the development of OpenAI, AGI. They're not specifying whether it's practical. This is how they envision the evolution in time. First level is everything related to perception and generation. Seemingly modern architectures of models, transformers, diffusion transformers are performing pretty well with perception and generation. There are some nuances, of course. The second level is reasoning. Reasoning not just similar to a human, but also explaining why you are getting to a certain inference. For example, in medical AI, it's important to get an accurate response, or when a doctor makes a decision, we also need to be able to explain how they came to the decision. Did they need to call a medical board to make this decision or not? Third is action. First, there was this unofficial image of information on Bloomberg, and then Sam Altman commented on it as well. OpenAI said that we are between the second and third. So we are probing the agency topic, but we are still not finished with the reasoning stage. I'll get back to that in a minute. Experimentation stage, sooner or later. And we are seeing the first attempts at it, the first stabs at it. With research problems, with scientific discoveries seems more serious as compared to the previous levels. And the last level, evolution with self-reflection and self-improvement. To what extent will this AGI be able to evolve when there is no human involvement, no human supervision? We have created this structure to represent the different value streams because they are creating value not just for science, but also for applications. The first category is multimodality. I'm going to describe each component separately. The main idea is to create something that, as opposed to the solutions, other solutions in the market, would perform well in terms of computing resources with modalities of different inputs and outputs. I'll get back to that in a minute. Agency, the second category. We all want to we all want our AI to have some mandate, but at the same time we want to limit the potential risks of making an error.
And these errors might lead to some consequences. Recurrence and reasoning comes to that category as well. I'm going to talk about that in detail a bit later. Here we're not talking about the living creatures, robotic creatures with multiple hands and legs, or even two legs, that can do something in the physical world. Now, that's the embodiment, on the world model. And compute and data. These are the major investments. These are the parties that pay for that. Because we understand that compute and data processing is where the bulk of the investment goes. On the top section, these are the emergent capabilities. That's what we called it. So all the useful stuff that will be the result, but what will be the outcome is not known to anyone. This is why it's called emergent capabilities. Let's look at the middle and lower layer and talk about that. Now, everything that we see right now, different architectures of the models, know how to work with different types of modalities for the input, but the output is usually pretty much the same. It might be text, or image, or sound, but we do not see a video with sound that is delivered by one model. We're still having some manual labor here. Having several modalities, that's an even more complicated task. And we do not think what modality we're going to use when we communicate with each other as humans. We show, we talk. And this end goal is to achieve that in an efficient and cost-effective way and quick way, to go to the architectural stack of the models that would help us to operate the modalities. We're talking about the input and output. To bake in one architecture transformer models and other models. And those who was on the gallery with the forecasters, Madora, he likes to use the word powerful AI, not AGI. He says it happens when we leap forward to something completely new in terms of the architecture. And he says that these are not going to be transformers for sure. And the next interesting topic is agency. We see the examples that are pretty simple. Anthropic AI, the name of the company I just talked about is CEO, and Google Gemini AI. This is when an agent navigates you on the screen on your desktop, and if you give the permission to use your keyboard and your mouse, It can do something useful like book a flight ticket or a table at a restaurant. These examples have been with us for many years, but they're becoming a reality right now, thanks to the LLM models themselves, and thanks it was possible to technically operationalize that. So you take a page of with text translated to the language understandable by a model, and you get something useful. Yesterday, my colleague sent me a podcast where sci-fi blogger tests Call1 Pro, and he asks to write scenarios, how to ask your boss for a raise. And then he asks to rank up and downturn side effects. And it says, well, you have a quarterly review, that's the best way to approach your boss about the raise, or you can meet him in the hall, or you can use HR. But the worst thing you can do is to meet the boss in the hall somewhere and to ask for a raise. That's the worst thing. And it analyzes the context properly. You know, so it says like, okay, I have a kid coming soon, and the model says, no, you shouldn't risk it. You have a kid soon, you need financial stability for now. So the tasks and problems are becoming more complicated, and the agency, it's like microservice architecture. The automation related to the software development will be related to the agents. We're starting that trend, really. So, in terms of what our research is doing, in terms of our research, we would like to have some quick wins, some low-hanging fruits, and come to this end goal, to make sure that the automation is based on them. Now, recurrence, it was asked, the GPT-4o, the weakest one in terms of the reasoning, I think, to draw a horse riding an astronaut. So it kind of puts it here, but it looks like Lego. On the second slide, these are the different, this is something, and GPT-4o, yeah, here it started to say that, yeah, this is the legs of the horse, and it doesn't really look like an astronaut here. And it says that, okay, this is an astronaut's helmet. As for the embodiment, you have this kind of, in your head, some humanoid dancing robots. First of all, it's hard to understand how to, what is the optimal form of that device so that it is optimal in solving all the features and performing all the tasks that people do, because, you know, it depends on the task that this robot will have to perform. But anyway, embodiment is not only limited by the physical embodiment. We have more and more synthetic data, and more tasks can be resolved in virtual environments in terms of the training. I'm talking about driverless vehicles and driverless planes, for example. Anything that can overload our useful cognitive capabilities and can translate that to the real world. One consulting company last year published a report who is going to be automated lastly, and what will be the industry that will be automated, will be the last one to be automated. This is the construction, because the foreman and the construction worker, these are the people who are hard to be replaced, because it's very hard for AI to work on a construction site, basically. Another important component is the world models. Sword, the start of this year. Sora was a great model. Now we have a second Sora. I think it was published a day ago. This is the first Sora, the flagship video when a girl is walking in an urban environment. In a couple of months, Kandinsky video was published, and here we have a Sber cat walking through the through a city. Looks okay, but it doesn't really have the physics of the real world. We don't have shadows somewhere. Sometimes some of the objects are moving quicker than they should. Will we be able to make machines understand the physics of the world with just feeding it with images and videos? I don't know. Now, compute and data. There are many areas here. Huge topic for discussion. How can you make a distributed learning in terms of in the situation when data cannot be collected in one basket, so to speak? You can use the kind of a scheme of the file, use the file sharing scheme, you know. There was this software that helped you to pirate movies and music. DeepMind and Google published a report about that, an article about that, and they compare this method with a file sharing service. Obviously, there are some new compute devices. Distillation of the models themselves, that's understandable because many models cannot be put into the compute capacities. They need more. And the code optimization, because it's understood that apart from making a good model, you have to be able to install it in real life. And it seems that our HR analytics made a kind of a survey asking about the skills that became very relevant. ML engineers and ML and C+ developers in generative AI. The number of jobs soared because everyone started to implement Gen AI. Small video generated by Kandinsky video about space. I decided that it would be the right thing to do to discuss the practical AGI as part of a dialogue, and I would like to invite the rector of Innopolis University, the professor Alexander Gasnikov. Alexander, please, welcome on the stage again. Now, Alexander, we are the people, thinking about all this. We're the dreamers in a way, But you work in the fields with the real AI applications, Because we usually try to put some KPIs and all the other things. Any scientific, we try to make any scientific and this creative work to be useful in practice. How can you put these creative, difficult things in one framework? Do you need to do that, or people just need to search without any barriers? They just need to think outside of the box. These streams that we've talked about, what is your first response? I think I actually like that. That's useful for me. You responding as a rector or as a scientist? As a scientist. As a rector as well. I need that. Trying to force people work in these areas is not something that you should do, maybe, but it's useful because it's a bridge from the industry. Scientists have to look into that. This is the request from the industry, and that simplifies our life because we had to go to you with that and tell you, help us here. I remember in the beginning of 2000s, you were working with a company, and you had to go there to listen to the task that is absolutely non-scientific, and then you put that in the scientific framework. And you are now doing the this scientific work for us. You know, it is very logical and it's very, you know, insightful. Maybe it needs to be fine-tuned in a way, because, you know, we're talking about some intersections. It's hard to divide something if it is connected, but I think it's pretty convenient. It's convenient for me, yes. So, and I think that Innopolis is going to integrate into that system, you know, into that framework. I think it's really convenient. Yeah, this is what we are going to announce, because we want to build our work, internal work, and the work with our partners to have proper partnerships, you know. We're talking about the structure of these research vectors, you know, research vectors, it's such a term in science. Anyway, these are the research vectors, so to speak. But if you look at this concept, like, what do you think about AGI? How did you vote? I forgot my phone at home. Oh, that's funny. Yeah, but anyway, I think that's an interesting question, you know. The presentation that I had today, I said that you have to learn evolutionary biology at schools. You would say, that's weird. How is it connected to AI? That's a good question, because if you understand how our brain works, it can help us to try and understand the development of AI. I think there was an experiment made with mice. There was an embryo of a mouse. They removed a part of the brain that was responsible for, let's say, vision. And they left the part responsible for the hearing. And they put the neurons responsible for the vision. They connected it to the part of the brain that was responsible for the hearing, and the mouse was using the parts of the neurons responsible for the hearing for vision. I mean, maybe it was different. I don't know, but anyway. It seems that this is a positive thing, that yes, there is a chance that there is an opportunity to have some general principles to do something multimodal, to find some common embeddings. That's good news, you know, it's kind of evolutionary biology inspired idea. And for example, I want to jump higher because I want to play volleyball. I do leg work, leg days to jump higher, and then I start to want to run faster. But you can't do both. If you can jump higher, you know, it does not mean that you can run faster. I mean, obviously the brain works differently, but the idea is super simple. Specialization is not for free. If we want to have strong agents and strong assistants, invest in everything in one thing is, I think, a non-obvious idea, because you see that among the kids, because when you see the phenotypical development among the kids, they like some things better than the other. And if you try to force kids to do something differently, to study something differently, it won't work, because they are wired for different things. They can do it, but they won't be great. So creating something of value, it would be, you know, very hard to do. It's like if you take a person, you won't be able to make a champion in swimming, running, and all the other types of sports, you know. I think the same will happen with the specialization. So we will hope that it will be all kind of gathered together and it will reach some level, but there will be some divergence as we talk about the AGI. A strong AI, meaning AGI, I don't know. maybe there will be some PR campaign that would say, okay, have achieved AGI. I think it will happen in a couple of years. There will be some good PR event for that. As for the, content, we're talking about some nearest ChatGPT style revolution, but in robotics, when we will have our own ChatGPT, not in the robots that look like humans, but like in robotics, because, a plane does not fly and like a bird, right? So there will be some things that we will take and copy from animals, but some mechanisms would be used. And in schools and in education system, we have to include the lessons of how we became humans, what experiments were done with animals that show how the brain of this or that animal works. And if we monitor that, we'll be able to understand what is our future and how to move to that future. That's a great selection for ourselves, using ourselves and animals to understand how it was developing from an evolutionary point of view. And if you know the history, it's easier to forecast.
Well, once again, I'm spending so much time talking about the thing that is truly important to me. Not many people say it, so I'm taking advantage of your platform, sorry, to once again talk about it. No, it's okay. Indeed, in marketing science and its applied use is not about terminology. OpenAI, I think, started to introduce this term AGI, and they probably feel that the main capitalization in AGI is going to be in AGI, but the Gartner hype cycle also shows that we still need to wait, say, 10 years to the AGI peak. I would say that's pessimistic, but maybe they will be calling it ISI or powerful AI. It's not about terminology, but you started talking about mice, and rightly so. Even a mouse with a dissected brain can listen. Not all people can listen. I have a lot of people I know who have a perfectly fine and working brain, but they can't really listen. By the way, speaking of mice, that probably goes here in this group because it's about attention. A human being has this neuroplasticity, and neural networks also has it, but imported from outside. As for people, we are born with it. I'd like to get back to the first point. What is the scenario that you envision for it? Some said that maybe AGI already happened. Maybe we already have AGI. If 1 in 4 are using Gen AI, and then there are companies and corporate surveys that say that in the next 5 years, 100% of information flows will be processed with the help of AI, meaning models that work with text, agent-based models. So given that, maybe we already have AGI. Can we say so? Or will we as human beings be enslaved by AGI? How do you see it? It's a difficult question of whether we have it or not. I don't think we have it. I don't think we achieved it. To do all of those things mentioned on the slide, we need a lot of resources. And in terms of accessibility of these resources, I mean to be able to train the model, the AGI model, instead of just doing inferences. Not many entities, not many parties have access to the sufficient resources for it. And then inference also requires resources. Not everything is publicly available. Well, GigaChat is. Yes, GigaChat is. Great job. My point is that the main problem we are facing is that the current phonemic architectures, I think that goes to point 6, item 6, from the perspective of density, we can improve the processing units, but up to a point. So maybe in the next few years, what we will be facing is this problem whereby the brain is millionfold more complex and fast in terms of the number of computes that it can perform in a second, and also the amount of electricity that is required for all these computes, for all these architectures. If we want to make progress, we will need to source this energy somewhere. That doesn't sound like such a trivial challenge. And also this simultaneity of inference and training. Instead of first training and then getting the inference, we could make these tracks parallel and simultaneous. I'm not a specialist in this, but what I've gathered from my communication with colleagues is that with AGI, we are usually talking about some cases, limited cases. There is a case where the model works and it helps you out, and it does have a certain wow effect, but is it worth it? It often is, but still we keep asking. So I don't think it's AGI yet. It's not something that works across all domains and is accessible to anyone. But I hope and I think that in a few years, all these questions will be resolved. I'm just judging by the trends, the current trends, because just a few years ago, nobody knew about it. ChatGPT, agent-based systems. The good news is that while I do optimization, and from the universality point of view, as any human being, I think, I believe that the more universal, the worse, because when something is universal, it means that when I ask it to perform a specific task, it will perform worse. But there are methods. Yuri Nesterov has been working on them for 30 years. They show that thanks to adaptation, this idea of self-fine-tuning, I saw it somewhere on your slides. Yes, we had it at an earlier slide. So I think there is an option of self-fine-tuning which would allow universality to some extent in specific domains. We are seeing it already in some AI-related domains, that something universal becomes state-of-the-art, competing with narrowly specialized methods, which was a bit surprising to me. But it is partially due to the fact that there is this fine-tuning to solve a task as you are solving it, trying to figure out what you are actually working on the go. It is about improvement of performance as you are performing a task, and maybe we could adopt this method, but you may say those are my fantasies because I'm not a specialist, but that's my take. Sorry, I'm being reminded of the timing. Unfortunately, I've been told that we do have a minute for one question, a very quick one, to Alexander, because you can catch me in these bare halls every day, but Alexander doesn't visit us that often. Anyone want to ask a question? Well, probably you're not interested in practical AGI, so there are no questions. What? Somebody's showing me something? They asked me at the entrance to the hall, do you want someone to ask you a question? I said no, but I would welcome a question to Alexander. Oh, there's one. Hello, Sasha. Maxim, thank you for the lecture. I really hoped to run into you later to ask my questions, but since I have this opportunity, what are the cases where universal was better than narrowly specialized? Because we are currently working on something very similar, and we are at a junction. Do we use universal tools, or do we spend more time and more resources but create a narrowly specialized tool? Well, my answer will be this. Let's say you are training GigaChat. GigaChat is a function
там разметок и того, что выдает модель. Вот мы сумму квадратов невязки там формируем.
with inferences based on labeled data. We optimize the weights of the neural network with an algorithm so that the mismatch is lower. And then the question is about the learning rate with our training method. What is the method step? Usually it is related to the parameters of the problem smoothness. The universality is that there may be some universally working general recipes, recommendations, whether you're training GigaChat or something else, recommendations as to how to perceive information and set the learning rate. You can try to factor in the specifics of a particular task, or you can generalize it. Adam, by the way, it's not yet universal. They are shifting towards universal, generalized recipes, and they are performing rather well. So the attempt to create a narrowly specialized tool is not always successful. Because there may be some generally applicable recommendations. You set this smoothness and then it works well. With the training of GigaChat, as far as I know, they used things that can be called universal, I think, partially. The same stuff is used to train a lot of other things, and those are general principles. So this is, once again, universality, but you can go beyond those limitations, those borders. Of course, you can broaden this context. Once again, it also applies to convolutional neural networks. There may be some universal logic that you can use, and then you assess the scale of its universality. It's a very interesting research problem. So this is a great idea, but how great is it? This is a universal thing, it's very good, you need to put it in the textbook, and this, some time will pass and it will replace adversarial networks, diffusion networks. But if something looks like it's here to stay, then we need to promote it and advertise it. Thank you very much. See you next year. Thank you, Alexander, for joining us, and thank you for your enthusiasm. Alexander Gasnikov and Maxim Yeromenko, this applause is yours. We thank our speakers and we move on with our program. Just 5 years ago, we couldn't even imagine how AI would permeate our daily life, our work. We couldn't assess the scale. But in 2024, the level of implementation of AI in business processes, meaning its application in at least one business function, raised from 55% to over 70% in just 1 year. These are global figures, and they are very impressive. What goes next? What happens next? We'll hear about it from Go Meng and his presentation. Professor of Shandong Academy of Sciences, Dzinan Institute of Supercomputer Technology, Tsinghua University of Technology. Go Meng, the computing power era. Drive the acceleration of digitalization and intelligence.
Thank you. Good afternoon, ladies and gentlemen. My name is Guo Meng from National Supercomputing Center in Jinan, China. As you know, in the past few years, AI has made a great achievement in application and technology research. I'd like to discuss a bit more about the supporting environment, the computing power. So, what is computing power? Computing power could be defined as the ability to process information. It usually includes 3 topics: storage, compute, and analysis. If we talk about storage, it's just related to read and write. There's nothing more to get advanced processing of information. And compute is something related to mathematics. Analyze is something concerning to logic and intelligence. In the first beginning, computing power should be oriented from the brain power. If we look at maybe one of the smallest neural network of elegance, it has 300 neurons with 7,000 connections. It can help elegance to get in touch to the outside environment. And if we have a look at the fruit fly, it can use about 3,000 neurons with 500,000 of connections to help them get advanced behavior to the environment. On the right side, the human brain has 100 billions of neurons with 100 trillions of connections. That number of computing elements makes human brain the most intelligent maybe machine of the world. Because of the rapid development of brain power, humans know how to learn, how to get food and resource quickly from the earth. So this is the reason why human is dominating all kinds of life on the planet. Let me ask one question. Who is the people has the most powerful human of the world? If the question could be changed to who can remember the most numbers in a short time, there's a championship that is called the World Memory Championship. If you want to get win in this competition, you must recite thousands of random numbers or maybe put cards in a few minutes. And if you want to do some calculation, for example, in the middle figures, two numbers with 7 digits do the multiplication. Guess how much time do you need? 1 second? 1 minute? The answer is 10 seconds. So if we're talking about something more complex, like how to get knowledge, it's more complex, like the beautiful picture of the Russian State Library. You know, there's a lot of knowledge with a collection of people's development of our generations. People can develop tools to expand all kinds of abilities, like lever, pulley, and different kind of machine to expand the physical power. And also, we innovate the telescope, sound locator, or different kind of sensor to expand the eyesight and hearing. But if we have a look at the computing tools, that will be more complex. For storage, in other words, memory, people discovered image, language, characters, and books to expand the memory ability. And discover abacus, machinery computer, slide rules, and modern electric computing processors for calculations. And the topic for this conference, AI, people using neural network for analyze and inference. If you look at the development of different kind of computing tools, from 1,000 years ago to about 150 years ago, that's mechanics, abacus, slide rulers, and mechanics computer. And about 8 years ago to now is electronic or electric time. that include vacuum tube and transistors. After we have transistors, especially the integrated circuits, because of Moore's law in the last more than 50 years, the transistor on the chip doubles every 2 years. That means from 100 millimeter to 7 nanometer, we have massive computing elements on the silicon chips. A few years ago, when people discussed about is Moore's law dead, because of great requirement of artificial intelligence, Mr. Huang and NVIDIA continue the development for 1,000 times speed up in 10 years. Now you know the principle how computer comes from, and now how to realize great computing power. If you have looked at the most powerful supercomputer in US, China, and Russia, that data is from the list of top 500. You can know that there are 4 important key factors to improve the computing power. The first is the advanced semiconductor technology. From 28 nanometer to 5 nanometer, you can get more benefit from the silicon technology. And next, you must know, you must have massive computing units. The leading computer has tens of millions of cores inside. And third, you must have very efficient network to connect different computing cores. A good topology and high bandwidth and low latency. Finally, in recent years, we need hybrid architecture computing because just the CPU is not easy to get performance at a power consumption limit. Now you have the fastest supercomputer, but it's not okay for now because if you look at HBL, the most important benchmark for evaluation of supercomputing speed, the efficiency is around 60 or 70%. And if you look at the real applications like simulation or artificial intelligence, you must do a lot of more work to emphasize the code design. There's a story 60 years ago. The Nobel Prize winner, this physicist Richard Feynman, said that there's plenty of room at the bottom. That means we can develop high-end technology to speed up, to find new physics as a nanoscale. And recently, some computer scientists published a paper in Science said that there's plenty of room at the top. That means you have to combine the software algorithm and hardware architecture together for the total achievement by computing. Now I like to speak that there's plenty of room in physics. If we are reaching the limit of semiconductor physics, we like to explore different principles like quantum and photonics. And this is a hot topic in recent years to delve to the new computing power. Let's talk about some macro picture. There are a lot of device powers like house watt wind power that's related to mechanics. You can use force or Newton to elevate. And for the electric power, there's something related to the electricity. You can use volts to evaluate. And for computing power, it's something related to information. You can use instruction per set, operations per second, flops per second to evaluate. Computing power and the other powers development bring the industrial revolution and upgrading. There are two words, no matter what happens. The first is speed, second, efficient. We developed the method to speed up how to use the force that lead to the first industrial revolution. And how to use electricity efficiently, that lead to the second. And the computing power and related information technology help us to get into the third and fourth industrial revolution. There are different carriers for computing power, from cloud to edge. From cloud, we can use HPC, cloud, AI, and in the middle term, the network can we deal with information at the tube, the pipeline. And from edge, we have cell phones, mobile, PC, tablet, and even watch, and even the intelligent cars. If someday we can make the computing power as a basic infrastructure at the electronic power, it's very important to connect the different computing power together using internet or the computing power networks. I list some important topics of computing power edge. The first is research on new computing technology, like the advanced semiconductor technology, quantum and photonic technology. The second is develop the fast computing equipment to support the requirement. The third is construct the cost or energy efficient computing infrastructure. The fourth is building computing power network to balance the power consumption and computing output. Next is investigate simulating and AI applications to create healthy computing ecosystem. I'd like to talk a bit more about what we are doing now. I'm from Shandong province. It has long history and has the second largest population of China. And you may know Confucius, one of Chinese famous teacher, the teacher of all ages. And you may know the Qingdao beer that comes from Shandong province. Jinan is the capital city of Shandong province. It's very famous for its spring and water. I'm from the supercomputer center. It has long history in the past 40 years. And we developed and operated different kinds of computing facilities in the last 40 years. From the vacuum tube to the high-speed ICs. The speed up is about trillions in the past 40 years. We are operating Shengwei and Shanhe supercomputer. Shengwei is a Chinese homegrown computer with Chinese design CPUs. And Shanhe has massive CPU and GPU to supporting the AI research for recent years. And now we are building the computing power network across Shandong province. The first to connect Jinan, Qingdao, the two big cities. The second stage is to build a network across Shandong province. The third stage for now is to connect it, the most important computing facilities all over China. And using these computing facilities, we promote applications of supercomputing, like weather and AQI forecast, oil exploration, medicine, new material, new energy, and even agriculture. For example, we provide the leading computing resource to the weather and AQI forecast for the Ministry of Ecology and Environment of China. Now, the model is based on simulation. Very recently, we worked with some partners to develop AI method for the weather and AQI forecast. And this is the largest RF telescope of the world. It's called FAST. And it generates 10 to 20 petabytes data every year. Using our supercomputer, we help our astrophysicists to analyze the data. And now we like to find some AI tools help to deal with the signal generated by the telescope. We also supporting universities, research institutes, and companies from China to training their large language model. For example, ChatGLM is Chinese, one of Chinese generative language model. And also there are some applications driven by AI, like the digital human. And also, using simulation, we can do some computing-aided engineering for chemical engineering, material, equipment, medicine, bioengineering, using different methods, like from DFT to multiphysics. Now, using AI for science and engineering is a hot topic. We are also working on some new topics like photonic AI for the future. We like to build a prototype of photonic computing facilities together with our Russian partners. If you have looked at the recent development of China's computing facilities, just as the President Putin mentioned on the first day, we encourage our international collaboration together with the homegrown technology. For the past 40 years, you can see we have developed a lot of Chinese brand supercomputer in China, and some of them have ranked the first place of top 500. And in recent years, according to the national strategy, there is the data computing in the West. China has built a lot of computing centers in different provinces of China to leverage the power consumption and computing output. Let's discuss something about the future. As you know, computing power first comes from the brain, the animal brain or human brain. And because of rapid development of human and human culture, we have a lot of computing tools based on different principles. For example, mechanics, electronics, quantum, or photonics. And now we are watching how to make it more smart and more intelligent in the near future. We like to compare all these technology to training, to develop new technology or tools to deal with intelligence. Maybe we can expect in the near future, we can converge the brain power and machine intelligence together. Finally, they need to achieve that target. The international collaboration is very important. We like to get close collaboration, international collaboration with you to develop massive parallel simulation and AI codes based on the current leading computing facilities. And second, to initialize the photonic AI collaboration. And third, I think is most important, is explore the AI application in science, engineers, industry, livelihood, etc. It is it's very important to balance the investment and outcome of the AI. Finally, I'm from Jinan, Shandong province. It's not far from here. It's only 6,000 kilometers away. By plane, it needs 8 hours, and through internet, we can communicate at any time. Welcome to visit Jinan. This is our center. Thank you very much.
Thank you. Professor Goldman, ваши аплодисменты.
Professor Goldman, we've learned about the computing power era and driving the acceleration of digitization and intelligence. And right now, Sanath Raj, the leading researcher and the main data scientist in telecom from India. He's going to talk about the generative AI that can deliver up to trillions of dollars to the world economy. Sanath Raj, please, a very warm welcome. The leading engineer and the main data scientist in telecom, Sanath Raj. LangChain for generative AI.
Hello, hi everyone, good evening, thanks for being here. So what we'll do today is understand one of the most popular frameworks that helps us to build products really quick, LangChain, and there are competition or products similar to this. We'll probably touch upon that a bit. So today, real quick, we are going to understand why there is a need for a framework like this. What is a LangChain? Why are we interested to know that? And few basic aspects about what LangChain brings in. Like it helps you brings the tools, routers, agents, racks, and even build chatbots for yourself. So LLMs or the foundational model, as we know it, are good at a lot of things. It can do language comprehension, it can do or be very good with reasoning, it could summarize, it could build code as a co-pilot. But that's with the foundational model. But also, there are certain specific aspects where it has to get better, or the contextual or the data awareness is missing. That could be like a cutoff date of a training date. If a model is built probably on data till 2023 December, it may not have something as recent as yesterday or last month, or something specific knowledge that's within the company or within a particular team that's probably not known at the time of the training. And sometimes it could hallucinate, and we could not have things that are factually correct sometimes. So that's an issue. Bias and ethical, I think over a period of 1-2 days, we have looked at how bias and ethical issues become more and more critical when we take on this journey. And like I said, there's a lot of dependency on training data, and it's not really good at understanding things that are pretty complex. So when things are standing at this juncture, how do we make use of certain things that could augment the foundational model to make it more context and data aware? That's something that we will look at. So this talk, we are going to understand one such library or one such tool that is useful, which is LangChain. It's an open source tool. It helps the developers to build things real fast. But what's LangChain? It's like the name suggests, it's a chain that binds various components or modules around the language model, and it enables developers to build or have capabilities done real fast. And why is it getting popular? One, it's like a go-to framework by more developers. It makes things easy and fast with the integration. It simplifies the overall journey of getting the foundational model up and running with the user-specific tasks. And it helps us. LangChain can help us with many of things. It's like building, we have LangChain. And if you want to have things productionized, we have LangSmith. And if you want to actually deploy it and serve it as an API, then you have also a component about it. So we have LangGraph that can actually build agent and agentic workflows. LangServe that could actually deploy and make it as a RESTful API. And if you want to evaluate, monitor, then we have LangSmith. And overall, from a landscape perspective, you have LangChain, and then you have community integrations with the Azure and with the OpenAI. But what problem are we trying to solve? So, like I said, LLMs have a capability to do a lot of things, but there are certain things where it has to get good at. And one thing that certainly is required with regard to problem statement or solving is, making the foundational model or LLM more context or more data aware. So with regard to making the LLM more context or more data aware, there are some of ways or some of means of getting it. So one of the easiest or one of the most popular one is the prompting thing, where you define the system behavior to the model and you tell how the model should behave, and prompting would precisely do or give you results as expected. So that's like the easiest of the lot. The next one is making it more contextual by using technique like RAG. That's another thing. Or you could go one step ahead. These are like incremental. You could do PEFT or fine tuning, where you could actually have some training data and enhance the model with the more data. That's on PEFT. But there's another option of having something from the scratch and do a full training yourself. But on these verticals, what we are seeing, prompt and RAG is where LangChain is really good and it can be useful. So probably we'll look at cases and scenarios where we could use for the verticals in blue and green. So we understood LangChain as a model that changed multiple aspects around the model. One such thing is the tool. And a tool is something that helps us to interface the LLM with some of the APIs that will solve the problem of probably not having factual data or not having up-to-date data. For example, if you want to have it integrated with the LLMs, that's one of the tools. But also we could have it integrated with the Wikipedia. We could have it integrated with DuckDuckGo, Google Search, etc., which gives you information that's very factual. Connect that with the databases, etc. So that's the tool part. So we'll look at very easy or simple examples of how the code snippets will tell us to use the tool. So if you look at, there are two examples here that I have. One is for the specific tool called DuckDuckGo, which is equivalent of a Google or any search. The other one is Wikipedia query. And I instantiate the model saying, here search is equal to DuckDuckGo search. And then I ask model.invoke and I ask my specific query, I get the response. So this answer, what I see is not coming from the foundational training model. It's actually coming from the integration of, say, DuckDuckGo. Similarly, if you want an information from Wikipedia, you could also get it similarly. Say model is equal to Wikipedia wrapper or any other object, and do a model.invoke and call your query. And the answers are coming, like I said, it's not coming from the LLM foundational model, but it's coming from the API. So this way, you're actually solving the data accuracy or relevancy or having more up-to-date information. And the second things, other than tool, one good aspect about LangChain is called as agent. So here, with regard to agent, we have something called as React agent, which has the capability to understand based on reasoning, and it has the ability to reason and act. It's a bit of autonomous that way. And it actually automatically chooses the right tool or right path based on what's there. And it's also a good way of integrating with multiple type of say modality, etc. So with regard to the React agents, let's look at a very simple implementation. So here we basically have all the imports, instantiate the LLM, and then we have the template or the prompt template that defines the system behavior. And here I'm saying answer the following questions as best as you can. So you are prompting the foundational model to behave in a way how it wants. And then you basically have in this example, there are three categories or three aspects in which you want the machine to react or machine to give you the answer. So one is the tool which I'm engaging is a REPL tool, which is a good tool if you want to solve some Python related problem. So it's like a colleague or friend who knows very good coding. So this is that person. The other person is the Wikipedia wrapper who has more factual or more contextual information. And the other one is the Google search or the DuckDuckGo search. So with the definition of what each tool has to do, has to also say when is Python REPL useful. Useful when you need a Python or equivalent like a code specific problem. Wikipedia is useful when you look up a topic, country or a person, then Wikipedia is more relevant. And I'm also saying the behavior is useful when you need to perform internet search that the other two tools cannot provide, then you use this tool. And what I'm doing is at the end I'm actually creating an object called tool, and I'm creating a list that has all the three tools together like Python, REPL and Wikipedia and DuckDuckGo. And now I'll actually go and invoke this React agent, which is more like a chain. So I create a React agent where I plug in my LLM and also the prompt, which is the system behavior. And I create an agent executor which has the agent, the tools, which is collection of all the various tools, and put that as one block. And then now I invoke the model within the agent. And I have different types of questions. So I ask a question about a sports personality here, who is Sachin Tendulkar, who is a cricketer, and I ask a question about a Python-specific question. So the question here I am asking is, tell me about Sachin Tendulkar, who is a very famous cricketer. And here, because the question is more about personalities and correct informations, so it is saying entering the executor chain, and it is actually, because it is React, right, reason and act, it actually says I should use Wikipedia to look at this information, and it actually gives the information from Wikipedia. So next time around, when I actually use the same set of code, and instead of the question which is more factual or more current affairs, I now ask a question which is a little more technical. Now I say, write a user-defined function that can calculate the RMS value for a regression function, so which is a very specific task. And then I use the same or invoke the same agent. This time around, it's not actually invoking Wikipedia, but then it understands this is more Pythonic. So it says, I'll use REPL tool to write the function and calculate the RMS value. And if you see the verbose part, it actually looks into the input and takes the difference between the predicted and the actual value, and then the RMS is calculated. And if you actually look at the output, you actually get the code for the RMSE. So what React does is, it actually has the capability to reason and act. It's quite autonomous, and it could actually be solved to solve different use cases, different LLMs, different agents based on what's required. So something on the similar line, but not as autonomous as React agents, are router chain, which provides capability to the foundational model now to route based on the scenario. It's like you have different kinds of people or one person wearing different kinds of hats. So it could be a Python programmer, it could be a Wikipedia expert, it could be a legal expert, or it could be a multimodal model like image generating, text generating, video generating. Based on the scenario, it now gets routed like a decision tree, and each of the trees that get executed. So here in this example, we'll see how do we actually create this router chain. And we start with setting the system behavior. We are saying you're an expert, so either in physics, or here we are having a scenario where one is a beginner physics teacher, the other one is the expert physics teacher. Based on the question, the model or the chain has to be smart enough to route it to different scenarios. So here the beginner template expects, or rather answers, the questions that are a very basic level, and the expert would actually answer the question probably at a PhD level, at a more a detailed level. But it has to understand it by looking at the question. So now if you look at these specific questions, which we are going to plug in later, where I have two kinds of questions. One is like, how do magnets work, which is a fairly simple question, and the second one is how do a Feynman diagram works. So the other one is a fairly advanced question. So based on what's asked, it actually, for how do magnets work, it actually engages a beginner chain, and then it answers saying that the magnets work based on magnetic field, etc. But here in this example, it's actually engaging a beginner thing. But then for the same chain, you invoke, but with a different query. This time around, you ask how do a very detailed concept, or how do an abstract concept about physics to be explained. Then it understands. It's because of the prompting. You have set the system behavior. So now the system is smart enough to say that you have to engage a different chain or a different agent or a different router or a different person, and it actually works that way. But in this whole idea of being router chain executed, we could have things a bit more in our control by making or having some business rule implemented, by having some sort of semantic similarity of some sort of if-else condition. That's something we will look at now. So in this example, it's same as physics or maths. So here it's slightly different. It's a mathematical professor, and the other one is the physics professor here. And based on the questions you are asking, whether it's physics or maths, it should actually invoke the right kind of model or invoke the right kind of response. But here what we are doing before actually invoking, we use the semantic similarity. So whenever we want to use the semantic similarity, we'll have to convert the words to embeddings. You actually convert words to numbers using embeddings, any embedding model. So now you have a list, or you have a tuple with the numbers. So that's your system behavior for both physics and maths. And you have this system behavior also embedded. Then the user comes in, asks a question. So asks a question here about what's a black hole, and the second question is what's a chain rule in differentiation. So one question is more physics related, the other one is more mathematical. But what we are doing here is actually we are actually converting the query also to embedding. So I have my system behavior or the expectation embedded already, and my query is also now embedded. So now I can actually run a cosine similarity to see whether the question asked is similar to my behavior 1, behavior 2, or behavior n. And accordingly, I have an argmax argument which picks or invokes that object or invokes that model and accordingly engages. So if you look at the example here, what's a black hole, it says using physics, because the cosine similarity of the question of what's a black hole is more similar to the system expectation of a physics template. And second time around, when I ask what's the chain rule of differentiation, it understands it's a mathematical question, and then it invokes the mathematical agent. So this is how, in the context of use case, when you have multi-modal, multi-agent, or multi-systems being involved, you could use routers or a React agent to actually solve your problem. The other useful example with the LangChain is doing something like RAG, where you have a retrieval, augment, and generation. So in the first part of the code, what we see here is actually you have the documents. This is the input data, which is not part of your training data. This is something that you give because that will give you more contextual or more specific information about your organization or the use case. You chunk the document, you make that into pieces, convert all of that into numbers, which is the embeddings, and then once the question comes, you have the contextual data which you passed as the chunks also in the numbers, and the query that you're asking also is now converted to embeddings. And then you look at the, again you do a semantic search of nearness of what is the question that you've asked is near to which of the chunks that are there. And what you do is basically make it more contextually richer by feeding this additional context with the question. So I can have very specific questions. Let's assume we are talking about building an app that will help users to understand details about the insurance policy, etc., which is very specific to a use case or a project. So I could load all the PDFs or all the Word documents or all the information about this particular knowledge. And now the question is specific to this insurance policy or this insurance scheme, which is not part of my foundational training data. But then because of a tool like LangChain, I could actually make it more contextually aware. So let's look at how do we do it with the code. So now I have a function, utility function, which is a loader function. which can read any of the document, PDF, Word, or text, etc. And once I have the data loaded from the document loader, I basically have a chunking method that instead of passing one entire document at once, I actually split it into, say, 100 words, 1,000 words, whatever, and then pass it or save it as chunks. Once I save it as chunks, I now bring in vector database, wherein this vector database can actually save the embedded information of the chunks and store it as numerical vectors. And now the information about the context and about the query will be used in the next stage. But whenever it is retrieved, it has to be retrieved based on the contextual similarity or semantic similarity. So that's what we are doing here. Once we have the embeddings, we actually save it in a vector database, and we store that as part of the vector store. And then now I have my setup ready. So now the user is coming to this application and trying to ask questions that are very specific. So in this example, what I've done is I've actually passed a PDF, which is about a very popular document, which is about attention is all you need, which is about the BERT and the transformer. So I've loaded that document in my document loader. I've chunked it, and I've passed it to the vector database stored as embedding. So now when a question that's asked now, what is an attention layer? What we do is we actually ask the chain or the LLM the question, and also we look up this information in the information which is already there in the vector store. So we use the cosine similarity or nearness measure to understand which of the chunks, say 100, 500, or 1 million chunks, which of them which is already there in the vector database. This question of what is an attention layer, or how does this insurance policy work after say 18 years of beneficiary, etc., whatever is the specific question, we look at the chunks that are very near to this in terms of the question asked, and we retrieve top 3, top 5, or top 10 based on this. So now the idea is basically you have this information. So the idea is, if you understand a question better with the additional context, LLM also would understand the question better with the same context. So that's the entire idea. So now you actually pass this additional information with the context, and now you ask the question, what is attention layer? Even if it is not part of the foundational training model, because you have contextually you have made the LLM or the model more richer, it is now capable of answering the questions which was not part of the foundational model. So that's how RAG works, and RAG is one of the super useful tools when it comes to doing implementations on GenAI or LLM. So that's on RAG. And if we want to use LLM to build a very specific custom chatbot, let's see how do we do it. So here in this example, I'm using a Hugging Face model, and I'm creating an LLM class. I'm downloading the model from Hugging Face, or I'm calling any OpenAI model. Then what I do is there's a class of LLM, and then I do an invoke. I can ask any queries, or I could actually build RAG on the model, or I could have any prompt template or routing or agentic behavior expected. So here I'm setting the system expectation by using a prompt template saying you are a very helpful assistant. That means you are the foundational model would work very differently from a ChatGPT, because you have to understand ChatGPT or models like that are designed or tuned to actually have a conversational part, but foundational model may or may not be very good at it. So we're actually setting the system expectation by giving such sort of information, saying you are a helpful assistant, you are good at problem solving, whatever. And then you have your chain built with the prompt, with the LLM, and then you have user asking the question, where user can input the question and the LLM can actually answer. So here, I'm asking a very specific question to the LLM, now being augmented or made into a chat conversational bot, and ask the question, what is a rocket? And it answers, a rocket is a vehicle, etc., because it was part of the training data. But now, I ask the question of who invented it, where I expect the chatbot to have the context of what is it, Here I'm referring to it as the rocket because that's part of my conversational history or memory, but it doesn't understand. So I said it will have the problem of being factually correct. So now it actually hallucinates and thinks I'm talking about something, and it says invention of wheel. Who invented it as invention of wheel is attributed to some century ago. But this is one limitation that we have. So how do you overcome that in LangChain is basically having the same set of code but having one additional attribute in the chain, which is not only the LLM and the prompt, but also you have the memory block, which is nothing but have the conversational buffer memory stored, and you could save that as a JSON or have it saved in your S3 in AWS. But that's the memory which is part of the current cache or the conversation, and then you stack that together as a chain which has LLM, prompt, and the memory. And now if you ask the same similar question to the chatbot, it works really well. So I ask what's a nebula, so it says it's a giant star, etc. But now if I ask the question, how is it formed, so it understands my question is about the nebula, and it has this conversational awareness because this conversational buffer memory that's getting stored. So yeah, so these are the things I thought I could share with you with regard to LangChain. So thank you everyone for being a very patient audience. Thank you.
Thank you very much for your performance. Thank you, dear Sanat Raj. And we have a few questions from the audience, and if you don't mind, I will ask them. At least one. What potential issues or challenges might arise when using LangChain to optimize a language model, and how can these be addressed?
If you can repeat the question, what potential issues?
What potential issues or challenges might arise when using LangChain to optimize a language model?
Sure. Okay. So the question is, what issues would one face while using LangChain for productionizing? So the issues what I've seen is LangChain works real good, and it's helping us to solve the problem real quick. But one of the issues could be when we want to actually get output in a specific format. Let's assume I've defined the system behavior to only give me JSON output. Sometimes it may or may not follow. Then if the schema is not the same, then we have an issue in actually getting the data of a different data quality than expected. So the production pipeline may fail. This is one. The second thing is when it comes to frameworks like RAG, when it comes to retrieval, only as retrieval as a thing, if you could compare this with its competitor, probably Llama Index. Sometimes the other one works better, but I'll not say that's always the case. But there are issues with scaling and productionizing. That's something that I've faced. Yeah, sure.
Thank you very much. Thank you for answering the question. Sanat Raj, applause to the speaker. Thank you.
We are continuing the last day, the science day of the AI journey. I'd like to remind you that today we are discussing science. We are going to have Alexander Panov. Trained neural network models in robotics are increasingly more often used to generate both high-level behavioral plans and very simple low-level actions. The use of pre-built demonstrations to pre-train such models faces the problem of low generalizability. What are basic behavioral models? What are their basic properties? We'll find out from the presentation of Alexander Panov. A round of applause. A PhD in physics and mathematics, director of the Cognitive AI Systems Lab at IRI, the director of the Center for Cognitive Modeling, MIPT, Alexander Panov, Basic Behavioral Models in Robotics. Right. Hi, everyone. Welcome you all on the AI Journey conference. We're going to talk about robotics. Quite a lot has been said about the AGI, about what we need to achieve AGI. I am from those researchers who think that it will take us some time to move to the AGI, not 1 year, not 2 years, and during that time we will have to go through this simplified AI, so to speak, something that we need to implement in the robotic devices, something that has to interact with the world and demonstrate its cognitive capabilities, and something that has to be in the physical world, present in the physical world, not virtual, and demonstrate its thinking abilities. Right, so what is the foundation of the learning approaches? Learning from demonstrations, that's the base. We'll look at a couple of examples of foundation behavior models. We'll talk about multi-robot learning. We'll talk about how can you build a team of robots. Let's start with the learnable approaches. Robots will not be able to replace us. They should not do that, but we need to leverage their capabilities to empower ourselves and to resolve new tasks. And these are the situations where robots can augment human capabilities and go to an absolutely new level of various tasks. Construction, for example, I dream to build a detached house or make a renovation at home with a robot, and I would help this robot to do the work. Collaborative robotics is one of the major trends for this year and for the years to come. If you look at this slide, we can see this diagram in terms of the number of robots that we're using right now and the videos that we see on YouTube every day with robots. In 2000s, more and more robots were manipulating robots that were working in these static, determined conditions at conveyor lines in the factories. Now we see more robots working in these same conditions that we work in the human-oriented environment. In the environment that is comfortable for the humans, not for the robots. And there are more and more robots like that. And the most important thing is that these robots are becoming cheaper. Only large corporations were able to afford a robot. Now, any household can buy a small vacuum cleaning robot and use it. They have to become more universal and more mobile, of course, and to make these robots more universal, we have to use the advanced AI approaches. There are two approaches. The adaptive learning model, using reinforcement learning. This is one of the key approaches that around 7 years ago put the robotics development in the new era. Now we can create a reward function that would build this reinforcement learning model. Second is something that the robot connects with the words. Well, when it tries to understand what we want to do, and these are the LLM, the language models. 2 years ago, language models became this disruption that helped the robotics to go to an even new level, where we see the robots that are not just falling all the time or switching off randomly, but those who work with us and live with us. In robotics, there are two areas. First is end-to-end models, is when we have a very large neural network that will give us a set of actions that the robots will perform in this or that environment. But these end-to-end models, for some reason, do not work properly. The specifics and of the physical world is pretty challenging. So I think that the modal architecture is going to remain the most popular one. It means that we build a robot from a number of components. So if you look at the robot on the picture, this is a multi-agent system. that builds a common control system for the robot. Every component is responsible for a separate part, for the concept, for giving the information about what is happening around the robot. One is responsible for planning, or the other one for training, another one building the map. And this multi-agent system will develop in the future. This is the future of all robotic systems. STRL, by the way, one of the examples, one of the systems that we test on different robots together with the colleagues from MIPT. That's the robot going on in the Technical and Physical University. There are many components in these robots that are learnable and cannot be trained. And that's important because one agent have to train and to get knowledge or get pre-trained, and others can work based on the classical rules with model predictive controls as one of the approaches. And the example of our work today is what we presented at ICRA Robotics Conference. It was the only Russian work at the conference. We said that the model predictive control can be injected with a special function called the function of the potential that shows how the robots go through the barriers, through the obstacles. Usually, I mean, the obstacle problem has been resolved for like 30 years, and when we do that, we need to put obstacles analytically. But if we build a map with the CV methods, this is the map that is not even because there are some obstacles that are too complicated. But if we train a neural network that will tell us that, okay, like there might be some obstacle there, it might work. And this is one of the most important results that was well received at the conference. We're going to talk more about the fundamental, the basic models, and of course we know that when we talk about the basic models in language systems, it is all based on huge volume of data that are not labeled. So the basic fundamental models appeared when we were able to extract something from these data, from text, from the images. So we have a huge volume of data, and we were able, without some special labeling, to build this model of the world, well, a so-called model of the world. But anyway, we were able to learn something about this data, and we were able to get this huge memory, let's say transformer model, to resolve this or that task. For example, we wanted to resolve the task of developing a strategy. And this is the basic model. But of course, for robotics, for the behavior data are demonstrations. So it's text for language models. For multimodal, these are text and images. For behavioral models, it's demonstration and doing some task. If we look at this slide, that is very characteristics. If we put all information for text models in tokens, it will be 15 trillion tokens. If we talk about images, it's 6 billion tokens. Videos, that's more expensive. It's 2.6 billion tokens. If we're talking about the robots, the actions that are needed, it's like 2.4 million tokens. Can you believe that? And if we're using the same architecture, transformer architecture, if it trained properly on this 2.4 million tokens, it is hard to expect it to train well on 1 million tokens. So we have two options here. Use something about transformers or try to modify them. The other one is to take data from some other place. That's a very good approach. The first thing, how to use data properly. You don't have to have a lot of them when you have a good algorithm. Serral, that's a pretty popular robotic algorithm. A practical task, you need to insert this thing in this hole, and it's very important for the engineering, because when we develop manipulating robots, it's very important for us to be able to, insert this thing here. And we used some data to pre-train our model, and if we organize not even the algorithm properly, but the sampling of the episodes, and we will complete an episode at any given moment in the right time without using the tokens that we lack severely, we can retrain a robot with real data in 20, 30, or 40 iterations max. So we can build the pipeline of the work of the robots in real environments, and we don't need a lot of data for that. But that's a pretty useless algorithm because it cannot really do anything else apart from inserting these things here. But that's a good example, published in the library, been used quite actively. Now, multitask pre-training, an example of a paper that I really like, the control transformer paper, shows that we can train a model without giving an award. So we don't give an agent the goal, the task. We don't set the task. The agent just sees some actions that are being done, and it then develops the causal effect. And then after that, we train it to resolve a specific task. So we add MLP layers that are responsible for training the transformer for specific tasks. And here it shows that this is how we can receive a basic model with this, that was trained on the same tasks. We have then similar tasks inputted, and the transformer is playing a role of the fundamental basic model. This is a good example of the fact that transformer model can be used differently from the classical ML tasks. One of the papers that I'm going to talk about today is deeper modification of transformer architecture. It's called recurrent action transformer with memory, RATE. We suggested to expand the context for language models. If we are going to use special tokens that describe not the information but the information from previous tokens, we will say that this is memory tokens, and we will thus understand what information is important, and we'll put information from one stage to the next one. But for reinforcement learning in robotics, we need an additional module here. We called it a specialized memory module. It's here at this transformer part that is highlighted blue. It helps us to map the tokens of memory for each other, with each other. And this is how you can show the efficiency of this architecture compared with the classical transformer architecture where you need memory. That's a great example here, because the robot here is playing that kind of a hide and seek, right? The robot has to remember where the ball is hidden. And this approach works very well. A couple of words about a very popular architecture and approach in robotics is diffusion strategies. We do not have to generate actions step by step, you know. Diffusion model has been around for a while, and we can generate the optimal trajectory on the go, immediately, skipping some steps. It's like we generate a picture from the scratch, right? And for that, we need a diffusion process. So we have to understand how to get one trajectory from a set of trajectories. There should be a reward function, obviously. But this really fits well with the explanation of the diffusion process. And yes, it shows that you can do that. You can generate such trajectory, and quite a lot of papers that explain that method. One of them is used in robotics diffusion policy. The idea here is that we're not going to generate trajectory. We're going to work in the environment of potential and the gradients of this potential. And the potentials are responsible for the actions of the in the environment where the robot works in. And here the classical diffusion process can be replaced with a process that we train with transformer. So this is how we give these trajectories that generate from noise not to be local, but we can make them long to make this trajectory working. Now, there are some limitations to this approach. We can work with diffusions, but locally. It's very hard to reason them for a text, for example. So it's hard for them it's hard to make them multimodal. I liked one of the papers on the IRIS conference this year that says that maybe we should work not in the flow matching, not in diffusion, but to do the flow matching. And the robot state resides on the Riemannian manifold. Now we can encode high-dimensional multimodal distributions more efficiently, and this is where you can make diffusion process, but actually flow matching instead of diffusion. This is one of the trends that I think next year is going to leverage these methods for more complicated tasks. Let's go to a more classical options of the use of foundation models. I'm going to give a reference to the article that says that we're going to work not with the basic models, but with the basic agents. Now, the paradigm of the basic agents in robotics is something that is close to our hearts. Working with an environment, we get a basic foundational model and use it for some tasks. What should they be? First, it should have a few short attributes. By training on a couple of examples, it should show you the strategy of resolving another task. Secondly, it should have a fine-tune attribute. So fine-tune is where we enter more and more data, and this is where we need to change the weights of the model so it can resolve new tasks.
These are the two main properties of robotics. They are hard to implement, and as I said, one of the barriers is data and the way we are coding the architecture. With data, an important thing, how can we overcome it? It's through generation of synthetic tasks, synthetic data, and creating a closed loop. We start with a small array of data. RoboCat is one of the interesting publications on this. One of the good examples, we are performing tasks, training to perform the tasks from the demonstrations. Then we add 2 or 3 examples of a new task in a simulator. The robot uses these examples to get fine-tuned with the synthetic data generated in the simulator. Then we close the loop, we add more data, and in the simulator we are increasing the amount of data. We no longer need expensive demonstrations where a human would perform this task. This is a very promising area in robotics, synthetic simulators, where we can generate data for different problems. They create an environment where we can generate data without which we could not train foundation models. This is how a foundation model looks. Once we have solved these problems, OpenVLA is one of my favorite architectures. It's pretty standard. All the main foundation models with the transformer approach work approximately like this. We have a pre-trained core. It can be a language model or a multi-modal model. We need to adapt it to work with other modalities, with images, for example, with depth. These adapters need to be pre-trained. For example, we're using a video clip, or we're using some other options that transfer us into a unified latent space. These models called VLA are very similar to the traditional models which work with multiple modalities, but as the output, they do not generate a video or an image. It's just one of the available tokens. This output simplicity unfortunately adds complexity elsewhere. If the input and output are pretty much the same, we have text as input and text as output, that's one thing, that's pretty simple. But once we make output more peculiar, more specific, we need other methods of regularization because we need to stabilize the whole process of training. For example, do chunking with a sequence of actions. But that's pretty much how these architectures work. I'm going to give you some other examples very, very briefly. The examples of what we have been doing in our team for foundation models, but not for universal tasks, but tasks related to navigation. So this is a foundation models for navigation using landmarks. We have an image, a semantic map, and a labeling of depth, and the robot must be able to use examples of different rooms or environments to navigate in a new environment with new information, and it needs to do this efficiently. So it needs to extrapolate existing attributes to new maps. We showed how you can do this effectively, and we are showing that the foundation model does not have to be unified. It can consist of different chunks of different modules, each module responsible for a specific task, getting to the target, for example, or exploring the environment, or moving from one landmark point to another across the rooms. The development of this approach was related to the question, why do we need these skills to be trainable? Let's add some good classic skill. And as a result, we got the skill fusion architecture. It enabled us to win the Habitat competition, the best-known competition in the world of navigational robotics. And essentially, this is showing that foundation architecture, behavioral architecture, can be modular. And these modules can interact with each other. Simulation with fine-tuning models plays a very big role as opposed to large language models, for example. This is an example of fine-tuning a model that was working in the text-to-image mode, answering questions based on an image. And we showed that we do not have to disrupt any basic attributes of the model. It can still generate its traditional outputs, but it can also work with a simulator. We're not violating its basic principles. And another important slide, most multimodal problems solved in robotics with the foundation models give us a new modality, for example, an instruction only at the beginning. There are no problems where we are building a dialogue in synthetic environments. This is when we give an instruction and then at some point we say, no, you're doing something wrong, you need to correct yourself. Or this is the middle of an episode, let's tackle another task, a completely new one. This means we have environments where we can interact with robots. One of the biggest projects of this year that we did is developing this environment, this framework called Igor, that enables multimodal reinforcement learning. We can insert a text modality at any point within an episode, and projects like this are very important for robotics. This is an example of our platformer multimodal architecture. We are developing it, and its biggest characteristic is that it needs to be fine-tunable in a simulator. Most models that I showed, unfortunately, can't do this. This diagram shows in yellow that we were fine-tuning the model in an environment. It was trained initially on other problems, and so it gets fine-tuned online much faster. And the support online only works when we are adding some function to the architecture, such as goal criticism. And now a couple of words about multi-agent systems, another important domain for robotics. In robotics, it's hard to handle one robot, and when you add more, it becomes increasingly more challenging. But robots are becoming more and more reliable, and the next step is interaction between robots and their interaction with the human being. Multi-agent reinforcement learning is the biggest tool that we can use to solve these problems. Our team is one of the leading teams building multi-agent approaches in RR. We are solving the classic navigation problem for several robots so that in the environment of a warehouse they could build their path, they could find their paths without collision. We have built a benchmark called Spalina. 20 to 30 classic algorithms. We're showing how to measure them correctly, because in multi-agent RL it's very difficult to do. And another important thing I wanted to add, this is my last slide, we were the first in the world to create multi-agent basic behavioral model. We showed that it turns out you can collect data in a special way, tokenize them and organize them for transformer training in a way that helps us identify the strategy or the behavior of an agent that factors in the behavior of other agents. It's very important. This article was accepted for AAAI, a very important international conference, and in navigational problems in multi-agent systems, I think this is a breakthrough. In conclusion, foundational behavioral models in robotics are very different from the models that we use for other problems, including multi-model agents. We need to make adjustments because our models need to work with data in a more efficient fashion, and they need to take into account the context that robotics provides. They are multi-model and multi-agent, even when we're talking about just one robot. This is something that we need. We do not need end-to-end architectures, and they are multi-agent in terms of interaction between multiple robots and humans. I agree with the previous speakers. I think that very soon we will have more fascinating videos showing that robots are not doing something in a standalone way, but are communicating actively with human beings, performing complex tasks. Thank you very much. Check us out on Telegram. We have a Telegram channel. We are just 90 subscribers short, I think, so do join us. Thank you. Alexander Panov, thank you very much for such an interesting presentation, and congratulations on what you said about your article, and congratulations on defending your doctoral thesis. As far as I know, that happened very recently. Congratulations. We have a couple of questions for you. Well, one question from the audience. You partially answered it, but apparently our audience, online and offline, would like you to talk a bit more about it. The development of robotics can radically change the world and our lives. What do you think are some of the other challenges that society can face now and in the near future? You partially answered that, but could you elaborate? When we are creating such powerful tools that disrupt our lives, multimodal models and language assistants, we need to add to this toolkit some educational component. We need to train people to use these tools and perform some frequent tasks so that people didn't view this as some magic. There's a magical fairy in my smartphone generating images. We need to bust this myth, and then there will be less fear of this technology. So I think technology plus education, that's the way to go. Thank you very much, Alexander Panov. Congratulations on your doctoral thesis. We continue with the robotics trends. And now we have a presentation on smart robots of the future. Our next speaker is Li Juzin, The first humanoid robot was created in 1970 in Asia. It could communicate in Japanese, it could see and hear. What can such robots do now? Let's hear more right now from Professor Li Jizun. A big round of applause.
Профессор Харбинского института технологий.
Professor of Harbin Technology Institute, Li Jizun. AI operational system for smart humanoid robots.
Hello, everyone. Good afternoon. I'm the last speaker, and thank you for your patience. And I'm a very great honor to share some our work with you. It is about the development trend of the humanoid robot in operating system. I'm Zhi Junli. I'm a professor of Harbin Institute of Technology. Maybe Harbin is very familiar for the Russian person. And I'm also a chairman of the Shanghai Jushi Intelligent Technology Company. So I'm a researcher and also an industrial man. Okay, the topic of this talk includes 3 parts. The first one is motivation. Why we just do such study? Research studies the operating system for the humanoid robot. The second one, what should I do to innovate? Because the humanoid robotic is a very new one. It is not just every devices, the devices we just used before, such as cell phone, a PC, that's all. So there is an innovation. What should I do? The third one, the last one is application. How it look like? Just we have done for these researches. So the first one is motivation. As we have, we all the computer science. Maybe there are a lot of majors, but I am a computer science. For computer science, what the operating system is? So we know that we all know that the Windows, just like this one, and we know the left one is a computer. It's a very old computer. It's hard to operate, but they use some expert. But we know that we use Windows, we can just make these devices can be utilized by everyone all over the world. What's the main part of this? What's the key of this change? We know that it is operating system. It is GUI, graphic user interface. That means there are a lot of elements in the screen. You can see it, watch it, you can understand what that means, and you can just click it or just make that work. So it is GUI, make the devices, make the PC computers go to everyone's world. The second big breakthrough is the mobile phone operating system, such as Android, iOS. And we know that if we look like this finger, it is a PC top and it is a old cell phone with a keyboard. But it is not very good to use. But if we use the Android, we can use our finger to touch the screen. So everybody all over the world, no matter what is old or young, or just our children, they all can use it. So it is a very big breakthrough to make a good thing happen. So now we are in the area of the new world, humanoid robot. It is maybe the topic. Maybe it is the most excited devices that the human can make. So it is humanoid devices, humanoid robot. It is made by a company of my student. So I and my student cooperated to make this thing happen. He make this robot, and I make the operating system to install to make that very good to use. So there are very big questions for these things. What should this question mark? What is the operating system to humanoid robot? If it is Windows, Android, iOS, no. So if we use just this operating system, we cannot make the human robot as a human. We cannot transform the robot as a robot into a human. So we should make this picture come true. But we cannot if we don't design a new operating system. So this is the motivation of our research. But what is the challenge of this operating system? You can just look at this figure. And this is a real robot. It worked in the real industry site. Just like that. This is in a company in the Suzhou province, just a city aside from the Shanghai. Maybe you know the Shanghai. So if we use this, if we look at this industrial site, the robot will do something that human can do it. You can see that this is just a coil. A coil, the robot need to take this coil into and weigh his weight. And if it is in the maybe in the 100, maybe that correct. That okay. That if it is with the qualified, that this coil will be put this side. If it is not qualified, it will be put another side. So this is the robotic need to work. But we know that if we use the robotic, if we use the operating system, there is a robotic operating system for the robot. It names robotic operating system (ROS). Maybe you all know that operating system, that software. But if we use this this ROS, that what they will work. They just need to understand. They need to understand the workflow of this work, of this job, and decompose the steps of these workflows, and do some program to make some program to do the things. And they need to build maps and build maps based on the workflows and setting movement trajectory on the maps. That's all. But if you know that it is a very solid diagram, not flexible. But if you look at these scenarios, you can see that there are a lot of dynamic scenes, dynamic situations. Maybe I have given you some examples. Environmental characteristics, table distance, because this is a real platform in the industry site. This platform may be large or small. You cannot let all the platform just as the same thing. You cannot, because it is a real world. There are a lot of the different differences. So if the table distance is just far, how did you do that? Just you need to redesign the whole workflow and make a programming. But if the platform is just small and you go near to the platform, what should you do? You need to redesign the whole platform, the whole workflow, and the whole workflow, and do programming from scratch. It is not very good, and it will be lead a very bad result. There are a lot of the need for customization. It is very difficult to make profit, to get some money, because there are a lot of work to do customization. So this is the current state of the robot. You cannot make profit. There are a lot of the things we all know in these days. We all discuss something about large language model, large model. And it will be work in the robotics field. It's okay. There are this is another design for the robot, large and small design, large and small brain. That means we have get a large model, a lot of the small models, and they will cooperate to get something done. This is just a picture come from the Google. Maybe you just have said it. But in my view, it won't work in this field, because if there are also a lot of the change in the real scenarios. In this example, there are unexpected unstable electrical conditions, such as in this is a kitchen. You open the lamp, it is a light. You can just do it. Use RGB, maybe some CV, computer vision, algorithm. That's all. But if you close the map, because you are the kitchen, the lamp cannot always be open. So what should they do? You cannot let a company, a big company, to train all the situations, all the models for all situations to do things. So it is also not practical for real world application. So this is the motivation of our work, the work of my team, my research group. So this is the overview of the current state of the robot operating system. You can see that this is a mechanical system, and this is computing hardware, operating system, and the integrated system, robotic ecosystem, autonomous evolution, and this is final form. And in my opinion, we have done these things. Mechanical system. Just maybe you see the humanoid robot in this stage, but there is no good operating system. There is no robot ecosystem at all. So this is our state. And if we get the final form of the robot, we need to do a lot of work to go through this line. So this is motivation of our research group. So the second was innovation. What should I do to make the robot can work in the real world situation without just the train again, just the program again and again? This is the object of my research team, and this is my dream. So what is innovation? This is a zero-layer architecture of the operating system for robotic, for humanoid robot. So I will give you some details of this architecture. You can see that it is the whole picture of this architecture. We have 1, 2, 3, 4, 5, 6, 7, 8. We can 8 the component. It is big parts of the our operating system. And all of these components is new. Let me give some example, some details of these components. this one, intent interaction. What means intent? In the past time, for Android, for the Windows, we just do some programming to make things happen, to make our computer work. But what intent? What the human do in the real world? I will give some example. What should I do if I just call to maybe my wife in Chinese? I will call it, and what should I do to do this job, do this task? I need to just pick up my phone and call the number. And that is the programming. That is procedure, the fixed procedure. We can just program it. But if we know that I come here maybe yesterday, just yesterday, and from the Beijing to Russian, and this phone cannot work because I haven't SIM card. So I need to another phone. I need to another phone to do these things. The program cannot deal with such change because the program just know that this phone can call, but they knew that we have a different situation. We have a new country that we need to another phone to do these things. Human can do it. The program cannot do it. This is the intent. What means intent? Intent means what is the object of our task. We just call my wife. So this is intent. What should I do to do? What should I do to just make the things, make the object can be satisfied, make the things happen? And this is the intent interaction. This is intent driven. And we need to flex task. We need to combine the ability of these two phones and can get the object to satisfy. So this is human do something work. It is not the computer do things work. So we need a new design for operating system to do these tasks. This is the new design of our architecture. So that you mean maybe you can just maybe you just wonder if we just make all things, all cases, we could just consider all cases, and we just program case by case. It is not it cannot work because there are a lot of the detailed cases. Because you know how many phones that the people can take. I am very wise as a third phone. What should the system can do if there are somebody no phone, one phone, two phones, and three phones, maybe a lot of things. So this is the new design of our operating system. Operating system is architecture. The intent contention, the intent interaction, the flexible tasks, and the autonomous evolution. So the operating system can evolve it by itself. Maybe I will give another example. At the cell phone, I have no SIM card. The cell phone cannot work, but I have the internet. The new app can work. It is WeChat. But I didn't program these situations. So the robot can learn something, how to use the WeChat. So it will be learn something, learn some new skills, and do things work. So it is autonomous evolution. So that means that in conclusion, that means that this new operating system must have some new designs. It is intent-driven. It is autonomous evolution. It has the flexible task, and so on. That is 1, 2, 3, 4, 8 big components. There are a lot of challenges in these components. But if we can achieve these goals, we can just get an object that we can just make the robot as an out-of-box usage, just like a phone. You buy the phone, and it will everyone can buy the phone, and you can just install the app what you want, and it will do the things work. And if you buy the robot just like there, just put it in there and it will be work. It will learn something. It will learn the new stage, learn what things happen in this stage, and it will do something work. Maybe clean the room, maybe do something, turn the light. That's all. So in the follow, I'll give you some technical details of our design. The first one is the intent. This is intent. This is an example of the intent. We use just some algorithm. This is the top level papers we have just published. You can just get it from the internet. And in this one, we can just see from the robot's camera, and we can just understand this picture. We know there is a person, there is a sofa, the relationship of this person and this sofa, and we get a series of this relationship, and we can just predict what will happen. What will happen? That means that what the people intend. We can say that these people will sit down on this sofa. So the robot can do something in advance. Maybe just clean up the sofa. You can just sit on this sofa. So this is the intent prediction. And we have just do it in a lot of the scenarios, for mobile phone, for another tasks. Another thing, the second thing is flexible task. This is the picture shows flexible tasks. We have a controller. The key design of this technical skills is the controller. It will monitor all the things happen in these scenarios, which we just show this picture. This video cannot be played. So if you in this picture, in this video, will show that this is a view from one camera, and if we just sit down on the chairs, there is a change in the view of this camera. That means that if the situation changes, there is a good new devices. It will work well, work more better. Yeah. So this is a flexible task, and there are a lot of the other technical design, such as the coordination, such as the semantic graph, and the semantic graph and the new skills just mimic what the peoples do. So there are a lot of the technical details, and we just show some things. And the final part of my talk is applications. There are four examples. The first example is the smartphones. This is a smartphone, the use case of the smartphone for my operating system. And I also tell you that I am the chief scientist of this big company in Chinese. And you can see it that this is an app that we have just designed for these scenarios. It is a flexible things. That means this is a travel example. During the planning, before departure, on the way, before arrival, after arrival, that this app or this service will change, will go along with you. That means that if such as this one, before departure, that your schedule of the airport will be show like this. This is a card. That it will remind you that you need to prepare something to go to the airport. and if you on the way, these things will change, and before arrival, change again, and again. That means that the tasks, the program will change along with your situation. This is another example. We use this operating system in the smart vehicle cabin. I'm also chief scientist for this smart vehicle cabin company. Just ignore it. This is an application example of our report. In this video, we can see that there is a robot. It will go around just like a person. Maybe you can see it because the video cannot be played. This robot will replace the worker in this industry site. It is worked in the real world, so we have done it. And the fourth example, the last example, is the autonomous drone operations. We can this is for the light, for the solar light electrical site. That if from this site we can just make some tasks and operate the autonomous drone to operate on it. So that means that in conclusion, this is the final one. In conclusion, I will just give you some overview of my talk. That in the future, the humanoid robot will maybe go everywhere in the city, in the street, in your home, in the industry site, and it needs new operating system. The current operating system cannot work, so it needs a new operating system. This operating system needs a new design. I have given you eight different challenges and what we have done for this challenge. And we apply this operating system in the mobile phone, in the smart vehicle, in the humanoid robot, in the autonomous drones, and we have got some results. And maybe in the future, you will. I am very happy to welcome you to China, you to Shanghai, and maybe you can visit my company and look around what the humanoid robot with our operating system, innovative operating system, can work, can make this humanoid robot just like a human. They can do everything the human can do it. Thanks so much.
Thank you very much, Professor Li Zhizun. Thank you very much, and we have a few questions from our audience, and if you don't mind, I will ask them. But first, what I'm thinking about, sometimes when I ask questions from the stage, it seems not very loudly. And what I'm thinking about, if I were artificial intelligence, the level of my voice will be increased automatically.
Maybe, yeah.
So, the question from our audience is, what advantages does a unified operating system offer for robots compared to highly specialized solutions?
Okay. It's a good question. We need a unified operating system because in the current state of the humanoid robot, not a humanoid robot, just an intelligent robot, not like just a human, maybe with some wheels. There are a lot of things needed to customize this robot, including the hardware and the software. This customization makes the devices very expensive. You know that the people don't like expensive. They like cheap. So unified operating system can make the everything will be cheap and very easy to use. As you know, there is a good example for the cell phone, Android, iOS. is a unified operating system. This system makes the cell phone go over the world. Everyone can use it. So it will be the trend, it will be the target of the humanoid robot, in my opinion.
Thank you very much. Thank you.
Thanks so much.
Professor Lee Ji-Zun, ваши аплодисменты.
Professor Lee Ji-Zun, thank you very much. AIJ is more than a platform for experience and expertise exchange. It is also a place where we summarize all the work that has been done in AI over the year. Next, we will have 3 exciting award ceremonies. We will learn who published the best scientific papers for AI Journey. We will also learn the names of the AIJ contest and AI challenge winners. Let's see you back in just a few minutes. See you soon.
РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Лаборатория Касперского – технологический лидер и единый партнер по кибербезопасности. 220 тысяч компаний в 200 странах и территориях доверяют нашей глобальной экспертизе и лучшим в своих классах продуктам, эффективность которых подтверждена многочисленными тестами, рейтингами и наградами. Лаборатория Касперского. Активируй будущее.
Центр искусственного интеллекта Т-банка. Создаем специализированные большие языковые модели для каждой конкретной области. Проводим фундаментальные научные исследования. Входим в топ-3 компаний по вкладу в open source в России. Разрабатываем решения для создания голосовых интерфейсов на базе точных, быстрых и безопасных моделей. Создаем сервисы обработки изображений, чтобы ускорить рутинные операции. Развиваем персонализацию и улучшаем клиентский опыт. Узнайте больше.
Дом РФ, как институт развития, запустил реестр программного обеспечения с применением искусственного интеллекта в строительстве. Уже сегодня искусственный интеллект оптимизирует работу со строительной документацией, генерирует мастер-планы, создает планировки на основе пожеланий жильцов, повышает скорость разработки архитектурных концепций, контролирует соблюдение правил безопасности на строительной площадке, анализирует материально-техническое обеспечение, обеспечивает эффективную эксплуатацию инженерного оборудования. Интеграция искусственного интеллекта на каждом этапе инвестиционно-строительного цикла увеличила производительность труда на 40%. Дом РФ создает будущее строительной отрасли уже сегодня.
Ladies and gentlemen, let's begin. Let's open this evening with a round of applause. The awards ceremony of authors of the best research paper for AI Journey Scientific Journal is open. We begin the awards ceremony. We will be rewarding the authors of the best scientific paper of AI Journey Scientific Journal. The publication is the journal is the third special edition of the highly rated scientific journal called Reports by the Russian Academy of Sciences, Mathematics, Computer Sciences and Management. This edition is all about AI technology, and it is traditionally published on the occasion of AI Journey Conference. SBIR traditionally opens the call for research papers for AI Journey, and this year we received more than 230 applications from Russia and BRICS countries, and 30 articles were selected by experts for the special edition. There is a money prize for the best article, 1 million rubles, and now we'll hear who is going to get this prize. To receive the award, to give the award and to summarize the selection process, we welcome on the stage Vice President, Director of AI and ML Department of SBIR, Maxim Yeremenko. Director of Ivannikov Systemic Programming Institute of the Russian Academy of Sciences, Arutun Avetisian. Academician of the Russian Academy of Sciences, Chief Editor of the journal Reports of the Russian Academy of Sciences, Mathematics, Computer Sciences and Management, Head of Mathematical Logic and Algorithmic Theory Department of MSU, Alexey Semyonov. Welcome, Maxim. Some opening remarks, maybe? Well, good afternoon, everyone, or rather good evening. I would like to thank our partners, the Institute of Systemic Programming. Thank you, Arutun. You have been contributing to the publication for a while now, contributing in terms of quality and quantity. We have a lot of fascinating articles. Over the 2 years, the number of articles has grown significantly, and maybe, and also the quality, Q1 maybe in the foreseeable future. And also the Academy of Sciences and Mr. Semyonov, personally, thank you very much. Thank you for giving us the opportunity to open the call for papers and participate in publications in different collections of articles. It is particularly important today to start with something, and it's hard to imagine a scientific conference without a collection of scientific papers. So this is a great start. We now have this ambitious goal to make the conference an A conference. An A-rated conference, but this is a conference about business and science and society, so maybe this could be separated in an individual track. And also the collection helps us select the research papers and research projects that have scientific value, scientific potential. As I said in my presentation, any scientific project is viewed through the lens of application and usability, so this is yet another criterion for the research projects to grow to products and sometimes even breakthroughs. Thank you, colleagues. Arutun, over to you. Indeed, we are doing this, we're not doing this for the first time. 172 articles were received, 45 selected after reviews and double-blind reviews. And I've just heard that I think the final number is 30 articles out of 170, an amazing result. Together with you, with the audience, we are creating this collection. And a message to all of you, please only submit the truly high-quality papers. Because we have ambitious goals, we do want to have an A-rated conference, at least A, and then we will see. After the selection process, we do end up with great articles, the 30 selected articles. Unfortunately, we can't include them all. We selected only the best of the best. I'm sorry that on such a jovial day I'm talking about work, but it is hard work. Any conference is about popularization and goal setting for the next few years. If you are going to apply for this collection, we do have very rigorous selections, so you can't just submit any old paper. Alexei, what would you say? Specialists in AI often say that there are academic journals with their history, with the background, ratings and such, and we have a conference. We're not interested in the quartile of academic papers, we are interested in the asterisks after the A. And now what we are seeing is a symbiosis, spur turned to the academic community, because the academic community has the peer review mechanisms, reviews by experienced specialists in the relevant domain, and they can apply the double-blind reviews to the papers. And this is a symbiosis between the AI conference and the oldest, the most respected journal, 100 years old, which collects the most prominent research in mathematics, computer sciences, and management. I think this is a great result of this symbiosis. My thanks go to SPER for organizing all of this event, and for the monetary prize of 1 million rubles. My thanks also go to the Institute of Systemic Programming, named Dr. Ivannikov of the Russian Academy of Sciences. Mr. Vitsyan, thank you for providing the peers for the peer review, and thanks to our team that works on this journal. Thank you very much. We're now announcing the name of the publication and the authors. This year, the best article that will be part of this journal is the article for universal representations of data for wells with assembling self-fine-tuning models. Written by a team of authors from Skoltech, Vladimir Zholobov, Evgeny Romanenkova, Sergei Yegorov, Nadia Gevorgyan, and Alexei Zaitsev. This applause is yours. Welcome on the stage. We're very happy to see you all here in person on this ceremonial day for AI Journey. The winners are here to receive the prize of 1 million rubles.
И, конечно же, победителям мы предоставляем ответное слово.
And of course, a couple of minutes for your comments, dear winners. Anything you would like to say?
Обязательно улыбки. Наш фотограф находится...
Make sure you're smiling for the camera. Our photographer is right in front of the stage. While you are smiling for the camera, with this thunderous applause, you have a chance to think on what you would like to say from the stage. Can I? Sure. Thank you very much, colleagues, for this token of appreciation of our work. I thank all of the participants of the conference and everyone involved in the organization of this publication, the journal, I mean, the whole team behind it. This work, this research is a part of a bigger cycle of papers where we essentially attempt to build a model, a foundation model that will be building great representations based on complex industry-specific data, oil and gas industry data. And in this particular research paper, we were able to combine two great, powerful ideas which help tackle a number of industry applications much more efficiently. What is the economic effect? Will we be producing more oil? Not at Sber, but I mean as Russia. Will we be able to reach a break-even point with $1 million? What are you going to do with $1 million? We will invest it into further research. How much time did it take you to write the paper? Well, sorry. First things first. Did you write it yourselves or did you use GigaChat? No. Come on. I'm a bit skeptical of GigaChat, so yes, we wrote it ourselves. It took us about 2 years to do that research, starting from the very first day when we thought of this idea, of this concept, and all the way to the final prototype. It took us 2 years. Yes, that was a pretty long and hard endeavor. Are you all from Skoltech? Not anymore, but initially, yes, we were all from Skoltech. We started the research on Skoltech's platform. Wait, it says 5. There are 5 names on the slide, but I do not see the other 2 colleagues. Yes, unfortunately, they couldn't join us, but they exist, I assure you. Thank you very much. Please take one more step towards the edge of this scene for another photo opportunity with more light from the limelight, because you are indeed in the limelight tonight with your million ruble prize. Hold tight. Thank you, and thank you for advancing science and research. We wish you every success in your work. Thank you for your contribution. Thank you for being here to inspire scientists and readers. Maxim, just a moment of your time, because we have another awards ceremony. Awards ceremony for winners of AI Journey contest. As you heard, we are going to give out prizes to the winners of the 9th International Online Competition for AI Journey contest. The contest was held with the support of IRI Institute. Every year, participants of this competition offer state-of-the-art AI solutions which empower people, improve the quality of life, and help optimize business processes in companies of different scale. This year, we had more than 1,500 participants from 23 countries fighting for the main prize. We received 4,800 solutions. The total prize fund is 8.5 million rubles. The contestants had to solve 4 problems in multimodality, multi-agency, AI in robotics, and large language models. And let's begin. Let's find out who submitted the best solutions. Challenge in Ecom AI Assistance. With this challenge, the participants had to create an AI assistant based on GigaChat in order to communicate with users and recommend items. Maxim, you won't be alone here on stage giving out awards. Please welcome to the stage Senior Management Director, Director of Data and Recommendation System Department for B2C, Sber, Ivan Kuzmin. Maxim, Ivan, please move a little closer to the edge of the scene to be closer to the audience. The floor is yours. Hello, everyone. Welcome. Well, AI is different. AI related to recommendations is something that is closer to my heart. Search engines, recommendation engines. With the help of AI, we can select the best music, the best goods and products and services, and obviously can be very helpful in other areas of e-com. Large language models are, of course, related to such recommendation systems and engines, and we set this, in my opinion, highly pertinent challenge that has to do with creating a personalized AI assistant that recommends different goods. We received all kinds of different submissions with prompt engineering, with all sorts of methods and techniques. And we'll see what kind of solutions out of these exciting submissions we could implement in business, in practice, because it does, they do have a business value to a large extent. Thank you very much, Ivan. What about you, Maxim? This is an interesting challenge in terms of research, but it could also be very promising in terms of economic effect. From the perspective of Sber, I think this is the challenge that will provide additional benefits for the customer in the form of accurate and relevant recommendations, and it will also generate income for Sber. Thank you. Let's find out who is third. 300,000 rubles go to Alexander Lidovsky. Alexander is joining us online. Let's see Alexander on the screen. Hello, Alexander. Good evening, everyone. I'm just away for a holiday, so I'm sorry I can't be there in person. Congratulations on your third place. I saw your post online about how you tackled that challenge. Can you share in just a few words what you thought about the challenge and how you are trying to solve it? I really enjoy the challenge. As Maxim said, it really has great monetary potential, income-generating potential. And this is the best challenge from the perspective of LLM effect and our expectations of it, and it's great to see that so much attention is paid to LLMs. Traditionally, I hope that traditional classic search will yield its place to conversations with an AI assistant. I used a category tree. I tried to identify the most relevant goods and include that in the category tree that gave the best results. I know that some other guys, Anton, for example, did an end-to-end pipeline. But with my solution, I spent not much time on the solution. I think I had 30 attempts. So it was pretty efficient.
Alexander has a YouTube channel, Big Lidovsky, almost Libovsky, in Telegram, right? Yeah. I thought you will be like wearing sunglasses and with a glass of white Russian cocktail in a robe, right? Anyway, there were quite a lot of solutions to this problem, and I think that's congratulations to you. Yeah, where's the money, Lidovsky? Yeah, congratulations. I hope it becomes yet another step towards your achievements. Stay tuned, many other things to come. Second place, 400,000 rubles. Alexander Perevalov is the winner. For every problem, apart from top 3 winners, we have a special award for the quickest solution. And Alexander became one of these winners as well, so he is receiving another 200,000 rubles. Congratulations.
Здесь лучший свет, здесь вас лучше слышно.
Yeah, just come to the fore.
И больше вдохновения для того, чтобы придумать ответное слово и поулыбаться нашим фотографам.
Alexander, спасибо большое за
So, Alexander, thank you so much for participating. A couple of words about the solution. Yeah, I focused not only on quality but on speed as well. I think I had like 10 requests to GigaChat. I decreased it to 2 requests to GigaChat. Moreover, GigaChat used GigaChat Lite, not GigaChat Pro. So the result was not only of high quality, but it was pretty quick. And it's a solution that will bring a lot of profit. So maybe to motivate people to resolve that problem, you need to share the profits with them. Good idea for the participants, not a great idea for organizers. I remember when consultants took a percentage from the saved state regulatory capitals. If you talk about Sber or VTB, like large banks, you're talking about billions of rubles. So you have to be pretty cautious here. Alexander, you're from Perm or from Germany? You're working here and there? Actually, I've learned, I've graduated an MA in Perm. I'm writing my thesis in Germany. I hope that next year I will be able to defend it, and then I will go to do something else. I will leave the academia. Well, you will be very welcomed here. Thank you very much. Congrats again, Alexander Perevalov. A round of applause. Yeah. 600,000 rubles. Like, yeah, that's great. And Ecom AI Assistant. The first place and 600,000 rubles goes to Anton Lekchenko. Unfortunately, Anton cannot be here with us. He is connected through video call. We, of course, congratulate Anton. All the winners are chilling. Hi, everyone. Hello, Anton. How is it in Novosibirsk? Very cold, very snowy, but you're not in Thailand, right? No, I'm sick. Well, get well. Congrats. You know, it's great that all the regions are participating, using different approaches. Can you expand on your solution? How have you selected the optimal solution? What were the methods? Yeah, I think the main thing that I was able to do is to use the characteristics of the products. I built an end-to-end solution that took the iteration from the characteristics of the goods and looked at the requests of the users and gave me one regression match. The sorting was, after that, basically ideal. It helped me to analyze the dialogue and to see what users wanted and to improve the frequency of the use. I measured the gap, this 10-15 requests that I made. These were, like, I used the more classical approaches, Berta, not the GigaChat. Anton, thank you. As far as I remember, you have been participating in our contest for the 3rd year. You were in the contest of the rare languages in Russia. I think it is a still relevant task given the GigaChat and OpenAI ChatGPT. You can use this money to go to Thailand and then to subscribe to our services and then go back to Moscow, and I think that you will have a lot of job offers. Anton Lekchenko, get well. A round of applause will give you some energy and health. Thank you very much for participating in the ceremony. Ivan Kuzmin, thank you. Thank you for leading the ceremony and for your words and for your great sense of humor. Next task. Next problem. Embodied AI. The participants had to implement the system of the controlling of the assistant robot based on the language instructions and visual information. The senior managing director, the director of the Center for Robotics of Sber, Alexei Ganachenko, is invited to lead the ceremony together with Maxim Yeramenko. Please, you have the floor. We have been dreaming for robots to help us, not to just paint pictures and, write texts and create videos, generate videos. With the scientific theses, everything will be fantastic, but as for the household tasks, robots are not doing that well, and without AI, and without any serious breakthrough, this dream will never come true. So the competition that we have organized together with IRI and Sber AI encourages teams to find new approaches, the new ways to resolve this problem, and maybe to get inspired and to continue that search in the future together with us in some collaboration. So I'm very happy that our contest attracted a lot of teams who tried data, tried to resolve this task only with data, and I hope that your next work will use real robots, not only data. Okay, a round of applause. The third place, 400,000 rubles go to Amar Ali. Not only the quality, but the speed were of major importance, so he gets an additional 200,000 rubles for the speed. Fortunately, Amar Ali was not able to present here, but we will give him the award. Amar Ali shows that the speed and quality can be combined in one solution. Now, second place now. Amar was not able to connect. I think he's like a constant participant of our contest. Okay, second place, 600,000 rubles, Alexander Dudin. Alexander is connected through a video call. Alexander, hello. Congratulations. Good evening. Good evening, Alexander. A round of applause for you. You don't seem to be very happy. You took the second place, 600,000 rubles. Well, could have taken the first one. Okay. Anyway, Alexander, a couple of words about the solution. I think it was the most challenging task, most challenging problem on AI journey. Basically, there were two problems here. The first had a fine-tune of a large language model, but the second sub-problem was the identified baseline. Thank you very much. Thank you very much, Alexander Dudin, and a round of applause. I hope you liked our challenging problems, and next year do participate. Yeah. Thank you. And the winner is Embodied AI, Viktor Durnov and Sergei Arefyev. And they get 800,000 ruble check. Okay, at least someone took the money prize. Thanks for coming here.
Спасибо большое еще раз.
Thank you very much. A round of applause to support the guys. Well, tell us about your journey. I had 5 submits for the first problem. And we divided it in 2 parts. And Victor it took him 4 days to solve the problem. You haven't reviewed the solution, but yeah, I know that you work together. Maybe the question about the feedback about the problem. Why did you select it? We needed the compute power that Victor had, and that was our competitive edge. We do have a lot of video cards. So yeah, we had to pay for that, but we had to pay for the electricity, obviously. So half of the money price will go for the electricity bills, yeah. But anyway, congratulations and a round of applause. Alexei Ganachenko, a round of applause. Thank you. Third task. Multi-agent AI. During this task, the participants had to create a multi-agent RL system where agents can resolve tasks and resolve problems, having different schemes of cooperation. And we invite the Doctor of Physical and Mathematical Sciences, a professor of Russian Academy of Sciences, the General Director of IRI Institute, Professor of Skoltech, Ivan Asaledets, is invited to the stage.
Да, всем добрый вечер.
Good evening, everyone. I'll be very brief.
Подготовка соревнований — это полностью заслуга команды
Vlad Kurinkov's team organized this challenge. You know, the contest was not in contrary to the everyday agenda of the team, because you know sometimes people complain that they have to come up with a contest, but actually it was the contest was pretty much in line with our everyday activities. Thank you very much. The quickest solution, Alexander Dudin, connecting to us through a video format. The round of applause, and you can hear the applause, right? A couple of words about your solution. I took a baseline, decreased it.
То есть у вас была какая-то тактика, вы ее придерживались, да?
So you had it like a tactics and you followed the tactic. I have a tip that fine-tuned the baseline, used PyTorch. Anyway, made it clean and simple. I think that really is the round of applause. It's good for that. You know, sometimes it's easier to make it a solution than to talk about it. It's written all. Round of applause to Alexander Dudin. We're moving on. 500 ruble check. 1,000 ruble check. Ivan Sedych. Ivan is already getting here. Should come closer to the stage and smile to our photographers so that the world remembers that, and that it inspires the scientists and researchers in the future. So, how were you able to achieve that?
Раз.
Командная поддержка.
Да.
That's teamwork. It will take a lot of time for me to talk about the solution. I would just like to say that you have to be diligent, you have to be disciplined, and self-control. It was very nervous, especially the last week when everyone was pressing each other, and you had to be emotionally stable and healthy. Thank you very much. He optimized his speech and finding the shortest algorithm. I have a comment. Put a genetic algorithm where two populations are playing. So there wasn't just no training. Just wrote it, coded it, and there were no major costs related to that. So yeah, that's something. Well, these are the students. They usually don't have a lot of compute. Because, you know, artists, painters, they should be what? Yeah, okay. He should be able to know how to use Kandinsky neural network. Oh, yeah, you're right. 800,000 rubles, and the winner is Alexander Fedotov and Marina Shandra. Oh, yeah, they are not in a hurry.
Скажите тогда про решение.
Yeah, a couple of words about the solution. The solution was triggered by baseline. Looking at the baseline, I saw that it is a deep learning solution, but maybe not only deep learning can be used to resolve this problem. I thought that the majority will be using the deep learning, and I wanted to be original. Ifs and else, yeah, that's what you did. Okay, that's how you do it. A round of applause, Alexei Fedotov and Marina Shandra. Yep, congratulations. The first place and 1 million rubles. Mikhail Golubchik, and your applause. 1 million rubles.
Подходите ближе, в самую выгодную точку света, для того, чтобы фотографии с наградой вдохновляли
Let's take a picture
миллионы талантливых.
so that this photo inspires millions of researchers around the world. A lot of interesting things can be said about the solution, about the research. So, how did you arrive to the solution? The baseline was fantastic. You know, I was feeling that people were working on that. Like, I didn't even want to break it, you know, it was so beautiful, but I had to. Right, yeah. I added the adversarial component between the agent, the competition between the agents, so they were like working together, but they had to compete with others. I added that, and that helped. And in 1.5 weeks before the contest, you graduated the RL course. No, I didn't even graduate from that. I had a few lectures. I understood what RL was. I read a couple of articles, and I realized, okay, that was a kind of a baseline, so I had to use something modern. But I trained them to compete with each other, not to cheat, and, you know, that was enough. That's the real workshop, a masterclass. There was a comment from Vlad and the team that the solution has 3 parts, and it's very hard to implement all of these parts separately. Thank you. Thank you very much for that, and congratulations, Mikhail, Ivan. Thank you. Ivana Salerets, thank you for being with us today. And we are moving to the next problem.
Задача Emotional
Fusion Brain 4.0. Participants had to create a multimodal model for the deep understanding of videos and recognizing emotions and intent of the people. For Emotional Fusion Brain 4.0 award, we invite the director of the Fusion Brain Lab and IRE Institute, Andrei Kuznetsov.
Спасибо. Да, я могу быстро.
Thank you. That's the fourth task, fourth problem that we've been working on. Every year we're trying to make it more and more complicated. Multimodality this year has become most popular.
Особенности своих решений.
I think the winners will talk about their solutions right now, and that will be very exciting. 200,000 rubles for the quickest solution. Artyom Lyam. Artyom is connecting online, and we're going to see him on the screen. Can you hear the applause? Do you see that 200,000 ruble check? Yes, hello, I can hear them all right. Thank you very much for organizing this event. Well, Artyom, you were very quick, the quickest one to resolve the Fusion AI Challenge problem. Andrei, do you have any questions?
Tom, what about your skills in Kaggle? Did it help you to tackle this challenge? Well, in principle, yes. That was... I looked at the baseline in my solution, and I thought that, well, there are methods with a better quality, with a better performance, so I decided to update it. Thank you. Let's discuss it after the competition. Great job, Artyom. Hopefully, next year, for the next AI Journey contest, you will be a grandmaster already. Fusion Brain 4.0, the prize goes to you, and there's another thing, the intellectual game, with a prize fund of 200,000 rubles. This award goes to, once again, Alexander Perivalov. This is his third victory. Congratulations.
Александр, ну вы уже все знаете, нужно выйти поближе к зрителям, сфотографироваться.
Alexander, you know the drill. Yes, congratulations, Alexander. Once again, this is your money. Stand a bit closer to the edge of the scene, of the stage, please. I don't really think that I would end up in this category. I mostly focused on the quality, and I was really interested to hear some feedback from the organizers because I was curious about some other approaches to it. All the questions were related to the emotions and people's personality and behavior and character, data collected from different sources. But as we're mindful of the timing, let's maybe discuss it after the ceremony. Thank you, Alexander Perivalov. An additional 200,000 plus the 600,000. And now the prize winners, third place, Daniil Kvashennikov. The award goes to you as well as the 400,000 rubles. Daniil, welcome. Let's take a photo for the history of AIJ Contest 2024. Daniil is not a newcomer at our contests, and it's his third, I think, year in a row that he is participating in the contests and winning. Yes, it does feel familiar, and I think we saw a similar challenge earlier. This time with the baseline, we saw two competing solutions. And as the challenge takes up a lot of computing power, the competition was about how to adapt the existing solution. I slightly fine-tuned it. Fine-tuned one of the foundation solutions, basic solutions with sound. And then some time later, there was an update for the baseline solution, and it was a bit better. My thanks go to the Roskomnadzor for blocking all the communities, for working with different data sets. Well, you should know about Roskomnadzor by now, with your experience. Thank you, and this round of applause is for you. And now second place. Apparently our contest is going to get our own book of records, because once again Amar Ali is the winner, 700,000 rubles. As I said, he was not able to attend in person, but we will pass this over to him. We're moving on. Thank you very much, Amar Ali. First place, 1 million rubles, go to Ivan Maximov, Joksan Asokar, and Dmitry Kosenko. Congratulations. This applause is all yours. I think this is the first time you're participating in the contest for the multimodality challenge. So what attracted you to this challenge at all? I think this is the first time we worked in multimodality, and that was a great experience for us. We're glad to see that our solution came first. I can briefly describe the solution if you want. Yes, in just a couple of words, if you please. We focused on preparing data, high-quality data, for subsequent training of LoRa adapters. Japsan did the data pre-processing and the training. We used Kv2VM to quantize it, and then we unquantize it for the original format and the original speed of the model. Dima did the quantization and dequantization. He also prepared the repositories for offline deployment, and I was responsible for the coding. I optimized it for parallel execution of the task on the processor and the video card, and I tested the code locally and on the server of the organizers. So it's a symbiosis of solutions. Thank you very much. Congratulations to the winners. A huge round of applause to Ivan, Dmitry, and Joksan. Maxim, thank you very much. We are opening the floor for the next awards ceremony.
AI
Awards ceremony of winners of AI Challenge. AI Challenge is an international competition for teams consisting of young people in artificial intelligence. Young developers joined together in teams and submitted their solutions in AI. In 2024, people from more than 8,000 young people participated in the AI Challenge from Russia and from 65 countries. Participants up to 17 years old had an opportunity to try their hand at the individual track called Creative. They were solving challenges with AI services such as GigaChat and Kandinsky, and today we're going to give away prizes in the research category. First Deputy Chairman of the Executive Board of Sber, Alexander Vidyakhin.
Здрасте, ребят.
Я с удовольствием забрал у коллег.
Hello, guys. This is my favorite competition, the competition among the young talents, young people. We had children up to 13 years old.
Провели и не привезли. Ну, вот так бывает. В следующем году обязательно надо привезти.
Fortunately, we didn't bring it this year, but next year we definitely will. We had more than 8,000 participants in total. 65 countries. The top 15 are Russia, Belarus, CIS countries. We also have guys from US, Canada. A truly global geography, a truly global coverage, which makes me very happy. We will certainly be developing this platform where we motivate people and help them grow into absolute stars and celebrities in AI, because this is indeed a big international competition. But now the most pleasant part of it, we are going to give out the prizes. First challenge, large language model. And now we'll find out who the bronze winner is in this challenge. The team is Baby Yudis, Roman and Valery Tamrazov. Welcome. You are getting this prize of 600,000 rubles. Hi, I know who babies are, but what is Udis? We can hear a lot of people cheering for you. You have so many cheerleaders here in the audience. Your brothers, I take it, right? Yes. Was it difficult? Wait for the mic, please. Oh, they are saying that Baseline wasn't launching. Don't give them the mic then. So Baseline wasn't running. We couldn't run it. It was indeed difficult. We had to code from scratch. A round of applause for you, and the money is also for you. Congratulations, they came third without the Baseline. And I'm sure they used minimal computing powers, because Iman is always saying, we don't have enough computing power, not enough computing power. And there you have it. We have a team without any Baseline, coding and ending up third. Okay, who is second? The silver winners are the boys. This is not the first time they have conquered the AI Challenge peaks. Konstantin Sigalov, welcome back. The team is getting 900,000 rubles. So the boys, I see only one boy. The other one is in Canada, I take it? Yes, unfortunately, he couldn't join us here. Yeah, I imagine. Will you share the prize, or will you not be able to transfer his portion of this money because of sanctions? I'll do my best. Was it hard to solve the challenge? The challenge was indeed very difficult, and we spent a lot of time experimenting, and it turned out pretty okay. Were you able to run the Baseline? Nope.
Держите, сейчас дождемся первого места, у которого тоже, наверное, Baseline запускался.
Looking forward to the first place winner. I'm sure they had problems with the Baseline as well. So first place and the 1.5 million rubles go to Singularity AI. Alexander Astafurov, Andrei Khlopotnych. Alexander, I'm sure, remembers last year when he went up on this stage as well. I can see that the hostesses bringing out the checks are smiling wider and wider. Can we have a microphone, please? Well, tell us about the Baseline. Well, we couldn't run it. That's all you need to know. It's not a bug, it's a feature. This was made on purpose blocked by Roskomnadzor on purpose to motivate you.
Что было? Сколько у вас сабмитов было?
How many submissions did you have? 56, I think.
Примерно 56, да?
You think? Okay, what was the most difficult part, other than the baseline? Figuring out what's going on at all, what are the criteria, and what you need to change, what features you need to change, right? Yes? Okay. All clear, singularity forever. Alexander, please stay on this stage for just a minute because we continue with the next challenge. I'm really eager to know if anyone was able to run the baseline. The challenge is called Investment, and that challenge was set by the winners of AI Challenge 2023, Makar Baderko and Semyon Yepanov.
Задание подготовили победители AI Challenge 23 года Макар Бадерка и Семен Епанов.
So once again, that challenge was set by the winners of AI Challenge 2023, Makar Baderka and Semyon Yepanov. Wait, before we continue, who are you? What are your names? Maxim Gadzinov, Maxim Kumanov, Fyodor Fyodorov. You are not listed on the teleprompter.
Понятно. Но просто не было оптимизации экрана, я понял, да.
Sorry, we didn't optimize the screen, we didn't update it in time. So, but you are from the same team, right? Yes.
Давайте, хватайтесь за него.
This check is yours, 600,000 rubles. The team is called 548. Third place in solving the investment challenge. Vadim Gadziev, Maxim Kulagin, Daniil Teplov, Rostislav Aladikhin, Fyodor Fyodorov, 600,000 rubles, and a photo with Alexander Vedyakin. That is worth much more. What are you going to do with the money? There's 5 of you, and there's 600,000 rubles. So, yet another challenge for you. What about the baseline? We didn't even look at it.
Был вопрос. Куда вкладывать-то будете деньги?
So, where are you investing the money? Well, first we need to exchange it, to convert it into US dollars, and then we'll see.
Берите и быстрее покупайте, что вы там хотите, доллары или еще что-то.
Quickly buy the dollars.
Куда будете вкладывать деньги, может быть, я бы тоже вложился.
Wait, you didn't answer the question, where are you going to invest the money? Because maybe I should invest too. Well, we could invest some of it into Sber, maybe, and in ourselves, our professional development. Yes, that's much better than investing in stocks and shares. Thank you, congratulations, 548. Second place, a team called AI Visionaries, Fyodor Yebifantsev and Lev Kayumov. Please join us on this stage. You are getting 900,000 rubles and a photo with Mr. Vedyakin. Well, a photo with me is not worth 900,000 rubles. It's rather an opportunity for me to take a picture with you. I love these challenges, these competitions for young talents, because as I grow old, I'll be able to show photos with you, young talents, as evidence of being worth something. Well, you're visionaries. What can you say? Well, we didn't look at the baseline. Okay. The challenge was very interesting. What methods did you use to approach it? We experimented with a variety of models, and at the end of the day, we came up with a pretty unique solution, but it would take too long to describe it. Thank you very much. A very detailed description. Congratulations, 900,000 rubles is yours. Please return the mic and take the money. And the number one winner and the main prize go to the team aptly named E1. Ivan Sazanov and Ivan Zagorulko. The stage is yours. You're getting 1.5 million rubles. I'm sure you didn't check the baseline either. You just selected the right parameters, and Bob's your uncle, right? Yes, I really enjoyed the pre-processing stage. I really enjoyed this opportunity to study the investment area in the market, and we're now considering where we should invest, but it will depend on the key rate. When bankers hear the words key rate, they get into a trance-like state, you know. I really hope you will be earning even more and that you will invest all this money into yourselves and into your professional development. That will give you the highest ROI. Congratulations, and now the next challenge. Self-development. The bronze winners are Alt plus F4, Artem Popov and Alexander Gladkikh. The 400,000 ruble prize is yours. And a photo op. A step forward, please. The main question of the day is, did you have the baseline? The annual bonuses of the organizers team depend on your answer. No, we didn't have the baseline. Okay. No bonuses then. Not everyone is smiling in the audience, by the way. So what was the main challenge? I think the main challenge was to test all the models and figure out what are the characteristics that need to be retrieved from audio files, what to use. What was the self-development part? Self-development, you mean in the challenge? Well, the challenge is called self-development. I didn't try to solve it. I'm not sure why it's called this way. Were you developing yourselves or the model? Both. We were developing ourselves and we were helping other people to develop themselves. The challenge was to help people correct their speech defects. Excellent. I'm sure many would benefit from it. Thank you very much, Artem Popov, Alexander Gladkikh. Second place. The team called Decepticons. Pavel Kravtsov, Denis Davydov, and Andrei Boryskin. And their prize, 600,000 rubles. Hi, who are Decepticons? They're from the movie called Transformers. Never seen it. I don't think I see one of you on the teleprompter. Oh, wait, found it. You didn't have the baseline, I take it? No, of course not. We did it from scratch. I think we were overzealous a bit. We had roughly 200 submissions. I think it's called brute force. No, come on, no. Maybe at the very end, but well, not necessarily. It also reminds me of a DDoS attack. Yeah, that's similar. We used something similar to what the previous teams did and what the teams coming after us did, but hush hush. We really enjoyed the challenge. Thank you very much for setting it. I think this was the challenge where you could have the most fun. Thank you. This money is yours for your self-development. Don't be shy. Take it. Hope to see you back next year. Decepticons. I think in parallel, we are holding a competition to see who has the biggest amount of cheerleaders. So first place and 1 million rubles go to the team that submitted the best solution for the self-development challenge, the team called O2. Alexander Smirnov, Nikita Iltikov.
Hi everyone, congrats. I think you won a couple of times, so you know how it works. Tell me about the solution then. Well, we've started with trying to build not only the precise but large-scale solution. We understood that the problem will get more complicated, so we tried not to build local solutions, but we used an end-to-end approach. We developed a process pipeline with several steps, and we understood that the other problem that was different from the target one helped the models to be more consistent and to provide better quality on the second stage. Okay, so what happened?
Вам здоровья, много денег.
Okay. I wish you good health, and we are looking forward to seeing you soon next year. Thank you. Okay, a round of applause again. The next challenge, and the name of the challenge is education. Third place goes to logistic depression. Maxim Mashtalin, Jan Gustav, Mikhail Schwerner, 400,000. Yeah, the guys they just passed me by. Yeah, totally ignoring me. Yeah, why not? Let's just enjoy you. Can you, or are you experiencing logistical depression because you took the third place? What about the task? I'm not interested in the task. Tell me about the solution. Did you have a baseline? We didn't have a train. We made a train ourselves. Wow, really? Yes, we did it. What other things didn't you have?
Беспорядок. Так, это не то. А у нас знаете, какой бейслайн?
You know what baseline do we have when you have bonuses? There is a baseline of bonuses, and you are decreasing it right now. And when it goes to 0, then a person is finding a new place to work. So I have my own hackathon inside my head. Maxim, you did the right thing in commenting. You know, the guys are so confident, they don't need any baseline. They don't need a train even. Why? That would be too easy. Do you need computers at all? Yeah, sometimes we use them. Yeah, great work. I am proud that Sber can motivate people to work without anything. 400,000 rubles to the winners. A round of applause. Yeah, great job. You're from ITMO? Yeah, ITMO, MIPT, and High School of Economics. Can I use this opportunity and ask two people to make me pass the exam, please? Could you ask them, please? Who's your professor? They're watching online. Okay. Roman Popkov. Please put that pass grade to these guys. Do I need to ask the rector too? Yeah, I need a pass too. Yeah, I'll ask him.
Лучше направьте его Максиму Еременко, и мы, да.
I think Maxim Yeremenko will work on that. Yeah, we'll help you. You didn't find the baseline, you didn't find the train. MIPT? Ask everyone. Yeah. Okay, just help our students. Okay, guys, thanks a lot. Thank you, Mr. Vidyakin. These students are lagging behind. What happens with those who are A graders? Well, it depends on how much time these laggards spend on finding the solution. Yeah, logistic depression, very optimistic team, nevertheless. 600,000 rubles. ALT. Yaroslav Alapayev, Yegor Kuleshov, and Stanislav Andronov. Nika Smirnova, Konstantin Ivanov. A round of applause. Yeah, hi everyone. And we have at least one girl here, finally. So we didn't have any baseline, didn't have any labeled data. Well, that's how it goes. We didn't have any local videos, so just a cloud. We labeled it with LLM, and we said in the request that we are going to give you $1 billion as a reward. I hope you will not. I hope you will not disappoint AI. Start with this 600,000 rubles. Just say 600,000 is $1 billion and just enjoy. Use this prompt. And we're going to use that. Yeah, congrats. Any words? Just a thank you. Okay. Then you're doing great at school? No, not at all.
Просто все проблемы уже сказали. Раз, ну, 7, наверное. Предыдущий участник.
Хорошо. Так, товарищи ректоры.
Right.
Ну и зачет нам всем, пожалуйста.
Вы школьники.
I would like to ask all the rectors and all the teachers to put a good grade to these students, especially for English. There was a lecture from India yesterday, so I have quite a lot of expertise in English.
У нас очень популярная школа, МБОПСОШ, Первая Бичурская. Привет.
What schools are you from? Well, yep, these schools, the first Pechora school. Everyone knows about it, right? Anyway, the department of the education of the city of Moscow. I do support these guys. Please put good grades to these guys. I am from Samara, and I'm from St. Petersburg. Okay. How did you meet? Kirill Chernikov, thank you. Well, that's great. Fantastic job. I am confident that you will do well at school. This guy who failed with the baseline, Maxim Yeremenko. Well, yes. It's not a bug, it's a feature, right? That's what you want to say, Maxim, right? If you have any problems, just report to Maxim, and I'll talk with the governor. Yeah, that's the level of connections. Okay, Santa Claus with good grades will come a bit later. That was ALT team. And the winner is Rox and Oleg Drakanov, and Ragmir Kunambayev. $1 million rubles. So Rox or Oleg. Okay. Where is Radmir? He wasn't able to come. Yeah, well, you're going to split that. Where are you from? From St. Petersburg. University, school. 239th Presidential School. Yep, that looks cool. You doing okay at school? Yeah, doing fine. There will be no requests for you.
Что было самым сложным?
What was the most challenging? The most challenging was the algorithm. You know, like at the final stages. We put a lot of redundant stuff there, and labeling data was a major problem. Well, that's not a bug, it's a feature. With labeled data and baseline and good compute, I mean, anyone can resolve any task. Try without it. Yeah, that's true. Yeah. Ivana Soledades, these are the problems that I'm going to put for you. Yeah, but that's what you do, basically. We don't have any other problems. That's real life, guys. Yeah. Prepare to work in a large corporation. Yeah. Say my greetings to Radmir. Sending this applauses to St. Petersburg. And the next task, metallurgy. Third place, minions. Anton Yepifanov and Daniil Karpov. 400,000 rubles. How did minions decided to work in metallurgy? Why metallurgy?
Мы даже не знаем, если честно так говорить.
Почему? Ну, кроме денежного приза, что еще?
You know, apart from money, what were you motivated with? Or you didn't care? We just looked at what to participate and we thought that this is a good problem. We liked it. Yeah, it's hard to argue with that. No data, no baseline. There are 3 images in the test. In the private test, I guess there are also 3 images. The track called researchers, I don't think it's a research, it's more of a product track. We tried to solve the problem with research methods, you know, try to think something up, but we kind of experienced a YOLO moment. Well, okay, good job. You forgot the money.
Забирает команда с прекрасным названием.
Second place goes to 42. Konstantin Spirin, Alexander Povarov, Ivan Penster, Ignat Sukhanovsky, Andrei Bushin. 600,000 rubles. Yeah, guys, nice job.
Здравствуйте.
Hello. You don't have to talk about baseline. We really like the problem. I think those who worked on this problem really did a great job. Yeah, these guys were about to be fired, and you saved them. Yeah. Very multifaceted task, labeling, application, the model itself. But that was very exciting, and we did we did a good job. Yeah, well, second place. Why is 42, by the way? I don't know. Just selected it, you know, just we had to think about something, some name. We didn't even discuss it, like we thought like, okay, 42, whatever. Yeah, next year we will have, what, 43 or 41, depending on how you count. But anyway, you're in school, you're studying in school, yeah. School of Letov. Okay. I know only positive things about Letov School. Just called the founder. Like to thank Evgenia Ankudinovna and Yelena. Thank you. These are our information technology teachers. I would also like to thank all the other teachers, and please put some good grades for us. Okay, yeah, that works, I guess. Yeah, thank you. We think that you will face many other great challenges. 0 I'm Andrei Grobin and Dmitry Spirchen and Alexander Povarov. I'm sorry, Dmitry Alexutkin. 0, that's the name of the team, and 1 million rubles first prize. Yep, guys did a fantastic job. 1 million rubles. What do you want to say? It was a very challenging task that required a lot of work, but we had vacations, so that saved us. How many submits? That was unforgettable. I remember every submit at 4 a.m. on 2 hours before we were submitting, before the closing, we were submitting the final solution. We had 10 submits per day, more than 100, I think. So we didn't even count. Well, 1 million divided by 100, 10,000 rubles for each submit. Yeah, sounds good. Do you need any help? Ah, okay, no, whatever. You have 1 million. Just go and enjoy the money. Yep. Congratulations to 0.
Задача development.
Development. Third place, Clio. Semyon Suslikov, Mikhail Vershinin, and Yegor Andreasyan, Vadim Vetrov. 400,000 rubles.
Ребята, привет. Здравствуйте.
Hi, everyone.
Здравствуйте.
Здравствуйте. Ну, рассказывайте.
Ну что рассказывать? Вот вы заговорили сегодня про бейс.
Well, you started to talk about the base today. I don't even remember whether we had a base at all.
То есть, хотя бы у вас было на чем тренировать модель или нет?
So, did you have anything to train the model on? We had data, pretty good data. There was one interesting thing that the data was standardized before our research, and we were seeing the price minus 1, price minus 1.7, but these are like small details. How did you circumvent that? We just used it as is. Yep, great work. What else can I say? And that's how you earn 400,000 rubles. I'd like to take this opportunity and thank Yuri Kalirenko, our mentor, who helped us and supported us. And just a huge thanks to you. Thank you. When you get that check, maybe it's not only the words of thanks that you can thank the person who helped you with. Clio was the name of the team.
Деньги держите, микрофон отдавайте.
Второе место.
The second place goes to No Fooling Around. Artyom Seleznov and Denis Dinmukhametov. And you are here with us today again. Yeah, we know each other. Yeah, last year we've been here. I don't expect any jokes from you. I'm not going to say any jokes because the name suggests no fooling around.
I really enjoyed the challenge, and I loved approaching this challenge from the point of view of various types of data. In our solution, we use different modalities, temporal, tables, graphs, diagrams. So this was indeed an applied problem with applied value. Hopefully our solution will be of value. I really hope so too. And I also wanted to thank Gleb Bondarchuk, our teacher. A teacher is always good. Thank you very much. The money is yours. Jokes aside. Why no jokes, by the way? Well, that was interesting. We tried 3 different names for our team. Sorry, you got your money taken away from you. That often happens. A young girl comes up to you and takes all your money. It should be the other way around. So we tried 3 different names for our team with some background, and the organizers didn't like those names, so we ended up with our current name. We are just called No Jokes, jokes aside. Congratulations.
Приколов, еще раз ваши аплодисменты. Чек забрали.
The applause is yours, the money is yours, and now the gold medal, 1 million rubles, go to ML Shariki 2.0. Matvey Belyaev, Andrei Alyokhin, Artem Goncharov. We're looking forward to seeing you on this stage. This prize is yours. Well, you're experienced winners. You've won all kinds of Olympiads and hackathons. A bit closer to the edge.
Ну что, сложно было выигрывать?
So was it challenging? It was. The case was very difficult and very interesting. In our solution, we used an ensemble of 4 models built on different types of data. We used tables provided by the organizers, and we also passed diagrams, and we also looked at time sequences. So it was an ensemble of models, and the final solution was when we combine all those 2 models and do the post-processing. Sounds like a DIY manual, you know. Thanks. Thanks, guys. Congratulations. Great job. You wanted to add something? Yes, I wanted to thank my school teacher, my math teacher from school, Irina Nikitienko. Yes, I also wanted to thank my own teacher, Maxim Kirilenko. Thank you for having so much confidence in me, and thank you for being by my side. I'm happy to have you in my life. Can I make a selfie with you? Sure. But why me? Do a selfie with the check. If you want to make a selfie with Mr. Vedyahin, if that's your goal, well, it's ambitious enough. Let's not shy away from its ambitiousness. Thank you, congratulations, and hope to see you back next year. A round of applause. You are an inspiration to all of us. Despite being so young, the participants successfully tackled so many challenges, and it's evidence of the fact that the young talents are good successors of the older talents. This is the future of AI for all of us. Alexander, the floor is yours for the final closing remarks. Thank you, guys. You have done a tremendous job. You solved challenges that are not for the faint of heart. You made good money out of it, and you are indeed an inspiration to all of us and to the younger generations who hopefully will also venture into AI. And next, I am sure there are a lot of research centers and industry partners who will be happy to have you on board. I am on the supervisory board of, I'm the chair of the supervisory board of the AI Alliance, and we will be happy to see you in all companies of the Alliance and just generally in all companies across Russia, because people like you will be driving our country forward. Thank you very much, and congratulations to all of you. Thank you, and now I would like to invite to the stage all of the winners. If you'd like to make a selfie with Mr. Vedyahin, this is an opportunity for you. Please welcome back to the stage all of the winners for a group photo. Maxim, will you join us? Maxim Yeremenko. The absence of baseline, that's on him. Maxim Ivan Ivan, join us as well, please. you may find your future colleagues here, your future team members among the winners.
Еще не было ни одной фотографии, где меня не видно.
Don't worry, there's not a single group photo where I am not visible. Maxim, come on, stand up.
И вокруг меня снова выстроились коллеги из Сбера.
And once again, around me are colleagues from Sber.
Красиво.
Let me stand with the young talents, please.
Так, вас так мало видно за оселедцем. Возможно, будущий ваш научный руководитель затмил вас, да. Иван, пропусти молодые таланты.
Ivan, I think you are hiding some of the young talents behind your back. A roaring round of applause to all of the winners. Once again, congratulations to all of you. Your work, your achievements are inspiring. They deserve applause and admiration. Thank you very much, and we wish you every success.
Чек вложить. Не надо меня чеками складывать.
Ваши все-таки.
Это ваше уже. Я не имею. Это все теперь уже.
No, those checks are yours. They belong to you now. Our 3-day journey into the world of artificial intelligence has come to its end. Over this time, we have made significant progress into the future. We got hundreds of insights, and we learned about 1,001 ways in which AI will help people make this world better. Looking forward to welcome you at AI Journey in 2025.